Every day, every night, everywhere. People are living on the streets. We see it. We all know it's a problem. But what can we do? In Brisbane, Australia, two young mates decided to do something. They would start small. They decided not to call them homeless. They would call them friends. Then, they outfitted a van with a washer, dryer and a shower and hit the streets of Brisbane to wash their friends' clothes. Orange Sky was born. One van quickly became 2, then 4, then 20. The operation, staff, logistics needed to scale and quickly. So Orange Sky found a partner. Cisco tailored a Meraki network that can grow as they grow. Intuitive dashboards at the head office and robust Wi-Fi in every vehicle let Orange Sky monitor vans and onboard devices remotely via the cloud. Cisco WebEx connects leaders in real time with staff and volunteers, whose energy and enthusiasm is essential to the model's success. What happened? Something wonderful. While friends waited for their clothes to wash and dry, they talked. A simple connection, joining a community, perhaps for the first time in years. If one load of laundry can do that, who knows what's possible? Between cleaning clothes and creating a community, there's a bridge. Cisco, the bridge to possible.
Running makes me feel happy. My favorite part about cross country is like the mental part. I'm Max. When I was 11 years old, I was diagnosed with aplastic anemia, and if I didn't find a donor, I probably wouldn't be here right now.
I'm Dylan and I'm 22. 3 years ago, I joined the registry at Be The Match. It was simple, just swab your mouth and send it in.
Be The Match is a global database of donors. To save more lives, they needed to make more matches. So they consulted with technology integrator E+. The solution? Cloud-based management made possible by Cisco UCS. Now, Be The Match team members use Cisco WebEx and Contact Center to collaborate with patients, donors, and their critical courier network. And their data is secure, protected by Cisco Umbrella Security.
Knowing what Max had to go through, what I had to do was easy.
One person in the world was a match to me. It was pretty special.
The Cisco network allows Be The Match to make matches faster than ever. And that's just the start of what's possible.
I am excited to meet Max. I don't think he knows it yet, but he's always gonna have a #1 fan.
Me and Dylan are DNA twins. Dylan's like my brother.
Between a life-threatening disease and a life-altering donation, there's a bridge. Cisco, the bridge to possible.
April 16th, 2018. This is Tokyo. This is Rakuten. These are Cisco executives invited to a meeting with Rakuten. This is Tarek Amin, CTO of Rakuten Mobile. This is Prakash Suthar, team leader from Cisco Customer Experience.
Namaskar. Good morning.
This is a story about doing something that's never been done before.
Prakash, I need someone to help me build the world's first end-to-end cloud-native network. We need a partner.
Let's do it.
In order for this to work, it has to be optimized for 5G.
We'll design it from scratch.
Fully automated.
Fully virtualized.
Cloud.
Core.
Transport.
Virtual RAN.
Everything. It will be the first of its kind.
Oh, yeah.
You can figure it out?
We can figure it out.
This is their idea. It's an ambitious idea. An unprecedented idea.
It's true.
But this is what industry executives called it.
Impossible. Impossible.
But that didn't stop them. That just made them hungry.
So Prakash, how about developers?
We'll create a platform.
Different systems.
Different partners
Working together.
What else?
This is the plane that took the Rakuten team to San Jose.
Okay, so it takes 3 weeks to implement a traditional radio site.
With automation, we can do it in 10 minutes. And more secure.
Zero touch.
Zero defect.
Ready for 5G.
Just upgrade the software.
This is Tarek's impressed face. This went on for months.
We're going to need new hardware.
Then we'll partner with your vendor.
But our design?
You got it.
Then Tarek said,
And we want you to manage the whole chain, oversee the integration of vendors and partners.
We're on it.
February 3rd, 2019. This is Rakuten and Cisco and their impossible idea making their first call.
Oh my God.
And the world just changed. Rakuten and Cisco customer experience. The right solutions, the right technology. Most importantly, the right people. Between ideas and invention, there's a bridge. Cisco, the bridge to possible.
Growing up, I always wanted to be helpful. I was inspired by my mother and how she helped my community. My mom would cook a lot of Syrian food. One day, she asked my brother and me to deliver meals to our neighbors in need. She taught me that when you help others, anything is possible. Even leaving my country to pursue a degree. When I landed, I was shocked to see the level of poverty. I thought, how could such a wealthy country waste so much food when so many people are worried about their next meal? I heard my mother in my ear, and I knew what I needed to do. I started taking surplus food that would otherwise be thrown away and giving it to those who would benefit from it. I could see the tremendous impact right away. I recruited some smart students, and with Cisco's help, we were able to build an automated platform to connect food donors to communities with food insecurity. Not only are we putting good food to use, but also can track the positive impact on the environment. With sharing Cisco's purpose to power an inclusive future, we've been able to provide over 2 million meals across the US. My mother is my real hero. She taught me that a delivery so small could one day deliver on something so much bigger.
Between a small gesture and a huge impact, there's a bridge.
My name is Uwais Iqbal. This is my 13th year working at Cisco. I have the honor of leading the systems engineering team based out of Canada, but I was born in Karachi. Then I moved to Canada in 2000. Then I started engaging myself within my own community, which is the Canadians of Pakistani origin community. This is where I met with Daniel Mark. That was very moving for me. He's the French-Canadian who moved to Pakistan about 30 years ago to serve the deaf community. These kids, even their cousins, people around them, they won't talk to them because they think that they don't understand, they cannot connect with anything. So then I started using my influence in my community to get this story out. We were able to raise 200,000 Canadian dollars to support these children. Now when the kids are going to deaf reach school, they're learning the sign language, they have more understanding of the world, they know how to use technology. So far we have placed 8,000 people to different workplaces. If you start doing something small within your own community, the easiest thing is look around you who is in need. Once you take the first step, believe me, you will see that one door will open another door, and then there's so much that you can do that you will never stop yourself, that you're not just living life for yourself, you gotta always think beyond yourself.
Between a life in silence and one full of opportunity, there's Uwais Iqbal.
My name is Casey Shemansky, and I am a content editor for our talent brand team. In 2004, my younger sister Kelly passed away unexpectedly. Obviously, it was a very difficult time for me and my family, but we came together, we realized we wanted to give back. I think what makes me want to take action is a big part of my upbringing. I think a lot of that comes from being a first responder family, and when others are running out to safety, my family was always running in. In 2011, St. Baldrick's found me. The St. Baldrick's Foundation started with a bunch of first responders, and it kind of became a challenge between them, and it was if you raise X amount, you'll shave your head and you'll go bald. And now they're the second largest private funder of children's cancer research in the United States. It pulls at your heartstrings and it gives us purpose. I would love Cisco employees to join me. I would love to have more bald heads on campus and on our WebEx calls. My sister, I think she's proud. I think she's up in the stars and smiling down and just proud as heck that we've all kind of come together, and this is her legacy.
Between a family's loss and the fight for a cure, there's Casey Szymanski.
If we're to build a bridge to an inclusive future, then getting healthcare to everyone, everywhere is critical. Take rural Europe, where local doctors leaving for big cities is creating a medical desert. For patients left behind, many lack the mobility or the flexibility to reach critical urban appointments. The remedy, it turns out, is as much a technological marvel as it is a medical one. Meet Medibus, a state-of-the-art clinic on 4 wheels. But designing such a wonder came with its own set of challenges, taking everything Cisco knows about mobility, connectivity, video conferencing, and security into account, and, together with partner Deutsche Bahn, dispatching it from the cloud to create a 21st century lifeline. Now, no area is too remote, no diagnosis or specialist unavailable. All because one company dared to wonder if the road to better healthcare could literally be the road that runs through town. That's the inclusive future. Cisco, the bridge to possible.
Good afternoon, ladies and gentlemen. I'd like to welcome everyone to the marriage between Rebecca and Cameron. In the presence of this company, it gives me great pleasure to declare you're now legally husband and wife. Cameron, you may now kiss the bride.
Between being there and being together, there's a bridge. Cisco, the bridge to possible.
There's a world where every one of us is connected. Everyone. Everywhere. Where everyone is included. Where everyone has access to information, education, opportunity.
There's so much out there. I'm going.
There's a world where buildings are smarter, where automation fuels productivity. And our planet's health is as important as our own. There's a world where everyone is invited to participate, to contribute, to be bold. When everyone and everything is connected,
that's really beautiful.
Anything is possible.
Good morning.
Cisco, the bridge to possible.
Good to see you.
I know, right? Finally. Loving those shoes. Late for my meeting. Morning.
Hey, how are you?
Let me show you. Q3 numbers are suggested.
Tracer, best player.
Who stole my lunch?
Good morning.
The company we've trusted to keep us working remotely is the same company we'll trust to bring us back together. Back safely, with features like density monitoring to keep everyone properly distanced. Back securely, with more resilient, more robust protection to block threats faster.
WebEx, start the meeting.
And back responsibly, with touchless technology that connects everyone. So now, between a year of being apart and the joy of coming back together, there's a bridge. Cisco, the bridge to possible.
Okay, everyone, let's get started.
The magical power of the realm is a mystery. Like a guardian, it is with you always. Defending you, charging you, watching over you like Actually, it's not magic. It's this Cisco network. The power behind every gank, every combo, every mind-blowing moment at League of Legends Esports, MSI 2021.
Your cloud. It isn't just a cloud. It's everything flowing through it. It's alive. Connecting users, applications, data, and devices. And whether it's cloud native, hybrid, or multi-cloud, it's more distributed than ever. One company takes you inside, giving you the visibility and the insight you need to take action. One company has the vision to understand it all, the experience to securely connect it all, on any platform, in any environment. So you can work wherever work takes you. In a cloud-first world, between your cloud and being cloud smart, there's a bridge. Cisco, the bridge to possible.
Hi guys, I'm Chris. How are you everybody? I'm so happy to be here. I'm so happy to see people.
We've managed to be in school this year, but we've worn masks. But we've had 100 of our students choose to go virtually.
I mean, most of you are in what I would describe as the most difficult years of your life, as far as I can tell. Oh yeah, okay, great. How you doing, man? Do you have a question?
What age did you start doing music?
I was 11, actually. And we had a teacher at my school. He encouraged me to try and write a piece of music. In my dream planet, teachers are respected like pop stars, and no tax money is spent on arms. What do you want to do, Trennis?
I think about becoming like a country singer. That's like my main dream. Realistically, I kind of want to become something in the medical field.
That's amazing, but that's no more or less realistic than being a musician. I'm real and I'm right here. Do any of you write songs? Is this you? Yes, it is.
Yes,
That's wonderful. Well done. You don't get anywhere unless you put yourself out there, you know what I mean? Do you want me to play anything for you?
Can you do Yellow?
Look at the stars. Look how they shine for you. And all the things you do. Yeah, they were all yellow. Your skin, oh yeah, your skin burns. Turn to something beautiful. And you know I love you so. You know I love you so. This week it's been such a pleasure to be working with Cisco, talking to students and teachers from all around the world. I want to say thank you to all of you for being inspiring and wonderful. Thank you for all you do.
Where will you be in 5 years? Where will we be in 5 years? In 25? In 50? Let's be here and here, with her and him and they. Let's connect them. Let's connect everyone. Let's deliver technology that gives them access to power opportunity. Let's set a new standard for data security and personal privacy. Let's change the system. Promote equality and fairness in the workplace. Let's tear down the barriers to social justice for a more inclusive world. Let's clean house, zero carbon, zero waste. Because the health of our family is tied to the future of our home. Let's gather resources and partners, steer toward our greatest challenges and accelerate. For the benefit, for all. Cisco has made it its purpose to power an inclusive future for all. Where will we be in 50 years? Let's go see. Cisco, the bridge to possible.
Hello, and welcome back to DevNet Create.
I'm Grace Francisco, VP of Developer Relations, Strategy, and Experience at Cisco. We're thrilled to have you rejoin us for day 2. And wow, for those of you who were with us yesterday, we had an awesome day, and we hope you enjoyed it as well. One of the things I love about DevNet Create is that it focuses on the creations from this community. From the keynote to DevNet Creator Awards to the Demo Jam, we got to see the incredible things you've all been building. Across 4 channels we hosted in day 1, there was so much opportunity to learn. On the main channel, we were able to cover shift left security and customer-centric design. On the creators channel, we had great community-led sessions with topics covering serverless, user experience, and time series data. In APIs in Action, we heard about a variety of Cisco platform opportunities such as QA test build automation, mobile app security, as well as API clarity. And in Start Now, we had great introductory content to get people started in a variety of areas such as best practices with documentation, a basic introduction to Kubernetes, and tips for avoiding the pitfalls of IAC. Whatever your interests, there was a channel for you at DevNet Create. And I'm so glad you're back with us today. In the keynote yesterday, I said community is a continuum of technologists and that you are agents of change. Everything I saw in the sessions from day 1 demonstrate that. I see a group that is eager to learn everything you can, hungry to build new skills, and powered by creativity. Day 2 promises to be just as engaging. Today we have 3 channels of content built for you. From observability to machine learning, edge data processing to cloud-native security. Find the full agenda at developer.cisco.com/devnetcreate. And remember that this is an event for you to connect and collaborate. Remember to use our Q&A panel to engage with presenters and experts. You can also find us on social media channels using #DevNet and #DevNetCreate. Also new this year at Create, we are proud to be able to offer the DevNet Create Bright Fund. Through this fund, we can act as a single community to promote diversity in STEM and support the fight to end racism and discrimination through global education. Join us for today's closing keynote where I talk to a special guest on how we can continue to use tech for good. And with that, let's kick off DevNet Create Day 2. Wherever you are in the world, now is the time to find the sessions that connect with your interests and dive on in. And more than anything else, have fun, collaborate, connect, and create. See you again at the end of day 2.
Hi, and welcome to Apache NiFi 101, No More Spaghetti Flows. I'm Timothy Span, developer advocate at Stream Native. And my background is in streaming programming, things like Pulsar, Flink, NiFi, Spark, IoT, different technologies, but you'll see today, we're going to cover one part of what's known as the flip or flip and stack, which is a combination of several open source softwares, Apache Flink, Apache Pulsar, the connection between Flink and Pulsar, and Apache NiFi. All these are great ways to do streaming, but today we're going to focus on Apache NiFi, which is a way you can grab data from things like Pulsar, connect data to Flink, and it's just one thing that you can use to connect to something like Stream Native, which lets you get your data from wherever it needs to be to any other place in real time in any cloud. These are things you need to do. Today, we're going to show you how to do that with different types of data. Now, there's a lot of different types of data out there. Obviously, you've experienced using a database, maybe use MongoDB or other NoSQL stores, maybe big data on Hadoop, maybe different cloud resources, maybe you have JSON or XML files, text files. A ton of different files, whether in logs, devices, coming off of applications. You have a lot of data and you're working with it different ways. One of the best ways to do that, and we'll show you that today, is using an open source project called Apache NiFi. It lets you either read or have push to all kinds of different data. And we'll show you some of the data in the demo. It's very easy to do. Very typically, once I have this data in a format that's clean enough, you got rid of the nulls, maybe I enhanced the data, enriched it with other sources. I'll push it to something like Pulsar so that it can be shared to other data stores, other applications, other consumers, or something like Flink, where I could do real-time analytics on that SQL. What's great about this is it doesn't matter what type of data, doesn't matter when I run it, doesn't matter where I run it. I can run it on a laptop, I can run it on an on-premise data store, I can run it in any of the clouds, use it with any type of data, any protocol. Makes it very straightforward to do what used to be really complex, difficult programming. Now is really straightforward and almost easy. And this is pretty much the standard flow if you're going to build an application, whether it's ETL, ELT, a streaming application. This is really the flow. And it doesn't get much easier than this 4-step process. You pick a data source. It could be a Pulsar topic. It could be a relational database. It could be a file, REST endpoint, anything from any of the cloud resources. NoSQL store, JMS, all these different message queues and networks. So you'll get these data sources. Easiest to start with one. I grab, say, a file from a file system, then I'm going to validate it, do any kind of conversions, enrichment, check against schemas, get it in a format that's, ready to transport. And then sometimes I'll aggregate that or maybe drop some of the fields out. That's kind of an optional step. Then get it somewhere. Often it's not the final destination. Could be into another Pulsar topic cleaned up. Could be in the final database, S3, wherever it needs to be. And that could be multiple places. I might have one source go to 20 sinks or 20 sources go to one sink. Any combination thereof, but we think of it in a simple flow as the data flows through the system, from point to point. And even if that's spanning multiple clouds, even if it's petabytes of data, it's easy to run. What's nice under the covers, the architecture is pretty straightforward, but it's exactly what you need if you're building a clustered streaming system. You have a server, you have at least one. In any kind of production environment, you're going to have 3, 5 clustered applications. Now I find that the covers is a Java application, presents itself with a web server. It has different Java processes to control all those little controls on the screen. And it keeps a cache of files in a couple different repositories based on their uses. One is for the raw data. One is for the valuable content in there in whatever format it's in now. And another is a provenance repository for all the lineage, everything you've done to it. So you've got that record of everything you've done. And then we have Zookeeper to make sure the cluster is running properly, things are coordinated, messages are distributed evenly. And if you need something to run on only one node, we run it with the primary, very easy to do. Everything is shown to you in the UI, as well as through a command line interface and REST endpoints. I mentioned a little of the things there. One important thing to think about is a flow file. This is whatever is coming into the system. This could be one line from a log file. It could be a whole zip file. It could be one record from a database, 1,000 records from a database. So we have this flow file of your actual data, which if you don't want to change it, you don't have to. And then metadata around it, we call attributes. You can add and change these at will without affecting that data, in case you have requirements there that you don't touch the data. Now, it's pretty straightforward, but because of its flexibility, people can do things that make applications processing slow, difficult, or say, hey, I don't want to use NiFi. It's not doing things I don't expect. It's running too slow. I call them spaghetti flows. You don't want to do them. There's a lot of different things that you shouldn't do that I've seen Don't put 1,000 different applications in one workspace on one small server. You are not going to be happy. Don't have too many steps. If it takes hundreds of steps to do something, maybe you should move it to another system. Maybe NiFi, you should just do the pre-processing. Maybe it should be partially handled elsewhere. Maybe it should be a Flink app. Maybe it should be a Pulsar function. Too many steps, something might be wrong. Try not to execute third-party executables or scripts or Python. If it needs to be running those, maybe you should connect that through Pulsar functions or through some other means. Executing things has got a lot of overhead. You're running a full process. That's heavyweight. Make sure you use code that you understand. If you found it on the internet, it's not documented, it might not work. Make sure you get official ones or ones from me. I have really good processors if you need them. Make sure you upgrade. It's pretty common sense, but if you're running old code, it might run slow, might not have all the best features. Don't do it. Make sure you have enough RAM. By default, they only give you half a gig. That can't do much. Make sure you put this on a 32 gig machine. Use 16 of them. Use as much RAM as you can get, as many cores as you can. If I have 16 or 32 cores, 32, 64 gig of RAM, I can process, 1,000,000 records. It's great. Try not to do things that you wouldn't want to do in a little file. Like you have 1,000,000 record file. You think you could process that all at once? Well, that might all have to go into RAM. So think about it. But if you do split things, splitting can be painful because now, instead of running one activity, you're running as many as you split into. So if it was one item and you split it into 1,000 sub items, now I'm processing 1,000 things, which may be good, maybe not, something to think about. But there are things you can do to get rid of these spaghetti, get things running better. Reduce things, use less. It's like in the real world. Try to recycle, reuse components, use parameters so you can reuse things, make reusable chunks. Write a custom processor in Java if you're doing something that would take 20 steps. It'll be faster in one place. And then, custom Java code. Or if you already have a library, reuse it. Make sure you use the documents. There's a ton of documents to tell you what to do, a ton of articles I've written. Go with the best practices. If you have data that looks like it came out of a table, CSV, Avro, JSON, XML, use the record processors. They're faster. They're easy to work with. There's no downside to using them. Please use the record processors. It'll save you headaches, save you memory, RAM, much faster. Go that way. Use version control. Things crash. Maybe you lose your code. You don't want that. Make sure you always check in your things to version control and have that registry backed up. Use DevOps in the command line. Make sure before you move to different servers, makes it easy and automatable. You want things repeatable, documented, and automated. Now, when you're running stuff in production, make sure that you keep things isolated. A dedicated server for your NiFi nodes in the cluster and dedicated nodes for Zookeeper will give you the best performance possible. I would say if you need to, make sure if you're connecting to a database, you get the approved driver, the approved version, the latest ones that are tested, ones that work with your version of Java. NiFi can run in 1.8 and 1.11. I recommend 1.11. Use a good solid JVM with all the bug patches. Don't do things that you wouldn't do for any other application. Now, the next part of our system, I said we often push it to Pulsar. It's a great way to make sure you never lose data. I get it into a message queue. Other people can work on the data. It's never lost. Get it into Pulsar. Pulsar will geo-replicate. Let me run functions in case I need to move some of those apps. Horizontally scales, has tiered storage, all the DevOps tools you need, and support for multiple protocols. Maybe you don't want to use native Pulsar. Maybe you have MQTT. Maybe you have Kafka, JMS. Pulsar will act as if it was one of the brokers in that type of messaging system. So then you have that flexibility that it doesn't matter. It gives you a strength that you won't find elsewhere. But I talked about it. I've gone through some of the definitions and the terms so you have an idea what's going on. But I think the only way for you to really understand this is to see a full demo. So let's go into the demo and then we could see, what exactly I was talking about and doing in the real world. First, once you log in, you'll start off with a blank canvas. I have a number of applications here. All these separate little applications are process groups. If you right click on it, you can see a lot of options. I can configure it, give it a name, connect it to parameters. We talked about parameters, very important, but you reuse values, isolate them from your code. You'd also do things like set back pressure for the entire subset of technology in there. You could also set different controllers or connection pools here. You could see which ones you could start them, stop them, add new ones. Pretty straightforward. Then you put in your parameters. These will all be available for everything inside that. And I could do something like stop them all. You could see what you can do here. Disable it. If you're not going to use it, stop it and disable it. Uses 0 resources. Great tip for you. If you have some data waiting in a queue and you want to get rid of it, just empty all the queues. You could do that from the top. You can see what's going on from the top if anything's happened in the last 5 minutes. Good way to see what's going on. Now, if there's any kind of bugs, they'll show up in this little corner here. If you go to the hamburger menu, you could see that on your bulletin board. This is where any errors or warnings will show up. These are also available from the command line tool or the REST API. If you see in that hamburger menu, we also have other things like which version of NiFi with the about. Summary tells you everything going on. This is a great way to know, what's running, what's stopped, what might have, a lot of writes going on. Is there anything sitting in a queue going in or out of NiFi? Any connections you might have that have a lot of data in them. Here you can see we've got some sitting in here in one of these processes. And I can go right there with the arrow. Very easy to navigate. And I can, again, right click anywhere. Gives you what you can do where you are. Like here, I could download this whole set of source code. Could stop things. You get the idea. If I right click something here, I can't change it because it's running. To change something, I have to stop it. For a queue, I have to stop both sides. And here there's a couple options here. I could take a look and see what this data is. This is part of a book. And you could see some different text there. That's provenance. Lets me see what's going on. I could also change this queue. If you're going to be using it for things, you might want to name it so you could uniquely identify it and be able to find it in any kind of reporting. Here I could set a load balance strategy if I have multiple nodes. Round robin's a good one. I can compress it if it needs to move things around. I could set priority. So in case there's 2 different kinds of data coming in, maybe the data that's always loaded and an alert, I could prioritize that with an attribute. Pretty easy. So I stopped it. You can see data's backing up. I can see what I've processed recently and the date, what's happened. It said it changed some attributes. I could see which ones changed. And it's these that set a content type. I can look at the old content, new content, and I can go right where I need to be there. I can see what this changes. Let's just check changing a content type. Not a big deal. It depends on things I need to change within NiFi. This one is an interesting one because this is one of the record readers. So I could pick which kind of reader it is. And I could do that dynamically with the reader lookup. So if I don't know what the data is, but I can infer it, I could do that. Since this is the one for queries, I can write any number of queries here, looking at any of the fields, output it to something else, use a limited set of fields, As you see, when something stopped, it just queues up for you. And here it's queuing up this into Apache Solar, just to give you an idea. Very easy in NiFi to navigate here down the bottom, or to search for something. If I'm looking for, everywhere I use the word pulsar, I could see where it is and jump right there. Very helpful. I say, oh, this one's not started. I gotta set the controller. Very easy. Well, I hope you enjoyed the demo. I think it's mentioned everything that I talked about, and it really solves those issues that we had when we talked in the beginning. You saw how easy it is to use NiFi. There's more things that you'll need to do. I've linked all the articles to get you started, the best content out there, best practices, demos, examples. Everything is ready for you. So just connect with me on Twitter, on LinkedIn if you have any more questions. Enjoy the rest of the talks here. It's an amazing conference. Thank you for coming to my talk. And if you want some free stuff, I got some free books that you could download. So click away. Thank you.
Hey everybody, welcome back to day 2 of DevNet Create. It is really awesome to be here. We had such a fun time yesterday, and I know we're going to have a blast today. My name is Jeff Bull. I'm a developer advocacy manager for Cisco DevNet, and really looking forward to all the channels today. So we've got 3 channels going. You're here on the main channel. Clearly, it's the amazing one, but there's 2 others. We've got the APIs in action and the creator channel today. It's going to be a lot of fun. But before I get too much more into the details for the day, I want to hand it to Denise to talk a bit about yesterday.
Hey, I'm Denise. I am the software engineer in the developer success team. If you want to hit me up, go to Denise T. Kwan at Twitter and tell me about your day yesterday or even today. As Jeff said, we do have 3 channels, which is a little bit different from yesterday. Something that I'm looking forward to for today is the introduction to API clarity. That session seems really cool. On the creators channel, I saw one that's called, so you want to make an SDK. I mean, SDKs, everybody wants to, build, but then they sometimes don't know. So let's take a look at that one. And then in the APIs in action, there's an interesting one that I saw, building a troubleshooting assistant. I had a great time yesterday, and we're going to have a blast today. Eric, why don't you introduce yourself?
Hey everyone, I'm back again as well. Eric Thiel, I lead developer experience for Cisco, and I'm glad to be back all day today. I was just here in the morning yesterday, I know, but there was so much great stuff I was watching all day yesterday. Thank you all for all your submissions and contributions. Thanks for all the dialogue that we're having in the Q&A and the chats. It's been great hearing what people are liking and enjoying out of the session, what they're finding value in. So please keep that up. Today, again, we are running the challenge, the Secure Code Warrior Challenge that we partnered with them for, called Devi Defend. So if you haven't checked it out yet, I encourage you to do so. Because security is one of our main themes for this event, we wanted to make sure we're helping you all find great ways to build security into your code. And that challenge will help you. And the leaders will actually go on to a final round then, where you can actually win some cool prizes. So great opportunity there to participate, try out your skills, put a little bit of this in action that you've been hearing about. Like Denise, I'm really looking forward to the API clarity talk in particular, because it's so many people developing APIs struggle to understand even what's going on after if they haven't fully documented it. So I think it's a great way to really capture that and understand the nuances. So I'm looking forward to that session. I'm looking forward to the regional segment where we hear from you all across the Americas and what you've been doing over the past year. And then last, we're ending with a great session with a special guest that is going to talk about how you can help with Tech for Good and engage in your local communities. Jeff, back to you.
Awesome. Thanks, Eric. And thanks, Denise. It's really awesome to have both of you with me for the entire day today. It's going to be a lot of fun. So just a reminder for everyone, you can find me on all the socials at Jeff Bull Tech. So while you're out there on Twitter, LinkedIn, Facebook, anywhere you want, ask questions, chime in with us, say hi, be part of the conversation. It's gonna be a lot of fun. And if you're already on those social networks, you can also join with everybody else. Hashtag DevNet and hashtag DevNet Create. That's where you're gonna find all the chats. And while you're in the browser window watching sessions, on the right-hand side, you're gonna see the Q&A panel. Just drop your questions in there. There's live folks in the back end who are gonna answer those for you and get you whatever you need. And then right at the bottom, you're gonna see a big blue button that says join the channel. You can click on that, you'll get WebEx, and you'll get part of the conversation live with everybody else who's attending, which is super cool. So next up, we've got Ash from Styra. He's gonna be talking about the open policy agent, which I'm really excited about because it talks about decoupling policy decisions from enforcement, which I think is super helpful for the benefit of security within applications and everything that we do. So we're looking forward to that. We'll see you back here right after that episode. Okay, don't go anywhere.
Hi, thank you for joining us for this talk on the future of policy enforcement, decoupled and distributed. My name is Ash Narkar. I am a software engineer at Styra, and I'm one of the maintainers of the Open Policy Agent. I care about developing software that can be readily deployed, scaled, managed, and is secure by default. In today's presentation, we'll talk about the policy enforcement problem. We'll learn about the Open Policy Agent, look at its features and use cases. So let's get started. If you look at the cloud-native landscape, it's constantly evolving. You have new projects being added every single day. It may be a new database, it may be a new API gateway, a new service mesh, and so on. And so if you're developing a system which comprises of all these different projects, you're going to have a lot of moving parts in your system. If we talk about security, specifically authorization, for such a diverse system, you can imagine each of these projects written in a different programming language. Each of them have their own special way of controlling access, which may be tied to the underlying system. And what ends up happening is you have no visibility into the security posture of your diverse system. Even from a flexibility point of view, if say tomorrow you wanted to swap out your service mesh, you now have to spend both time and money to recreate those same policies to conform to your new platform. And you might say, we'll just use docs and wikis and just write these policies down somewhere and enforce them that way. That's fine until you have tens, hundreds, or even thousands of microservices, and this wiki approach is no longer sustainable. So what we need is a unified way to control access across all these diverse systems in a highly performant manner. And this was one of the motivations behind creating the Open Policy Agent. So, what is the Open Policy Agent? OPA is an open source general purpose policy engine. When you use OPA, you are decoupling the policy enforcement from the policy decision making, so your services can now offload policy decisions to OPA by executing a query. We'll understand this concept a little more, but before we do that, let's quickly talk about OPA's community. The project was started in 2016, and the goal of the project has been to unify policy enforcement across the stack. One of the earliest adopters of OPA was Netflix, and they've been using OPA for authorization over their gRPC and HTTP APIs. And companies like Chef, Medallia, Capital One, Yelp, and many, many more are using OPA in production for a variety of use cases such as RBAC, ABAC, admission control, data protection, and so on. For those of you all that follow the CNCF, OPA is a graduated project with more than 150 contributors on Git. It has a healthy Slack community of more than 4,000 Slack members. It's been starred more than 5,000 times on GitHub, and it's integrated with more than 20 of the most famous open source projects out there, some of which we'll see later on. So this was an overview of OPA's community. Now let's try to understand how OPA actually works. So like I mentioned before, it's an open source general purpose policy engine. Imagine you have a service. Now this can be any service at all. It can be your own custom service, an API gateway, a Kubernetes admission control API server, any service at all. Whenever your service gets a request, it's going to ask OPA for a policy decision by executing a query. OPA is going to evaluate this query based on the policy and the data it has access to and send a decision back to your service where it gets enforced. So you can see that we have decoupled the policy enforcement from the policy decision making. The policy query itself can be any JSON value. So for example, if you're doing HTTP API authorization, this policy query could include your request path, your method, your headers, your user, anything at all. Or if you're doing Kubernetes admission control, this policy query could include the pod manifest, for example. The policy decision itself can also be any JSON value, and then it's up to your service how to interpret that decision. So this was a high-level overview of how OPA enables you to decouple the policy decision-making from the policy enforcement. Now, let's look at some of OPA's features. At the core of OPA is a high-level declarative language called as Rego. And with Rego, you can write policies which are more than allow, deny, true, false, yes, no. Your policies can be strings, sets, objects, basically collection of values. So it's very expressive in terms of the policy decisions you can author. So for example, OPA can help you answer the question, is Bob allowed to access a particular field? And OPA can also help you answer the question, which fields can Bob access? So it's very flexible and very powerful in terms of the policy decisions you can write. OPA is written in Go, and it's designed to be as lightweight as possible. So all the policies and all the data you need for evaluation are stored in memory. You can think of OPA as a host local cache for your policy decisions. You can deploy OPA as a sidecar, a host level daemon. You can embed it inside your Go code as a library. And now you can also compile Rego policies down to WASM executables and then use those to evaluate your queries and get a policy decision. OPA does not have any runtime dependencies, meaning to make a policy decision, OPA does not have to reach out to any external service or an external database. You can do that. You can optionally do that, but by default, it does not need any kind of external dependencies. OPA does provide you with some management APIs that allow you to pull policy and data from a remote server. OPA also uploads all the decisions that it makes to a remote server, which you can use for offline debugging and for audit purposes. And OPA can also upload its own status, its own health to a remote server as well. Finally, along with the core policy engine, OPA provides you with a rich set of tooling to unit test, to debug your policies. OPA provides you with a unit test framework which you can use to test your policies before you actually go and deploy them. There are integrations with IDEs like Vim, VS Code, IntelliJ, which allow you to author your policies too. And we also have a Rego Playground, which is an online interactive tool which helps you to author and share your policies. And we'll see the playground later in the presentation. So these were some of OPA's features: a high-level declarative language, multiple deployment models, management APIs for control and visibility, and a rich tooling set. So we saw this slide some time ago, and I said that OPA is a general purpose policy engine. The reason for that is OPA is not tied to any particular data model, meaning as long as you give OPA some kind of structured data and you write policies that make sense for that data, OPA will give a decision back to you. And hence, it's a general purpose policy engine. Another thing here is that this is just a snapshot of all the projects OPA is integrated with. There are much more which you can find out on the OPA website. And if you'd like to contribute to OPA, you can integrate it with your favorite project and have it featured on the OPA website. And one more thing, you can take any of these integrations out of the box, and without even having to write a single line of code, you can start enforcing custom policies in these systems using the Open Policy Agent. So we highly recommend you all try that. So now let's look at some of OPA's use cases. We look at the first one around Kubernetes admission control. So for those of you all that are not familiar with admission control, it's a piece of code that intercepts requests to your Kubernetes API server before those requests are persisted into etcd. So admission control is an amazing way to enhance the security profile of your Kubernetes cluster. And now you can use OPA as an admission controller to enforce some of the policies that you see on the screen. For example, you may not want your containers to grab images from public repositories. You may want them to only grab images from like your private repository or private registry. So you can enforce that using OPA. Or you may want your containers to specify CPU and memory limits and requests. You can enforce that with OPA as well. Or you may not want your containers to run in privileged mode. In fact, all of the pod security policies can easily be implemented using the Open Policy Agent. So to give you an idea of how admission control works, imagine you do something. And by something, I mean you do a kubectl create some pod. So whenever you execute this command, it's going to send out a request to OPA. And the input that OPA gets, it's this admission review object you see on the left. And this is a deeply nested structure. You can see it's a pod, it has some metadata, it has a list of containers and some other information as well. So this is the input that OPA gets. And now OPA has to make a decision, again, based on this input and the policy and data that you've provided to OPA, and send a decision back to the Kubernetes webhook. And you can see in this case, the admission response, which is the decision sent out by OPA, is not a simple Boolean yes, no. It is an object which not only tells you the decision that was made, but also explains what was that decision. In this case, bad image registry. So again, you can see the theme out here, wherein we have tried to decouple the policy enforcement, which is done by the webhook, versus the policy decision making, which is done by OPA. So you can see that decoupling happening in this example as well. What we'll now do is we'll see a live example of some Rego code, and we can see how we can interact with the Rego playground and how we can write some simple admission control rules. So what I have here is basically the Rego playground. You can see it's available at play.openpolicyagent.org. You can see some good syntax highlighting for your Rego code, which makes it very easy to debug and write your code as well. So the policy, you can see this is this pane to write policy. You can see there's one to provide the input and to get the output as well. So this is a very simple policy. And what we want to do is we want to make sure that every container inside your pod is specifying a CPU limit. So if you go down this policy, what we are doing is we are checking the resource, which is a pod. We then iterate over every container inside that pod, and we check if it specifies a CPU limit. And if it does not, we are going to return a violation. You can see the input like we saw on the slide. It's a deeply nested structure, which is a pod. It contains some containers, and you can see that there are two containers. One container is basically the Nginx container, which specifies the CPU and memory limit. And there's another container, which is the MySQL container, which does not specify any CPU or memory limits. And so now, if I evaluate this policy, we know that there is a violation out here because the MySQL container does not specify the limit. So if I click on evaluate, I get a violation saying that the container MySQL does not provide a CPU limit, which makes sense. Now let's say you wanted to extend this policy for memory limits. So you want to say that all your containers inside your pod should specify a memory limit. Now to do that, all you have to do is take the existing policy, and let's say we again look for the same kind, which is the pod. We will iterate over the containers inside that pod specification. And instead of looking at the CPU limit, let's say we look at the memory limit. And then if it does not specify the memory limit, what we'll do is we'll just update the message to say that the memory is missing. So there you go. So now, if I have typed everything correctly, we again see in the input that we have the Nginx container specifying both CPU memory, but the MySQL container specifies nothing. So if I evaluate this policy again, you should see that there are two violations instead of one. So let's see. There you go. So we can see that there are two violations with the MySQL container, one for missing the CPU limit, the other one for missing the memory limit. And now, since you've written your first Rego policy and you're super excited, you can share this policy by clicking the publish button, and you get this beautiful link which you can use, and then you can see your new policy and you can share this policy with friends and family. So in this way, in a very simple manner, you can write a very simple admission control policy that makes sure that containers specify both CPU and memory limits. So this is how you would use OPA as an admission controller to enhance the security profile of a Kubernetes cluster and enforce custom security policies. If you'd like to check out the demo policy, it's at this link. So play around with the Rego playground and share and write your policies in a very fairly easy manner. And there are a bunch of examples on the playground which you can use to get started as well. So thank you so much for joining us for this talk on the future of policy enforcement, decoupled and distributed. If you want to learn more about the Open Policy Agent, check out the OPA website. If you have any questions, you can join us on Slack. If you have any use cases to discuss, you can discuss them on Slack as well. And check out the code on GitHub. And if you like what you see, please do start the project. Again, thank you for joining us and sharing your time with us today. Thank you.
Hey, everybody. I'm super happy we were able to get through Ash's session, learning about the Open Policy Agent and sort of how to understand security impacts of a system or an application. And then more importantly, the idea of, like, especially in cloud native, decoupling those components so that enforcement and policy decisions can be moved off into other components. I think it's immensely helpful. It really makes it simpler and componentizes the work that you're doing when you're building that application. But we've got more to come, and I'll hand it over to Denise because we have some really amazing offers we want to reiterate for you.
Yeah, definitely. We have some great offers for DevNet Create attendees. Remember, this is for a limited time only, so definitely jump on these as soon as possible. It is 50% off of all the DevNet exams. That includes the core exam, which is needed for the DevNet expert certification. There is 40% off of the Cisco Press books. I know that there's one for the DevNet associate exam. And then 30% off of the DevNet Associate and Professional Instructor-Led Training. You can find all of the offers at cs.co/create21 offers. And there are more things over there for you to take a look at. And another thing is, if you want DevNet merch, you can head over to the Cisco store. The URL is the same as the offers. And we have Snack Minute merchandise, as well as t-shirts, hoodies, tumblers, stickers, and many more things. So, Jeff, what do we have next?
Yeah, thanks, Denise. Super excited. So our next session is by Rosemary Wong from HashiCorp. So she's going to be talking about securing things like infrastructure as code right from the get-go, like right from the beginning, and not just implementing security, but also automating that. I mean, that's what we're here about today, is programmability and automation, and making sure that we can automate things like security, testing, and all of that right from the beginning of our development process. So stay tuned, and we'll catch you back here right after that session wraps up.
Hello, welcome to Security Tests for Security Groups Shifted Left. I'm Rosemary Wong, a developer advocate at HashiCorp, and today I'm going to talk about something that's really near and dear to me, and that's how do you secure infrastructure as code by default? There's a really interesting problem we encounter quite often, and that's the application isn't working. Whenever we hear the statement, we get this nice sinking feeling, and we have to think about, well, how do we debug? And usually the first place we debug as network engineers or infrastructure engineers is the firewall. Is there a security group somehow blocking that traffic? Is there an endpoint security group, more specifically in Cisco ACI, that is allowing that traffic? We don't really know, and we have to go investigate. And once we investigate, we come across, well, a really interesting realization, and that's, oops, we forgot to add it. It's a common enough occurrence that when you try to make changes to your firewalls or security groups, they might be manual. You might do them once, allow that traffic, and forget about it. But when you use infrastructure as code, or you try to express the firewall and security groups as code, you have a way of automating and tracking those changes within your system. So today, I'm going to answer the question in about 5 minutes of how do you automatically synchronize your IP addresses from a service catalog to an endpoint security group and remove this manual worry. And that way you can avoid saying, oops, I forgot to add the security group. And more importantly, I'm going to answer the question of how you get a secure by default configuration when you do this automation. It's great that you can run some as code and automate those changes between your service catalog and your endpoint security group. But how do you make sure that's actually secure? How do you know someone didn't accidentally inject a misconfiguration into that security group? So the criteria we're going to try to fulfill today is that it must have a secure by default configuration. I picked a few good configurations that we should probably consider, including disabling flood and encapsulation, enforcing preferred policy control, and setting quality of service priority class. And we must have this fully automated. We don't want someone injecting bad infrastructure as code into this kind of automation, because that could be, well, insecure. So the solution I'll walk through today is how you do security testing for an endpoint security group as code, as well as how you automatically sync those services from catalog to Cisco ACI. So effectively, the end-to-end solution should be a secure infrastructure as code that automates a lot of this workflow for you, and you don't have to worry about its security or its functionality. Today, I'm going to be using a couple of tools. The first is an endpoint module for Terraform, and I'm also going to be using the tests that are written in PyTest. I'm also going to show a little bit of console Terraform sync, which synchronizes the service catalog in HashiCorp console using a Terraform module. So we're trying to do this automation as code and making sure it's as secure as possible. Let's get started with the demo. All right, so on the left side, you have my terminal, and on the right side, you have the service catalog in console. If you're not as familiar with console, that's all right. Console is a way that you can register services automatically, and it stores that information. The first time I run console Terraform sync, I'm synchronizing all of the services like web and API using Terraform to a Cisco ACI endpoint security group. You'll notice that my Terraform creates a web and an API endpoint security group, and it matches those IP addresses. So when I create that security group, it's creating a match expression on the IP address based on that service catalog. Underneath all of this is a module that I've specifically written that's custom for this automation. So when I add a new service like database, a new service like database automatically gets registered and its IP address then gets added to the Cisco endpoint security group. Now, all of this is to say that I'm not touching any of this. I don't have to go through and manually decide, okay, database is at a specific IP address, as you'll notice that I'm doing in console. I don't have to know that the database is at 10.5.0.6. Instead, console Terraform sync is picking up that change from console and doing it for me. Underneath all of this is a module. If you're not as familiar with Terraform, it's an infrastructure as code tool. The idea is that I'm able to declare the kinds of infrastructure resources I want and need to create with certain attributes. So within these attributes, I have a few things that I want to focus on. First is the flood on in cap as well as the priority. When I first plan out these changes in infrastructure, I can generate a dry run. This is basically something that tells me these are the changes you're planning to make. So when I run a Terraform plan out, Terraform show, I export my dry run capability to a JSON. The JSON, you can take a look, has a bunch of values in it. Some of these values are going to be useful and some of them are not. But we can use this dry run to test what attributes we need. And this is where security testing becomes important. In this dry run contains attributes and possible misconfigurations. I can pull in that JSON, parse it, such as using a plan values, etc., retrieve the security groups from that, and test specific attributes and configuration. I can test whether or not, let's say, flood on in cap is enabled or disabled before I even apply those changes to live infrastructure. Even quality of service, I can check if it's unspecified. I can also check if my policy control enforcement is added, and I can check what kind of match expression I added. So maybe someone wants to add a match expression that's not valid. I can test that too. So by shifting the test left, what I'm able to identify early is that someone forgot to put PC ENF pref. So they forgot to add policy control enforcement, which means someone actually can go in and add the correct configuration to this Terraform configuration and this Terraform module that's going to be automated. This makes it, in some ways, secure by default. I'm setting best practices as well as the knowledge very early on so someone can make the changes proactively, run these tests again, pass knowing that this configuration is secure by default. So anytime console Terraform sync runs the configuration, I know that it is secure by default. It's conforming to my organization's standards of the kinds of attributes that I need, and I can make sure that as it continues to run and I change it, it's continuously conformant. Well, that's the end of the demo. If you're interested in learning more, check out this code repository here. It has some additional resources on all of these tests, as well as console Terraform sync. And if you're interested in learning more about infrastructure as code and shifting security testing left, you're always welcome to reach out to me. Thank you.
Awesome. Thanks a lot, Rosemary. That was an awesome session. And what I really like about it personally is it encapsulates how I view infrastructure as code. It's the idea that you can bundle so much together, including things like security policy, and define what you care about as part of your code. So I loved seeing it in action in your discussion and you talking through the logistics of how that might shape up. It's a really powerful tool. And if any of you haven't tried it out, I encourage you to check out what we've been doing with HashiCorp. So we've been partnered with them now for a while. A lot of great stuff that we're working on together. And if you missed the keynote yesterday morning, I encourage you to go back and catch the recording once they're posted, because we've got some great insights from Armand, the CTO at HashiCorp as well, talking about what we can do together and what the future holds. Denise, obviously there's a lot of security talk today. Talk to us a little bit about what's going on in the Devi Challenge.
Yeah, this year is the second year for the Secure Code Warrior Challenge. It is a 2-day challenge. We are on the second day of the challenge, so some people have already done it. And it is designed for all skills. And the top 25 people from this 2-day challenge is going to move on to the next one, which is called Devi Defends. And you can win prizes such as hoodies, Raspberry Pi computer kits, headphones, t-shirts, and maybe even a Devi plush. So you can get more info about the challenge at cs.co/create21challenge. Back to you, Eric.
Awesome. Thanks, Denise. I want to call out one more thing here. For those of you that have been following along, you probably heard us mention cs.co/create21offers. But one of the great things you can find there is links to the Cisco store. We have great swag like this great apron reminiscent from the snack minute that we had yesterday. Up next, we have Morad from Intel talking about how to secure your keys. And I think this is a really important topic for developers to consider. So please do stick around and check it out.
Hello, everyone. Our presentation today will be on how to not lose your keys. Obviously, not any keys here. We will be talking about cryptographic keys specifically. And we want to look at how to not lose keys, especially when you are using them, as you will see. First, a quick introduction of myself. My name is Morad Shafawi. I'm a cloud solutions architect at Intel. I'm actually a Cisco alumni. I joined Intel in 2017 after 16 years in Cisco. When I was at Cisco, I was involved in the security of the Cisco Call Manager and the WebEx suite, and in general, all the Cisco cloud, the security of the cloud solutions in Cisco. And I was also part of a joint program between Cisco and San Jose State University, a program that started a cybersecurity master program. I was part of the inception of that program. Now that I'm at Intel, my role consists primarily in architecting middleware, that is services, libraries, that expose security features in Intel CPUs to other software, specifically cloud native in cloud native environments. So first, what problem are we solving? So in this figure or this diagram, we see the life cycle of a cryptographic key. So on the left, you see keys protected in kind of a vault, or the technical term is key management system. So key management system is with what is typically used to store keys at rest when they are not used. And key management systems are typically backed by a hardware security module or HSM, which protects further those sensitive previous keys, cryptographic keys. Keys can also be protected on the server. So that would be on the right on the diagram on the server where they are actually used. So the keys could be encrypted either by another key or with a passphrase by an admin, for example. So there is a way to protect keys also when they are at rest on the server, right? And going back to the key management system, when the key is actually used by the application, by the user application, the key can be transferred from the key management system to the application through a protected tunnel, like TLS, using one of the protocols that are used for managing keys over a network, like KMIP, or the protocol that Vault uses, for example, or AWS KMS, or the Azure KMS, for example. And typically, keys are protected also when they are in transit, as I mentioned, over, like, for example, a TLS tunnel. So this is the gap that we have today in protecting those keys. Ultimately, the keys need to be loaded into RAM so that the application can use the key. And that's where the key is exposed. And that is the problem that we are trying to address in this presentation. Right? Because the key will be in RAM, and along potentially with other applications, maybe malware software, right? So how do we protect the key when it is loaded in RAM and in use? That's the technical term for this state. Okay, so why is in use a concern, right? I think hard to believe. So that was a security problem that happened a few years ago, for those who remember, where keys could be, because of a flaw in the OpenSSL implementation, attackers were able to recover the private key of a server. The other problem with, or the other concern when the key is actually used, is that the OS and the hypervisor, basically, or the privileged software, can itself have its software. It's still software, so it can have vulnerabilities. So even it protects or isolate, it does a good job, or they do a good job at protecting or isolating different applications. They can still be vulnerabilities that would allow malicious software to access the content of another application. And of course, we have the problem of malicious administrators who can easily recover the content of RAM because they have access to the servers. And keys also are at risk because there could be operational mistakes. Like if someone, for example, makes a VM snapshot of an application that contains a cryptographic key, and if that snapshot is not adequately protected, then keys can be disclosed to malicious parties. Okay, so the problem that we are tackling basically is that we want to protect keys in all states at rest, and as we have seen, the industry have good solutions for that. We want to protect keys in transit, same thing, good protections there with encrypted tunnels, transport tunnels, but we also want to protect keys in use when they are at runtime, when they are used in RAM. Okay, so what we will do next is look at what solutions we have today to address the concern of protecting keys at runtime in use, and look at their constraints and limitations. So there are solutions. Okay, so but there are basically two solutions or two techniques to protect cryptographics, especially sensitive cryptographic keys during use at runtime. The first technique is to use an attached hardware security module, an attached HSM, and the second solution is to use a network HSM, which is usually network HSM is usually your KMS. Okay. So first, let's start with the hardware security module with HSMs. So HSMs are separate physical hardware that gets connected to the server, where the keys are stored, right? And then cryptographic processing is done inside the HSM. And HSM has or provides an interface to client applications that they can use, and the only way to access the keys in the HSM is through that interface. So if the key is provisioned into the HSM in such a way that it doesn't, or it shouldn't, or it mustn't leave the HSM, then the only way to do cryptography with those keys is to use the API that the HSM exposes to the to the client application. And that interface is typically called is PKCS11. So it's the standard interface that most HSM support. Other HSMs or HSMs can support also custom interfaces, but PKCS11 is the one that is the standard that most HSMs support. Typical use cases for HSMs. So HSM can be used basically by any application that has concerns about protecting keys at runtime. But typically, HSMs are used by sign-in servers, for example, to sign certificates, and then we don't want the private key to be exposed in RAM. HSMs can be used in key management systems, in CDNs as well. Okay, so HSMs are great. They protect keys, and most of the time also they do crypto acceleration. So cryptography done inside or within an HSM can be pretty fast because HSMs use specialized hardware. So they are great at what they are doing. However, they come with some constraints. First, they are costly. So this is an additional investment that users should consider. They are difficult to scale because they are hardware in nature. It's not like scaling software where you can maybe just spin up another VM or right. You need to have another physical HSM in order to be able to scale. There is an operational overhead because if we need to upgrade the firmware, for example, or do any operations or maintenance on the HSM, you need procedures that are different from the rest of the procedures that an administrator needs to use for the rest of the servers and the software. And also, more importantly, HSMs are not always an option in public clouds because as a tenant in a public cloud, you get a VM, but you don't have typically access to the hardware to connect your HSM, physical HSM. Okay. So that's with the HSMs. The second way to protect keys in use at runtime is to use a network HSM or a key management system. So key management systems is where typically keys are stored when they are not used. And as we mentioned, most key management systems use an attached HSM. Not always. Some might just store the keys on disk. So it depends on the sensitivity of the keys, right? But most commercial key management systems would typically have a backend HSM. So the typical example or flow for using keys that are stored in KMS is for the application to retrieve the key at runtime when it needs to use the key and use it, right? But in this case, the keys are eventually in RAM, and then they will be exposed, and kind of we would have the same concerns that we listed, right? So if you want to protect keys in use when you're using KMS, there are or most of those key management application protocols allow you actually to perform cryptography in the KMS itself. So in that case, you would send the payload that you want processing on, like for example, maybe signing some payload or encrypting or decrypting some type of payload. So in that case, the payload is sent to the KMS, and the KMS is instructed to do the cryptography. So in doing this, the keys don't actually need to be exposed in RAM. So that addresses the concern, but there are constraints there as well. If the client application always sends the payload to the key management system in order to perform the cryptography, then there is potentially network latency involved. That might not be acceptable in some instances. The other issue as well is that there are some use cases that might not work with this. Like for example, consider encrypting or decrypting a large video file, right? Or a VM image, right? Sending the whole payload to KMS might not be feasible in that case. This diagram or this figure summarizes at a high level the solutions that we have today to protect keys in use when they are actually or actively used. So on the left, you see the solution that uses network HSM or KMS. So in that case, the user app sends the payload to the KMS, and the cryptography is performed there directly with the key. So the key never needs to leave the actual KMS. The second option is the attached HSM, as you can see here on the right. So the application using PKCS 11 API can access the key that is, or can refer to the key that is in the HSM, and then perform cryptography directly in that attached HSM with the key. So in both instances, the key is protected during use. And one comment here, one quick comment on PKCS 11 API. So the user app doesn't actually need to use this PKCS 11 interface specifically. In some instances, some of the common cryptographic libraries like OpenSSL have a way to translate OpenSSL calls to PKCS 11 transparently. So the developer can still use OpenSSL, but the translation to PKCS 11 would happen automatically and transparently. Okay, so now that we have seen the concerns with using keys in RAM and the current or the existing solutions to address this problem, we'll look at another way to protect keys in use. And that other mechanism is based on confidential computing, and specifically SGX. Okay, so we'll be looking at confidential computing. How can confidential computing help us in this case? So first, what is confidential computing? It's basically a computing paradigm that offers isolated areas of execution on a server, right? And that isolated area of execution is called Trusted Execution Environment, or TEE. The isolation, as we have mentioned that in one of the previous slides, the OS and the hypervisor also do that. But in the case of TEE, that isolation is often enforced by hardware, right? So there are hardware features in the CPU itself that would kind of enforce that isolation. The confidential computing is a feature that is that needs to be supported in the CPU, right? Not all CPUs support confidential computing, but those that do provide this capability, right? And some examples of technologies that today do or support confidential computing is Intel Software Guard Extension, or SGX, AMD SCV, ARM Trust Zone, and AWS Nitro also is another option. Okay, so how do we protect keys in a TEE? And just a quick reminder, a TEE, or Trusted Execution Environment, is kind of an isolated area of execution that the confidential computing feature offers the developer, right? So the idea here is to implement PKCS 11 cryptographic interface in a TEE. That's the idea. So from client perspective, client applications perspective, since this is like the interface is PKCS 11, it looks just like as if they were using an HSM, right? So if they were using an HSM to protect their keys, the idea here is to, instead of doing the cryptography and protecting the key in a separate hardware HSM, the idea is to protect the key and do the cryptography in a TEE, right? So in order to do that, we can have a kind of a shim, software shim, that takes those PKCS 11 calls from the client application and then translates them into the interface that the TEE supports, right? Something that we haven't mentioned, but TEEs usually provide a special way or support a special protocol for client applications to communicate with, right? So in the next slide, we will see how this TEE can be used to protect keys, but specifically using the SGX technology as an example. So SGX. So basically quick primer on SGX here. We can't cover it in details, but you are welcome to go and on the Intel website, there's a whole site dedicated to the SGX technology, SGX at Intel. So the way SGX TEEs are packaged, basically the SGX SDK allows the developer to package the code that would run inside a TEE as a shared library, right? That's the SGX SDK that does that magic, right? So from the client application perspective, an SGX TEE, or the technical term is SGX Enclave. So SGX Enclave is the kind of the SGX name for SGX TEEs. So from an application perspective, an SGX TEE is just a shared library, right? And there is an implementation with the link provided below of that PKCS 11 implementation in SGX Enclave. So it's basically from the application, the client application perspective, it's a PKCS 11 library, right? So the application would still make PKCS 11 calls to that library, but instead of those calls being carried out by a hardware HSM, they would be carried out inside by software running inside an SGX Enclave. So this is the basic idea of the solution, right? And here, this diagram explains at a really high level how these SGX enclaves work. So as you can see on this diagram, you have a typical system with hardware, VMM, hypervisor basically, maybe some VM with an OS running on that hypervisor, and then different applications. So the small red squares here are the SGX enclaves. And as you can see, the hardware, the CPU, ensures that the content of these enclaves is not accessible to any software, not even the application that uses that enclave, let alone other applications. So even the kind of malware is running on that, manages to run on that server, it won't be able to access those enclaves. But more importantly, even privileged software like the OS and the hypervisor can't access the content of these enclaves. Only the CPU can do. So the idea here with SGX is that those enclaves are protected at all time, and this is done actually at a high level by encrypting regions of memory. Those enclaves, they are encrypted with a key that is inside the CPU. So only the CPU can decrypt the content of those enclaves and run the corresponding code and access the data, like in this case, keys, cryptographic keys. So this is the idea with SGX, okay? So now that we have explained the general principle of how the TEE and SGX enclave can be used to protect keys, we might have the question of how are the keys provisioned into the TEE in the first place, right? Operationally, the key can actually still be stored in a KMS, right, in key management system. And then when it's needed, there is actually a flow that will allow you maybe as an admin or your deployment script to request CTK to generate a wrapping key, right, to return a public wrapping key, and the corresponding private key would still be inside the CTK, which is basically the SGX enclave that implements PKCS 11. And then that public wrapping key can then be used to wrap the application keys that you need inside CTK, right? So only CTK will be able to access those keys, right? And then CTK will return some kind of some ID, key ID that applications can use to access the key, right? In PKCS 11, that key ID is actually PKCS is called the PKCS 11 URI. So it has a URI format and refers to a specific key, right? So this is how you can provision the key. But there is another way that key can be automated, or the provisioning of the key can be automated using a feature called SGX attestation. So what is SGX attestation? Again, quickly, SGX attestation is basically a way for a TEE, an SGX TEE or an SGX enclave to prove to a remote party across a network, even across a network, that it is running in SGX enclave. And it can do that by generating what we call an SGX code, which is basically a signed claim that can prove to a remote party that indeed the other party is running in an SGX enclave. That SGX code can also contain a wrapping public key or the hash of a wrapping public key, and the public key can be sent separately, so that the remote party can encrypt or wrap secrets with that wrapping key and send them to the enclave with the assurance that only the enclave can have access to those secrets, right? So in same here, there is as at the bottom of the slide here, you can have all the details, but there is basically an implementation. We have done an implementation where we have implemented a shim on top of the CTK library, the CTK library, right? So the shim is called SKC, or Secure Key Caching, and what that shim does is basically perform an attestation with a remote key management system, right? And then when the attestation is successful, basically the remote key management system can validate that the key will be returned to an SGX enclave. Then they are wrapped with the public key of the enclave and returned to the enclave, right? So this basically automate the process of provisioning the key into the enclave. Final slide is, so what do we gain by using CTK and SKC, and in general an SGX enclave in this case? So what we gain is that the key, of course, the cryptographic key will be protected in use, and that addresses one of the concerns that we had, that we listed in the beginning of the presentation. But SGX software developed with SGX, like the CTK and SKC, they're still software. Besides the fact that they are run in an enclave, they're still software. So they can use all the techniques that are used for the rest of the software in terms of deployment, configuration, software upgrades. They can scale because it's just software. You just need to spin up another enclave on another VM. As long as that VM is also running on a server that supports SGX, that scaling would be possible. So basically, these are the benefits of running software in an enclave. You get protection at runtime, while you get all the benefits, or while that software integrates with the rest of your software. You don't need a separate procedure to manage that software. And this wraps this presentation. Thank you, everyone, for your attention. I would be happy to answer any questions. I think you have my contact information in the slides. Please feel free to reach out to me. I will be happy to help with any questions you might have. Thank you.
Right on. Thanks, Morad. It's really amazing to have a good reminder about not just security for our applications, but the keys portion of that specifically. As we're thinking about security for applications and how they get developed, it needs to be a cornerstone or a keystone of the work that you do. It cannot be an afterthought. And so often, it unfortunately becomes that when you're developing something, because we need to make sure that we don't want to be, our applications, our businesses don't want to experience another Heartbleed, or don't want to be, in the media for having to deal with another point of sale system, that gets breached of some kind. So thinking about that stuff in the beginning is super, super important. And I want to remind everybody, if you want to be part of this conversation and be part of all the chatter that's happening about the sessions and content and all of that, you can find us on social media, any of the platforms at #DevNet or #DevNetCreate. You can also, while you're in the browser window, you can go into the Q&A panel there on the right. Just go in there, drop your questions. We'll get them to you live. And you can click the blue button there at the bottom, and it'll open up WebEx messaging, and you can be part of the live persistent chat that's happening with all the other attendees throughout the rest of today. So we've got some more great stuff coming up for you as well. Denise, I'll hand it to you for more of the fun.
Yeah, before we continue on our sessions, I wanted to remind everybody that all of these sessions are recorded. Not only this channel, but all of the channels, and also from yesterday. Those recordings will be available on October 26th, so definitely remember to come back and, watch the recordings. We know that you need to because you're watching us, and there's all other stuff happening right now. So let's switch gears. We're going to be talking about searches. Have you ever gone to the site, you put in what you want to search, and it's completely useless? I mean, that happens to us all the time. And I definitely think that Jeff needs to use MongoDB, our next presenter, to find his keys. So let's hear from Karen discuss how we can unify search with MongoDB Atlas Search. See you after the session.
Hi, I'm Karen. Thanks for joining us today on this talk about MongoDB Atlas Search, unifying search and the database. I am a principal developer advocate here at MongoDB. I've been here almost 4 years. Something really interesting about me is I am an avid paragliding enthusiast. And just 3 weeks ago today, I was with some friends and we flew in a paragliding wing around Mont Blanc. It took 3.5 hours, France, Switzerland, Italy, before returning to France. But that's not what we're here to talk about today. I just like to squeeze that in. We're here today to talk about Atlas Search, and I want to talk about how MongoDB made search easier inside of Atlas. We're going to talk about all the features that we could do, and we're going to start building queries on those features. We're going to talk about indexes, analyzers, some of the nitty-gritty hard stuff before we move on to demos. I'm going to show you a demo. I'm going to give you the code so you can sort of download it, play with it, build your own aggregations and search queries. Before talking about architecture, what goes on underneath the hood and how that might affect performance for yours, things that you need to consider so that you can build search queries optimized quickly and confidently. So that's a lot. Let's get going. Why we built Atlas Search. If you need search inside of your application, you're not alone. Whether you're looking for restaurants or whether you're scouring logs for things, everybody needs search, and they need rich search, and they need fast search. So if you use MongoDB, you might have used $text for that or $regex for that, but that didn't bring you advanced features like autocomplete or fuzzy matching. You had to code around that. So what some people did was they set up third-party systems and servers so that they can do these things, but they found that this had its own set of operational overhead problems. You had to manage it, scale it, secure it. And so we saw that instead of making people do that, we just took the battle-tested open source Lucene library and we integrated it directly inside of Atlas to bring you Atlas Search. And so this is going to bring you a full set of rich search features without that operational overhead. We have fuzzy search, autocomplete, filters, facets, highlighting. I'm going to build out some of these inside queries inside the next 15 minutes or so and show you exactly how easy it is. So what I want you to leave today with is knowing that there are really basically only 4 steps that you need to do to search inside your Atlas data. You need to have an Atlas cluster. You need to have data on that cluster. You need to create a search index. And you need to query via the $search operator. Now, all 4 of these steps you can do inside your Atlas interface. I'll show you how. But these first 3 steps, they're very fast. They only require some click of a button. So let's show you what those clicks of the button look like. So for this talk, I went ahead and spun up an Atlas cluster. It is free if you wanted to do this with me. You don't even need a credit card. And then I downloaded the sample data set that's inside of Atlas. So if you go back and look at this, you can go ahead and use that. My collections that I have in that sample data set, you see sample Airbnb, analytics, we have a wide variety. I'm going to focus on the movies collection inside of my sample Netflix database. This collection has over 23,000 movie documents. And as you can see here, these documents have a wide variety of field values. We have strings, arrays, numbers, we have dates. So with Atlas Search, we can set up an index and start querying across these values right away. So the first thing I need to do, I have my cluster, I have my data, and now I need to build a search index. So the search index we have here is different than the regular MongoDB index, and I'll talk about that later. It's basically an inverted index, but all you need to do to create it is just kind of click along. We're going to use the visual editor. I'm going to keep it named as default. make sure I'm on my movies collection. And then you can see here the default settings. I'm using the standard leucine analyzer. Dynamic mapping is on, and let's just create an index. And that is really all you need to do to get started searching. We support all sorts of data. I already mentioned numerics and dates and objects. We also have Boolean and timestamps. When you map out with your default index settings, all of these, the text, numerics, all of these in green are automatically mapped. If you need GeoJSON data or autocomplete, that just requires another press of a button in the interface, and I'll show you those later. So now that we have the first three, let's focus on the last one. How now are we going to query across the data? If you already use MongoDB, then you're probably already familiar with our aggregation pipeline. Documents inside this enter a multi-stage pipeline that transforms the documents into aggregated results. And so we leverage the aggregation pipeline to do search queries by making sure the $search operator is always the first stage inside of those aggregations. So let's go ahead and get started with our first aggregation. If we wanted to, here we are in Atlas. So I can use this, you can write this out by hand, some people do. I'm going to take advantage of the aggregation pipeline builder here. I like this because you can add different stages in it, and it also shows you how to do, it gives you the comments, it auto-completes for you. You can build that out here inside of Atlas. I really prefer working inside of Compass. If you don't want to download it, you could just go ahead and do this in Atlas. We all have our ticks as developers. This is one of mine. So I'm going to use search here as my first stage. We have these nice comments that's going to guide you through how to create a search query. But I'm just going to go ahead and way. So we're going to use the default. Remember, we created the index and we just named it default. I don't have to put this name in it because it will default to the default index. Or if I named it something, I can write that in here. I always look for movies about the zombie apocalypse. And let's look inside. I know I have a plot field. And there you go. I have my first search stage in here, my first search query. If I wanted to, I can look across more than one field. So I'll do plot, full plot, and title by changing the path to an array. And so now I'm looking across all sorts of different fields. And the one thing I want to point out is how easy we make typo tolerance. If I misspelled zombie apocalypse, I will get no results back. And that's, we need to allow for people to make that mistake. So we do something very easy inside of Atlas. If you want to allow for people to just have a thumb slip every once in a while, just put in this fuzzy object. So you can do fuzzy max edits 2. 1 is less forgiving, and it'll bring you more exact matches if you wanted to do that. So now I have my first query. I mentioned this is part of the aggregation stage. Let's add some more stages here. I don't want to look at all these fields that I have here, so I'm just going to project out the fields that I want to use. And I'm just going to copy and paste code here to save some time. So now I'm getting the title, the plot, the full plot, the year. See if I can make this a little bit bigger for you. The year, and then you can see I have the score. I'm using the meta projection operator to get the score. Atlas Search will return a relevance score for every one of the documents inside your movie collection, as you could see here. This score grades how well this movie's document fields, the full plot and plot, matches the search terms zombie apocalypse above. And as you could see here in the preview panel, that the scores decrease as we go on. So this is bringing you the highest scores first, which are the most relevant movies. And because in-search speed is important, and because I know I'm getting the best match movies first, I'm going to use limit as my last stage because I only want the best movies. There's no need to go across all 23,000 documents. So this will bring me my top 10 results. So now I have my first aggregation pipeline using search. And if I wanted to grab the code for that, I simply press that button, and then here is the code that I would use to build that. And I can copy and paste it here. Now, as I mentioned, we can search across a variety of data. That was text. I want to search across this released date here. That's a date field. I can also search across numbers using operators like range and near. So in this one, I'm going to change my search field to use range. So now I am searching across the released path for anything between 1980 and 1996. And you could see my result previews here. The first one says released in 1984. So if I change this to say 1990, it's going to change that. Now it's going to filter out anything before 1990. So I have two basic queries, but how can I combine them? Because this one isn't actually very useful in and of itself. Well, we use something called the compound operator. Again, I'm just going to cut and paste for the sake of time. So as you see here, here is the range query that I built. Here is the text query that I built about the zombie apocalypse. I simply combine them in an array using the compound operator. And so this is how I could take these basic search building blocks and combine them in many different ways to bring you all sorts of rich search results. And I'll show you in a demo later how that works. And so now I want to talk about indexes and analyzers. Full text search is analyzed, which means the input data that we have, like the sentence above, it was the best of times, it was the worst of times, is broken up to smaller bits called tokens based on the analyzers. The analyzers pick the rules. So for instance, the Lucene standard analyzer is going to break this sentence apart at the white spaces, lowercase everything, remove punctuation, and remove the common stop words. It was the and or, for instance, and it's going to return these tokens to us. That leaves us with best, worst times to be indexed. So I mentioned that we have inverted indexes for Atlas Search. The inverted index means that it's going to point to a different set of index, which is the MongoDB indexes. So here on the left, you see that we have, these are MongoDB documents. And here on the right, we have the inverted index. So if we look for best, worst times, this 2 and this 3, those are the documents that they exist in those sentences, if I were to index on sentence. So basically, it's important to know that inverted indexes are essentially a map in which terms are associated with a list of document IDs. And that's what makes them so fast. If I use a different type of index, let's say if I were to use a keyword analyzer, it's going to match everything exactly. Spanish analyzer would have different stop words, so it wouldn't remove these certain words. So it's important to know this when you pick your analyzer. We have all sorts of different analyzers. We're supported across 40 different languages, and we have custom analyzers, which might help your use case if you have your own sort of specific language in your data fields, for instance, HTML tags, chemical equations, or even server logs, so you can figure out where to parse your tokens. We set up something with the dynamic index. Now I want to, that was great because we can index all of the fields, and as your schema evolves, we'll map those. But it's not exactly performance friendly. If you only need to index a certain field, if you're only searching across certain fields, I would suggest using static index definition. Here, I turned off dynamic mapping, and I'm only mapping on certain fields, title, genre, and plot, and I set the analyzer there inside the index definition. And I can even add multi to put different analyzers on the same field. So what I want you to think about when you pick your analyzers is think about your data. We're going to start with the data here and inside. Think about how you use it, how you query it. Then pick your analyzers. Your analyzers are specified inside your index definitions, and then you use your inside definitions, your index names inside the first line of your $search aggregation queries. So that being said, let's go have a look at our demo that I promised you. So if you go to Atlas Search Restaurants, you will find this demo. I wrote it. It might be a little bit buggy. I've open sourced it so you can put corrections and you can do pull requests on it if you want. But just to give you an idea, this is New York City, and it's looking for restaurants inside New York City. I can filter on star ratings or cuisine type or where. A few things, like you can see that I have autocomplete here. If I wanted to, I can pick out these. Or if I wanted to, I can look for noodles, let's say noodles in the menu. This here is, I'm going to use geolocation here. So this is the MongoDB office inside of Manhattan. So I'm going to look for noodles, at least 3.5 stars. I'm going to use the geo within, let's say within 24 miles of work. And there you go. So these are all the places that serve noodles within less than half a mile of work. And the other thing I want to show you here is that we have highlighting and we have synonyms. So I looked for noodles, but I'm getting back pasta and spaghetti and stuff like that. If I wanted to, and this is what I think is going to help you, is that you can see if you went to show the aggregation here, this will show you the aggregation code I have. So you can see how I use compound to combine these different search coordinates. I have the geo within, the range for 3.5 stars and higher, and then these are the different aggregation stages inside of it. So if I wanted to create the index for this, I'm not going to go through creating the entire index, but I have the data here inside What's Cooking. Search index, create a new index. I'm going to use a visual editor. I am in the right collection, but before we just accept the default, now I'm going to refine it. So I'm going to turn off dynamic mapping. I'm just going to add a field or two here. So I'm going to say location is field, and I'm going to add it as you can see the different types we have. So that's geo, for instance. If I add another field, I could add stars, and then that is, let's add my data type, and that is a number. So I can add this here, do everything I want to here, and that's basically how you're going to create your index. If I save the changes, create the search index. And that's what I did when I created this What's Cooking application. So I hope that helps you with it. Now, in our final minutes, let's go and look at some of the architecture that we have in it. I talked about search indexes being an inverted index. And MongoDB uses B-tree indexes. So you might know we have MongoD for regular MongoD. Sharding uses MongoS. So we built a whole new system, the MongoT system, that's based on Apache and has a different Java process. So the reason that this is relevant to you is that all these resources are co-located on the same node. So know that this is one of the reasons why you might feel performance hits, and that's why you need to use analyzers and indexes efficiently. The query lifecycle, knowing that you have MongoT talking to MongoD, I'm just going to walk you through the query cycle real quick so you know how that works. Your application gets your aggregation call, and MongoD sees that it uses $search, and it says, hey, let's send this over to MongoT. So MongoT will then look for Star Wars in the path. It's going to find these in the things. It's going to find the documents, the object ID documents, and it's going to send that back to MongoD. MongoD is then going to look up those documents, and it's going to finish the aggregation, finish the project, finish the limits, take the metadata, the scoring and the highlights, for instance, and then it's going to finish the aggregation and send that back to your application. And that's how that works. And that was a lot to get through. So let me finish up by some of the takeaways that you guys should have. It's included in Atlas and it's free. You could have it on a free cluster if you wanted to. It is easy and it is fast. And if you're familiar with MongoDB query language, it should be no problem for you to integrate right away. It is highly customizable and the data is kept in sync because it's all in one place. You don't have to worry about scaling out and you don't have to worry about scaling up. We do that for you as well. some of the resources that we have. I mentioned the What's Cooking is Atlas Search Restaurants here. This is the Git repo for that if you wanted to have a look at what's going on there. I highly recommend, I use search all the time. I have to go to our docs. They're great. And we also have great search capabilities in there. And then if you wanted to sort of see how I built it out other than the Git, this is a video workshop that I did at MongoDB World a few months ago. So if you go to this link, MDB Search Workshop, this is going to take you to a YouTube video where we go through all the steps from creating APIs and how you call it from the front end, and where we build out a Netflix clone. That was a lot to cover. I really appreciate your help. Thank you so much. I hope you enjoyed it. I hope you enjoyed the conference. And on Twitter, I'm YouOldMaid. So let me know if you have any questions or suggestions. Thank you very much.
That was super helpful, Karen. I really appreciate it because, you know, seeing how quickly you could go through an Atlas cluster and create a search query from all your automated tools was, I mean, just amazing to find out how quickly you can do it. But also, it so helped me find my keys. I really appreciate that because I was really freaked out about that. So that was fantastic. And, you know, if you have your own stories about using search and building your own search queries, especially with MongoDB and how easy that is, definitely share it with us. Hashtag DevNet and hashtag DevNet Create on all the social channels. You can find us everywhere. We'd love to talk about it. Share more of those stories. I mean, we've talked about this before. Denise and I hit on this a lot yesterday. A big part of DevNet Create is about the people, about all of you, like sharing stories, these projects you're working on, all of that. It's really fantastic. So we want to hear more from you. Absolutely. Eric, I think we've got some cool stuff coming up too, if you want to talk about that.
Absolutely. First, on the social side, I just wanted to call out, I didn't mention earlier, but feel free to tag me as well. I am Eric D. Thiel on Twitter. We love seeing all those posts, like Jeff mentioned. We just saw one recently come through from Gifted Lane, one of our DevNet Creator Award winners this year. Thank you again for all your contributions. But she said, DevNet has to be one of my favorite learning journeys after CCNA. And we love seeing that kind of feedback. That's what this is all about. This is helping people wherever they are in their journey, in their learning journey. Helping them grow. So whether it was Start Now channel yesterday, getting them started, or if it is the more advanced topics we have weaved in throughout the 2 days, we love seeing how you're leveraging that content. Please hashtag tweet at us. We want to hear about it. Next up, now I'm really excited. I'm actually all set. There is a retooling your data center talk.
Eric, I'm sorry. It's not those tools. Not those tools.
Oh, sorry. Yeah. No, I guess I was reading the wrong line. So it's actually Dave is going to talk to us a little bit about how they were able to retool their data center by putting agile and DevOps practices into place and really have them be a very dynamic and easy to support data center. So let's hear from Dave what they did.
Hey, welcome to DevNet Create, retooling for self-driven data center. My name is Dave Burns. A little bit about me is I lead the data center engineering and operations team for Cox Communications. And why I'm here is I've been around the block a little bit. I've worked on the Cisco side. I've worked in building data centers from the plumbing to the actual physical outside plant. So let's jump right into what I have to say today. So what does it mean by retooling and what is a network development engineer? I get that question all the time. And, you know, you can Google this. And so most of us will go straight to it. And really, a network development engineer is a person that's responsible for building and scaling data networks. We all know that. We've all seen that. But, you know, a traditional network engineer has always been just building networks and managing networks. So what's the difference? Well, it's pretty simple. You know, when we get into development, we're thinking more of a software mindset. We're creating, we're deploying, we're automating networks, right? And that's where we are today. It's an evolution. So are we retooling or are we just doing things differently? People get nervous when you talk about this because they're like, oh, you know, I've always been working on hardware and, you know, in BGP, RIP, you know, EVPNs, I mean, you name it. I'm starting to show my age when I start to talk about RIP. So, but anyway, it's really an evolution of networks and we're evolving with it. And then that leads to where are we going? Software defined network, a buzzword. We know it's a buzzkill sometimes when people talk about it, but it is our reality. And what do we mean by self-driven networks? It really is about this banner I have at the bottom. It talks about the process of, You know, when we do any type of work when it comes to a network, we're looking at requirements. We're looking at the intake risk assessment, the adjudication, the design, the staging, the fulfillment and validation. Those components, and which ones can we actually automate? And then the evolving skill sets that are required to do these things. You know, there's usually groups that are focused on design, focused on fulfillment. You know, how do we retool so we're all into this DevOps model? You know, it used to be you were in either in operations or in engineering, and engineering was really focused on building for the future. Operations focused on putting out fires and dealing with the day-to-day. Now, as we pull those two together, you have that continuous loop, and it's really all about simplifying, you know, the complexity. That's why I have here simplifying the operational complexity. Well, those of us who have managed networks know it's not easy. Those of us who have developed code know it's not easy. So when you merge those two together, it requires that we have a little bit of knowledge of both hardware and software and the process that it goes through. So the challenge that we often is enabling our networks to really be intelligent. And that leads to what we know as an underlay and overlay network. And those of us who are network deep, we call it the plumbing. Those of us who are developers, we call it the overlay. You know, that's the fancy term of saying, hey, this is how my application is presented. This is how it performs. And then that gets to how do I get to this culture of retooling and to prepare to become a network development engineer. I have a lot of these are all meaty topics, but I'm going to just be quick and try to just glean the top of them. There's the culture of learning. You know, we always are learning in networking and in software development. It's continuous. And if you don't have a passion for it, you're going to struggle. I always tell people, do you love what you do? If you do, you'll have the energy, you'll grow. The other is, you know, what is the visibility in network health? So in order to program something, you need to visualize it. You need to understand what you're programming. And then there's the standardization of network and security policy. You know, to go program a network, I need to know what guardrails that I have to operate within. And then I'm going to jump over to adopt an agile DevOps culture. Those are buzzwords, all of them. Really, it is about agility. You know, do I run in sprints? Do I adopt this mindset of doing things in very small, you know, steps? You know, we call them baby steps. You know, do it in 2-week increments versus, you know, long 6-month projects. Do it in 2-week increments, and we get more. We can continuously learn. We can do what we call retrospectives and then move on. Identify and monitor, report on KPIs. The KPIs, as you know, are going to get, you know, key indicators. You know, how am I doing? How is my network doing? How do I identify, you know, things that are important to my network, whether it be mean time to restoration, mean time to innocence. Those are people who always want to blame the network. Time to resolution, time to innocence. You know when we have an outage, everything points to, oh, it's a network. Oh, it's a server. Oh, no, it's the virtual environment. So how do we really show what numbers in data help us find what is the problem? And then I always go back to focused automation. You hear everybody in the industry talk about this data-driven mindset, but they want to automate everything. Is that the answer? I've always been a focus on what you want to go automate and what you can go automate, and eventually you will have an end-to-end automation strategy. If you try to automate everything all at once without having these underlying things, you're going to fumble. You're going to make errors, and then you're going to add additional costs to the business. So those of us who are more techie don't get what we need out of the automation. And then the last component is simplify, simplify, simplify. You know, I always had a leader when I was in the military used to say, keep it simple, stupid. And there's other ways to say that too, but KISS, and that's the truth. If I can design something that's simple enough to where the most basic operations person, tier 1, tier 2, tier 3 can understand what I was trying to achieve, it's going to be that much easier for them to manage. And it also makes it easier to automate. So what does that all mean? Well, let's pull it all in. It's innovation. Where does innovation start? It doesn't start with a grand vision of this glorious leader of a great company. It can, but it really starts with us as engineers, us as developers. The I in innovation is I, meaning go learn something new. I've learned that network engineers who go learn scripting, they're the ones building the playbooks to know what they're trying to achieve. And next thing you know, they are automating network changes and on the fly and things that we can do outside of maintenance windows. The next is building a culture of learning. That's the fun part, that we all love to learn. It's contagious. Let's make sure we continue to feed that and support that. You want to learn something new? On my team, we have a culture of learning. We manage networks, we manage security, but if you want to go learn about cloud, go learn about cloud. We're also managing some pieces of the cloud, but we don't own it all. Then the challenge, the big takeaway for me is, how can we do better? How can we move faster? How can we improve quality? Why not? Or why? Challenge the business as usual. Those are the best engineers. Those are the best developers. There's a way to go about doing it, but do those things. And last but not least, research on these topics. Don't just Google one thing. Go out there and look at all the different aspects. In the DevNet program, we've been taught there's all sorts of open standards to go research. Go learn those. Those are great aspects that will bring you and help you get to the place where you're truly a network development engineer. Anyway, I'm passionate about this. You can always follow me on Twitter. You can always reach out to me on LinkedIn. And as always, I appreciate your time and enjoy the rest of Cisco DevNet and go have fun.
Welcome to Voice Enablement App Inside Dashboard session. My name is Jairo Leon, Customer Delivery Architect at Cisco Systems. Happy to be able to contribute in this era of digital transformation. Today with me is Owen Snell, who is software architect for Cisco also. He's passionate about innovation and automation. Let's move to the problem statement. Maybe some of you have to deal with this kind of issues that we can see in this image. For many companies, applications are their business, and errors like this may impact the loyalty and reputation of the customer. In fact, some research show that the users have zero tolerance for bad digital experience, and if their digital experience doesn't perform, so they won't use them again. So that is very important. Wouldn't it be nice if you can receive an alert on your smart speaker on these kind of situations? Even without opening your laptop, get some additional information about the events? Well, that is precisely what we are going to show in this short demo. Let's talk about the solution that we have to get information about the applications. We are using Cisco App Dynamics to monitor service level indicators for this demo application called AD Capital. On the left, we have the flow chart that was created automatically, generated by App Dynamics, in which we have all the microservices that we see here. And also we have very important indicators that are errors, response times, that we are going to use to get some information about the health roles. On the right side, we have a dashboard. That dashboard is showing all the business transactions of this application, and also we can see the application components, that is node, servers, network, databases, tiers, and of course the business transactions. And also we have important metrics, and that is latency and availability, and the events that we get from this application. Now let's move to the short demo and how it is working.
Alexa, what did I miss? One new notification. From Notify Me. This is an alert for AD Capital application. The availability of the payment business transaction is being affected. This is impacting users' experience. Please check it now using Alexa's Cisco app Insight skill.
Alexa, open Cisco App Insights.
Welcome to Cisco's Application Insights Alexa demo skill. What would you like to do?
What is the status of AD Capital application?
Your AD Capital DevNet application has one business transaction in critical status during the last hour. The affected business transaction is Submit Loan Application. There is one database in critical status. The affected database is AD Capital MySQL. Would you like to hear the KPIs values for the affected database?
Yes, please.
Okay. Within the last hour, the AD Capital MySQL database had the following KPI values. Calls per minute went up to 578 and the response time went up to 4 seconds. Thanks for using Cisco Application Insights demo skill. Goodbye.
You may be asking how this integration was possible. We defined different health rules in App Dynamics, and when any of those health rules are violated, then App Dynamics will push a notification to AWS Proactive Events API. This API will also send a notification to a custom Alexa skill that we developed for this demonstration. And the Alexa skill will push the notification to Alexa devices, like the echo dots that you saw in the video. Then the users can hear all those alerts or notifications, and they can open the custom skill to ask additional information. The custom Alexa skill will trigger a Lambda function written in Python that will make API calls to App Dynamics to gather all needed information and send it back to your device via the Alexa skill. All the code that we developed for this demonstration is available in this link. We hope you enjoyed this session, and thanks for watching.
Hi, Rowan Ovesnell. That was awesome. And I really appreciated it. I was sitting here toying around with I'm not going to say her name because she'll chime, but I was toying around with mine. I'm like, I need to do something like this too. But the smart speaker part of it, I think was, it's a small part to trigger, but I think it's really amazing to see how we can use what we see as like personal technology with something that's really important, like monitoring application health in the system. And it reminds me of my IT operations days, that I spent a lot of my career in, where we would have a situation or an outage occurring, and we needed to be able to give notifications to management on a regular basis about what was happening. But it just consumed a lot of time to run over and tell somebody their email or what have you. So having something like this where you can quickly give the right people the tools to go find out information about something going on, as well as the operations folks, I think that's a huge benefit to everybody, and it can simplify things quite a bit. So I wanted to jump back in and just remind you about the Cisco store. We've got some really cool offers and some really great merch you can get out there, from shirts, hoodies, bottles, tumblers, all kinds of good stuff. There's lots of amazing things. Just go take a look, check it out. We all love swag. Find that at cs.co/create21offers. Now, Denise, I just realized something. I'm actually getting kind of hungry. Do we need to get some more snacks?
Wait, you didn't get any more snacks? I already got mine, some Albanese gummy worms. You should have got yours. Well, yesterday I did ask everybody to let us know what their favorite snacks were, but I didn't see anything on Twitter. So let us know today. Use hashtag DevNet and hashtag DevNetCreate. Well, let's move on to our next session. Have you guys ever used Wireshark and it saved your day during debugging? What if you were able to do that with API traffic? Well, in our next session, Zohar and Alexei is going to introduce API Clarity, an open source API monitoring tool. So I'm super excited about this session. I kind of mentioned it in the beginning. And so let's learn what is about API Clarity.
So hello everyone, I'm Zohar Kaufman, and together with me today is Alexei Kravtsov. few words about myself. I was the co-founder of Citera Networks that is active in the cloud storage and enterprise file services areas. Later on, I've co-founded Portshift together with Rani Lani, a startup focused on Kubernetes security that was acquired a year ago by Cisco. Alexei, would you like also to introduce yourself?
Yeah, sure. So my name is Alexei Kravtsov. Worked at Checkpoint in the old-fashioned security products before the cloud hit up, leading the data path acceleration team. Then I joined Portshift in its beginning to move to the cloud security products. And in the last year, we were acquired by Cisco. And so now leading the Kubernetes controller security team.
Thank you, Alexei. So in Cisco, we joined an effort around API security in Kubernetes and stumbled upon a problem space that we will present today. This work was inspired by Peter Bosch and Alessandro Dominuco, so thank you for that. And now we look at the problem space. So cloud services are becoming more and more popular. Many of them are using open API specifications to define the standard language agnostic interface, which allows both humans and computers to discover and understand the capabilities of a service without access to source code or documentation. Not all applications have their open API specifications available. They can be legacy ones or external applications, and we would like to get the open API specs of an application without code instrumentation or modifying existing workloads. We would also like to detect drifts between implementation and specifications, applications that still use deprecated APIs, also called zombie APIs, and undocumented ones, also called shadow APIs. We looked for cloud native open source that will allow us to do all this, but didn't find a solution that will answer all our needs. Open API tools and api.specificationtoolbox.com provide a good list of open API tools and related list of companies. There are also good solutions from Optic, Swagger Hub, API Shark, and IMVision, but none of them answered all our needs. So we decided to produce a new open source called API Clarity. No code changes are needed for any of your apps. When deployed in Kubernetes cluster, it observes all the API traffic and reconstructs all the relevant API specs. The user can then review the reconstructed spec and declare them as a baseline, or alternatively provide official specifications to be compared to the reconstructed ones. Afterwards, we can note all the API events that are different from the approved spec and highlight the zombie and shadow APIs. We also provide a UI dashboard where we can audit and monitor the API findings. As a first integration, we achieved this by utilizing a service mesh running inside the cluster. And voice sidecar proxies help us observe all the API traffic, and as a result, we can reconstruct specs, highlight API differences and other abnormalities, while the user can review the specs and make changes as needed. We detect spec parameters, whether in the path, query params, headers, or cookies. We understand object references that might be included in the spec. We support file transfer API, and for security definitions, we digest basic auth and auth2. So now for our demo and setup. So we have a Kubernetes cluster with Istio service mesh already installed. API Clarity, it was also pre-installed. And we run there the SockShop demo application in order for you to see API traffic and visualize everything that is going on. So let's go now to Alexei for the demo.
Thank you, Zohar. So let me show you what we did in API Clarity. So this is the GitHub page of the open source. Actually, it consists of 3 different repositories. It's the main repository of API Clarity, the speculator, which is our spec reconstruction engine. And we did an integration with the Istio, with the Envoy. So we have the WASM WebAssembly filters repo for you to hook it up and get traffic from Istio. So let's get back to the main repo. So in order to get you started with the reconstructing open API specification from live traffic in your Kubernetes cluster, all you need to do is to set up and run the installation YAML, which is right here. You can just deploy the YAML with the binaries and the images that we prepared for you. And in order to get the traffic and to monitor the traffic from the selected namespaces, you just need to init the WebAssembly submodule and just to run the deployment script with the namespaces that you choose to see traffic from. And from that point, all you can do is to port forward to your cluster, to our service, and you will see something like this. So that's the main dashboard of API Clarity, which shows you the trends of new APIs, of existing APIs, and if there were any diffs against the provided or the reconstructed spec. Here you can see the most used APIs, and also if you set up and approved any specs, it will be shown right here. I'm using the Weave SockShop demo application in order to generate some traffic and see how it is affected in API Clarity. So let's just generate some traffic. I'm registering to the shop. And let's buy a few socks and then see all the microservices that are involved in the transactions and all their APIs. So let's buy some additional socks. Maybe try to remove something from the cart. I think this is mandatory to complete the transaction here. Fill some credit card information and complete this transaction. Great, so I think that we generated enough traffic to see it immediately. So I think that should be a spike in the last 5 minutes of the traffic. Yeah, that's what we did just now. So if we go to the API event screen, we can see all the traffic that was generated right now in the SockShop application. We can see the time it would happen, the HTTP methods and the paths. Also, if there were any errors that occurred, we can see the source and the destination of the pods that communicated. And we can also see if there were any diffs against the spec. We'll get to the specs in 1 second. And we also see here the host that was invoked and what is the microservice that we invoked. And also here we have a type, whether it's internal or external communication. I will show you in 1 second also how external communication looks like. I mean, we monitor not only the traffic, the east-west traffic in your cluster, but also the traffic that goes to external destinations. We have here also filters that you can easily filter this application. And we also detect non-API events, meaning that if your web application generated there was some traffic like images, and that's not necessarily interesting for you for your API traffic. So you can see also this traffic. So let's just see if there are some images that occurred. Okay, great. So that's some images from the website. If I turn this off, all these images disappear, and we can focus only on APIs. So we have a bunch of filters here that you can just concatenate and search for. So let's just search for the carts service, for example, and only one that contains items, let's say. So you can see that these filters are added, and you can see the same thing in the trends in the graph view. You can delete all these filters and go back to the normal view. And you can also drill down into the event to see all the details. And we currently don't have a provided or reconstructed spec yet. I will just show you in a minute how it is added and created. but we can go to the API inventory entry that is prepared for the cards, for example, API here. In the inventory, we automatically detect and create the inventory from the events. So we see that these are the microservices that were invoked. The same we have for external HTTP, and I will show you also how this is reflected in the events. So basically what we have here is the API inventory where you can set a provided spec for each API, or you can see the reconstructed spec that we learn and reconstruct from the live events that we just created in the SockShop application. So if we go to some API and check what was reconstructed, we go to the review phase where you can check and set the values that you want for the parameters. So here we are reviewing the spec for the cards microservice. And as you can see here, we detected just as parameter because we see that this value changes and fits to a parameter structure. You can also see from which entries this was created. So we detected this one, for example, this UUID as a parameter. So you can also unmerge any entry from here if we got this by mistake. And of course, you can give it a human name as, for example, user ID. And you can see that it is immediately changed. Let's say check changes as well. Let's say that's a card ID. That's user ID. That's probably an item ID. So once everything is in place, so you can again review anything that was created, any event that created this suggestion. And once you're good with the review, you can approve the reconstructed spec. It will be created from 5 entries. And in a second, you will just see the OpenAPI specification that is automatically generated with your input. You can see it here. You get the hit counts for it. You can also see this in the Swagger editor. We generate an HTML page with the Swagger information, so you can view it conveniently here. So it is important to say that no information leaves your cluster. Everything is done locally using port forward into the cluster, and this one generated within the microservices and can be accessed only within the cluster. So here you can see that we reconstructed all the parameters and fields. We also have the ability to reconstruct security definition and objects, and we can understand which objects were used and place them correctly. We also reconstruct file uploads and the type of fields, and we have more and more properties that we put into the spec. Yes, so that's how a reconstructed spec will look like. So if I go back to the API inventory again, I can see that the cards microservice has now a reconstructed spec. We also have the ability to upload specs. So here you can just upload any specification. You can just drag and drop or browse it. And then you can also get diffs of the live traffic against the specs. So let's just try to review some additional specs. Here it was a really simple API. Let's prove it. Basically, in several seconds, I can create the API specification for all the microservices in the SockShop application. Let's just keep it as param1 for now. So as I get more and more specs in place, if I now generate any traffic again in the SockShop demo application, I should see probably should see any diffs with the spec. So that can help us to detect zombie APIs as Zor mentioned, and also shadow APIs, which are not documented at all in the specification. And just let me show you in a second how it looks in the system. So again, let's just finalize the purchase to invoke as many APIs as possible here in the demo application. Sorry, I'm not registered. I just create some user here, complete the purchase, get as many as traffic as we can, to hit as many APIs as we can. Okay, so I think it's good enough. So if I go back to the API clarity, again, to the dashboard, I see that there are a bunch of traffic that was created just now. And as you see, there are different types of traffic now. There are new APIs that happened that I didn't do previously. And also I get diffs, which I can just click here and go right to it. So here, if I would have a provided spec, it will show me. But here we see a reconstructed spec diff. It means that, for example, here we see some tracing headers of envoy that were in the spec and which are not present in the current calls. So this actually we can ignore these headers as well, so they will not appear in the learning mode. So let's just see maybe several more examples to it. So now we have a diff against the provided spec, for example. So yeah, you can see that new APIs and more information was detected that actually is not in the provided specification. So that's how you can detect shadow and zombie APIs. And in the near future, we will, in the upcoming days, actually, we will show you also in the UI the different type of diffs, like I said, zombie and shadow APIs. So that should be real soon. So I think that's pretty much wraps the current capabilities of API Clarity. So you are welcome to clone it, fork it, try it out yourself. You can also build it with any demo application, even if you don't have a Kubernetes cluster or Istio running, to get the look and feel of it. So that's it. So back to you, Zor.
Thank you, Alexei, for this great live demo. And now we will talk a little bit about a few other comments that we have in roadmap session. So why did we bother to do all this? A new report from IBM Security X-Force has found 2/3 of cloud breaches can be traced to misconfigured APIs. Yes, 2/3. From that report, let me quote, APIs are fast becoming the technical basis for both B2B and B2C business models. As such, when APIs are developed and deployed, there is really no way to estimate all the possible places the APIs are going to get used. API are silently but rapidly becoming one of the most critical pieces of software supply chain. Organizations are now one vulnerable API call away from a potential major breach. So this was IBM, and it should come as no surprise that Gartner predicts that within the next few years, API abuse will move from an infrequent happening to the most frequent attack vector, resulting in data breaches for enterprises and web applications. So we started all this in order to be able to use it in our secure CN offering for Kubernetes security we are working on. Knowing the API spec is the first step to identify your API risks. Given the specs, one can also run fuzzing tests and automatically generate the client and server codes. The spec can also be served as a good documentation for future usage. The most important roadmap items we have is we already support today OpenAPI spec version 2. We can broaden the scope to support also OpenAPI spec version 3, GraphQL, and gRPC. Currently, we are integrated with Istio and Envoy. We should add more integration points like browsers, Postman, API gateways, and others. I want to call out the community to cooperate with us. 42 Crunch, that are also behind APIsecurity.io, and API Metrics, that are doing intelligent API monitoring, already accepted this challenge and will join us in maintaining API clarity. We will be happy to see more of you collaborating with us on GitHub. Thank you for joining us and enjoy the rest of DevNet Create.
Wow, didn't I tell you that this session was exciting? API clarity can really come in handy when you're working with multiple APIs, especially like third-party ones in your application, and you don't know what's going on when you get an error. I mean, I can see it saving a ton of time when debugging, and I probably could have used it many times when I was writing applications. And so, speaking of making life easier, then we would like everybody to be a DevNet member. So if you're on the DevNet create page, up in the upper right, register to be a DevNet member. We have API documentation, sandboxes, learning labs, and much more. There's a ton of resources available, and it is completely free. So go to developer.cisco.com and register to be a DevNet member. And you can actually win prizes during Create if you become a member. Eric, what do we have next?
Yeah, well, speaking of prizes, as we've mentioned a few times now, the Devi Challenge is going on. I was just checking in during one of our breaks, and it looks like a ton of you have been playing. Again, we have partnered with Secure Code Warrior as a way to help teach people best practices around developing secure code. And it's a little fun tournament. The top 25 people are going to go on to the next round called Devi Secures. And we encourage you to check that out. You can see there's lots of good high scores on there, but there's a lot of headroom too. So definitely go try it out. There are challenges there from anywhere from beginner to advanced coders. And I really enjoy the platform. I think it's a great learning experience for people. So I encourage you to check that out. Next up, we're going to transition into a talk from Brendan, still on the security track. And this is actually great from GitLab. We recently did a demo of API Clarity plus GitLab in the keynote. But this one is going to talk a bit about how to find the weakest link in your development pipeline and to actually make sure that it's secure. So let's check that out.
Thank you so much for having me. I'm honored to speak to you today, and I'm going to try and touch on a wide variety of topics. As such, I might only go an inch deep on a wide range of ideas, but I'm especially interested in your feedback and questions. The most important thing to take away from this talk is to critically think about how we look at the software we're making and all the various dependencies it has. And so you should start that critical thinking by thinking critically about my presentation. I'd love your feedback, questions, challenges, and ideas to come either as I'm presenting or after the talk. And first today, I want to talk about a story that's not new to our modern world, a story that has been a critical part underlying human society for, well, probably for as long as humans have had a society to speak of. Today, we might call that supply chain or logistics or infrastructure. Whatever you call it, as long as humans have organized themselves and created specializations, and then as long as we've had adversarial relationships with other humans, there have been what we would call today supply chain attacks. Many wars have been fought and won based on the basis solely of the ability of one side or the other to control or master their supply chain or that of their adversaries. In fact, in The Art of War, Sun Tzu writes, "The line between disorder and order lies in logistics." And in the technological age, the age where software has eaten the world, software is just reliant on supply chains as any other part of our human infrastructure. And software can be eaten by its own supply chain. My name is Brendan O'Leary, and I'm talking to you today from the East Coast of the United States, just a few miles outside of Washington, D.C. I'm glad we can be together remotely. It's something that I'm maybe a little bit more familiar with than others, since I've been at GitLab since 2017, and GitLab is a completely all-remote company and always has been, with over 1,300 team members in 65 different countries and regions, and we have exactly 0 offices. I'm currently working as a developer evangelist for GitLab, but I've had a lot of roles over my time here. I spent time building up a professional services organization to help our customers implement GitLab and DevOps best practices. And then for a time, I helped run our CI product, GitLab CI/CD, as a product manager. And before GitLab, I spent a decade in healthcare software and development. and some time as a contractor at the U.S. Special Operations Command. In all these years of software experience in very different environments, one thing has remained constant: the ever-growing list of dependencies that the software I was helping to build has to have in order to function correctly. And every once in a while, one of those dependencies goes terribly wrong. And that's exactly what happened in the SolarWinds hack, which has been such a focus in our industry for the past year. In fact, the hack itself wasn't a single event. It was a sophisticated, coordinated, focused attack that took months to execute. And it wasn't conducted against the main targets. SolarWinds, in this case, was part of a supply chain for the real targets: high-profile companies and US government agencies. The attackers intentionally sought out the weakest links in the supply chain of their targets. Instead of attacking head-on or through some sort of inflammatory attack aimed directly at their adversary, the attackers chose to hide in plain sight, blend in with the other software deployed, and then slowly exploit that point of entry for their real goals. And as we said, this attack method, just as any supply chain attack throughout history, is not a new one. In fact, another one of the victims to this attack and the team to first announce the discovery of the hack was FireEye. And in their report to NIST, the National Institute of Standards and Technology, as part of the United States Resiliency Project, warned of just this set of concerns. In cybersecurity, it's often not enough to have your own house in order. As targets or organizations improve their security posture, attackers will compromise less mature companies who can then be used as entry points to their real enterprise targets. And that's precisely what the SolarWinds Sunburst attack represents. Attackers could access SolarWinds' build system, where SolarWinds created the various packages that they distributed to customers. Those customers relied on the software that they produced, installed that software with expansive permission across their fleets, and accepted updates directly from SolarWinds. But for months, those updates were controlled by the attackers, giving them administrative access to machines across various government agencies and untold other enterprises. And we've said this attack was not a full-scale assault. It was calculated and slowly exploited. Given the manual way that their CI/CD was configured, it was relatively easy for the attackers to influence the build process once they had accessed the build infrastructure. These builds were done on a set of machines and then signed with SolarWinds electronic signatures. But since the attackers had taken control of the VMs, they were able to inject any malicious code they wanted directly into the build pipeline. Now, at first, they just tested this capability to see if they would be detected. A few months later, they decided to release the real payload, Sunburst, which took the Orion software and Trojanized it, allowing the attackers to monitor and attach to any system that the infected Orion update was loaded onto. From there, the attackers would deploy a third type of malware called Teardrop that was installed via the backdoor that Sunburst had opened for them. Of course, this practice of using dedicated VMs for the build and certification process isn't unique to SolarWinds. And as the CEO of SolarWinds aptly pointed out, they're not the only vulnerable party here. Many other enterprises and software companies use similar build processes and would be susceptible to similar attacks against their CI/CD infrastructure. In some ways, though, that's exactly what I want to talk about today. Because there are a lot of dependencies that exist in our code. Sure, most of us, when we hear dependency, think of that traditional open source dependency, a library I bring into my code to help me do a known set of things. It might help me access a specific type of database, interact with a known API, or control a particular device. Libraries may allow me to use the language that I'm programming in for a more specific purpose. And the use of dependencies is universal across software engineering. But what is a dependency? What do I mean when I say that? Because I want to be very specific here that when I say dependency, what I mean, is a very specific definition. And dependency is easily the most used word in this talk. So let's talk about that. Again, one of the most obvious things it can mean, and it's part of what I defined it as too, is an open source dependency. Those are the libraries we're familiar with that in theory help us move faster to the end goal of solving a problem with our software. I'm not telling you anything you don't know already when I say that this type of dependency is everywhere. Data from GitHub's State of the Octaverse report shows just how rampant open source dependencies really are. And that's just direct dependencies, called out in a package manager file as specific dependencies that a developer made a conscious decision to include into the project. But there are often a web of dependencies that come with those dependencies. Much like Inception, open source libraries bring their own dependencies along with them. Here, we see the transitive dependencies mapped by programming language, again, compared with direct dependencies on average for each project. As someone who programs in Node from time to time, I can attest that that line above JavaScript, it's real. Just come look at one of my Node modules folders sometime. There are a lot of dependencies listed in there. Okay, so that makes sense. There's the code we write and the open source libraries that we include in that code. Not much is new there. Many of us have seen that pattern before. But it's not just those libraries. It's also other third-party libraries we bring in. And those may be closed source, ones we're using to access the operating system, or ones from another vendor for using their API. That library would then be a dependency as well. And then, of course, both of those pieces of software probably have dependencies of their own. Other open or closed source libraries that are packaged into the software that we're actually using. That's how leftpad being removed from the NPM repository all of a sudden impacts basically everyone trying to build and deploy a Node app. They didn't add leftpad necessarily to their package.json file so that they could pad some strings in their own application. But instead, the libraries they were using for something like, like Ajax HTTP requests or logging information, those used leftpad, and thus the supply chain fell apart. But that's just the code that's a part of the code that we ship. What about how we ship it? Well, the DevOps process and how we handle that are also part of what we depend on to get code into production. Are the systems we build on the same ones that have the rights to manipulate the production environment? What if those systems were compromised? Would it maybe be better to separate build and test functionality from the deployment methodology or the packaging of our code for our customers? And then there's the production environment itself. Where are we deploying the binaries that get created? How are customers accessing them? Who or what do we depend on to keep those systems running? Well, it's a lot more third parties. Vendors for our CI/CD stack, for our production environment, and then those vendors use other libraries, some of it open source, probably most of it closed source. We might bring in third or fourth party plugins or actions that are written to work with our CI/CD infrastructure, but are written by some other unknown person or group. And all of these things purport to help us build code faster, ship to production sooner, and make our customers happy. But if we're not sure that we can do it securely, are we sure we're not the next group to fall victim to the kind of attacks we talked about? What really are our dependencies? Well, that's why I want to introduce, or maybe refresh and define, this concept of a software supply chain. The sum total of all of these dependencies is better defined as a supply chain. It makes it clear we're not only talking about the dependencies in the strict software sense of the world, we're talking about something a bit more complex. So, okay, you say it's more complex, Brendan. Well, then what is it? I understand a supply chain when it comes to manufacturing. You have a supplier of raw materials, and then you turn that into a finished product. But when it comes to software, how do we define a single supply chain? Well, for the purpose of discussion today, I'd like to propose that your software supply chain is the sum total of anything involved in getting your code into a production environment. Anything more restrictive than that definition, and we leave ourselves open to the ability to overlook important or critical aspects of software production. So we talked about some of what that includes. It includes, of course, our code, but also how is it created? How secure are the endpoints that our developers are using? It also, of course, includes all the open source dependencies our code has, and we went through that in detail. But again, what about the code that comes from other sources we're not thinking about. Packages in the operating system that we rely on, or those from a hardware vendor, or firmware on the hardware that we're using. Those are all aspects of our supply chain. And then often neglected are our DevOps and CI/CD processes. Where is the code built? Is that in a clean environment each time or a reused one? Where do we store the artifacts of the build? Is that in yet another system? And if so, what are the security permissions on each system that the code must pass through in order to get to production? Outside of that, are we bringing in other snippets of code into our CI/CD process? What other things are we depending on that we don't have direct control over? And then there's the environment. In many environments, the production system that the company runs are highly protected, and rightly so. If an attacker were to get direct access to an application or a database server, that would be extremely undesirable, to say the least. But once you've embraced the concept of a supply chain, then what really constitutes your production environment? What else should be guarded as we guard the systems that the production application runs on? Well, really anyone and any system that has access to production to manipulate it by virtue of that can impact production, right? If we're storing the root certificate that we use to sign our software on our same pet build server, which is exposed to the world, well, that server is just as much production system as our credit card processing database. And then really are developers and their systems part of production? Well, it depends on the safeguards you have in place and how your DevOps platform works. Either, looking at an intentional insider threat or maybe even a seemingly innocent security change. How your DevOps platform works and how you get code from developers' laptops to the systems that then have access to your production systems, that's part of the production chain. And as is the rest of the supply chain we just talked about, the security along that entire process impacts the security we're able to deliver to the application as a whole. So let's say you're on board. Your eyes have been opened and you see how wide the software supply chain really is. You can see links that are weaker than others most of the time, and you even have a few links in your company's supply chain that you know are weak already. Now what? How can we identify and mitigate these risks? Well, I think the first step is to identify all of them. In the same sense that, what is measured can be improved, you have to first know what your supply chain is before you can hope to protect it. Because if you leave something out at this phase and it's the weak link, then all of the other work you do with the other links in the chain will be wasted. Once you have a decent understanding, you need to set up proactive management of those dependencies moving forward. This cannot be an activity that just happens once, tightens up your boundaries and security, and then slowly degrades over time to the same state it's in now. And most importantly, you want to automate as much as possible. Understanding quickly where any known issue that arises might impact your particular supply chain is one of the most critical aspects of supply chain security. In GitLab's DevSecOps survey for 2021, we found interesting information about how teams have matured application security over the past few years. Even as over 70% of security professionals report that their teams have shifted left, that is, moved security earlier in the development process. But if you dig deeper, some curious dichotomies surface. Scanning certainly increased. We saw jumps of 10, 20, 30 percentage points year over year in teams scanning different parts of their code and their supply chain. Today, 53% of developers run SAS scans, 44% run dash scans, dynamic code analysis, and 50% of security professionals report that they scan containers, run dependency scans, and do license compliance checks. But while there are more scans run, most results aren't easily available. Only 14% of respondents say that they make scans available to their developers. Even the static code analysis that runs on the developer's own code isn't always available at the time that the developers are deciding to integrate that code together. That can leave a lot of gaps. In fact, the typical vulnerability goes undetected for 4 years. From the time it's identified until the time teams have actually passed their code, that's typically another 2 to 3 months. That is all time that attackers have a surface to attack your supply chain. So shortening the length of time from an issue being identified to it being resolved is one of the most productive things your team can do to secure your supply chain. But what about the 4 years that it's undetected, or even a best case scenario, a few weeks or months? Well, for that, I'm recommending what I'm calling supply chain defense in depth. For those who might not be familiar, defense in depth is a concept in cybersecurity and security in general where you layer multiple defenses so that if one method of security controls is compromised or one vulnerability exploited, you can limit the impact and stop the attacker with other means. For many organizations, this type of security is going to be a journey. In less mature organizations, even the idea of supply chain security, much less a defense in depth strategy, can seem kind of far-fetched. But as an organization matures, they'll have the ability to look more externally. And I believe that every organization, mature or not, can take proactive steps on each of these fronts that I've drawn here. 2 basic types of vulnerabilities, known and unknown, and then those that are internal to what we're building or external dependencies that we're using to build our code. For each square in this matrix, we can have a plan in place for how we're going to identify and mitigate those threats. And how we handle each of these really could be a talk in itself, right? Zero trust is something you hear about. It's a relatively mature pattern, but it's one that we're going to see expand over the coming years. And, even if you're not there yet, I think everyone should be able to expect their suppliers to produce, a software bill of materials so you can understand the dependencies you're bringing in. As you think through your security posture, figure out where it lands on this grid and identify your weakest spot and start there. Now, that can be kind of intimidating. So where can you start today? How can you leave this talk and make your organization less susceptible to supply chain attacks? Well, I think the first key is to understand your supply chain. If your team doesn't already have a clear diagram or map of those dependencies, start by drawing your own. And then publish it to the team. Don't worry about it being perfect or complete. Just get it out there. Once it's written down, it's much easier to iterate on. And then make sure that you understand all of the direct and transient dependencies involved in your environment and in production proper, but also in the infrastructure involved in getting code to production. And it's been said before, but making security a key part of your development process is also critical to ensuring that you have repeatable security where you can add protection and layers to make sure that all the links in your chain are considered. And of course, this is an ongoing process. It's not something that you just do once and then you're done. It's going to be an ongoing process where you have to establish kind of a method of always revisiting the plan and making sure that it's up to date. Thank you so much for your time today. Again, if nothing else, I hope you've thought of at least a few links in your chain that you hadn't maybe considered before. And while no one can ensure that all of our dependencies are security hole free or perfect, we can work to understand where our chain is the weakest and put reinforcements and depth of defenses there to help our organizations succeed. Thanks and stay safe.
Hey everybody, thanks for joining me here today. Today we're going to talk a little bit about modern observability in software development. My name is Josh Hendrick. I am a senior solution engineer with Rookout. I've been in the industry for a number of years and held a number of different positions from software development through DevOps, professional services, and solution architecture. So I have a broad range of experience across the industry. What we're going to talk a little bit about today is really starting from the beginning, where do we come from? Where are we today in terms of the evolution of software development? And why do we need these monitoring and observability capabilities that we have today? What is the real need for observability? What are some organizations doing in terms of constructing their observability pipelines so that they have all of the information they need, where they need it, and where it should go? And then we'll talk a little bit about dynamic observability, which is really kind of taking observability to the next level. And specifically, we'll talk a little bit about a tool that helps you decouple data access from code so that you can access and get better insight into your code while it's running in development, testing, or production environments. And at the end, we'll do a very short 5-minute demo just to kind of show you how that all works. So without further ado, I'll jump right into it. Looking back where we've come from, right? We really started developing what we now call monolithic applications, which were historically composed of these big bang releases, right? Where you have these tightly coupled applications. Organizations would release software every 6 months, every quarter, every year sometimes. And we found that that wasn't good enough to go as fast as we need to be going. There was a shift towards service-oriented architectures, probably 10, 15 years ago. That was kind of the buzzword, where we started to decouple these services that we were building into more of these coarsely grained services. And that shifted us to where we are today. A lot of the organizations that I talk to are shifting or have shifted to microservices-based applications, which really have a goal of being highly maintainable, agile development teams can build individual services. They're interdependently deployable, so you don't have to take the whole system down if you want to upgrade a specific component of your system. And so things have changed, right, over the years with software development. There's been a major shift organizations are taking from developing on-prem to the public cloud. Organizations, it's now normal to develop these hybrid architectures where you have some components on-prem, some components in the cloud. There's been a big shift from virtual machines or these static servers to containers, and a shift towards these container orchestration platforms like Kubernetes, for example. So Kubernetes has really become the standard for container orchestration. There's a number of other platforms out there, but most of the folks that I talk to are migrating or have migrated a number of their workloads into Kubernetes. And so this shift from monolith to microservices has enabled development teams to undertake hypothesis-driven development, if you will, where we have these small iterations. Teams can experiment a little bit more easily, get fast feedback on a new feature that they're introducing. If it doesn't work, quickly pivot and shift into something new. And it just makes life a lot easier on development teams. And so with all of these architectural changes, we need new ways to observe the software as it's running in kind of this new world, if you will. So that kind of brings us into looking at monitoring and observability, right? So I think it's kind of important to start distinguishing between monitoring and observability. Monitoring, if you kind of look back at it, it's really something that helps determine the state of an application. And really the way I look at monitoring is it's typically been kind of a set of predefined metrics that allow you to identify application or infrastructure issues, give alerts on predefined things that you want to know about while your application is running, right? So it's kind of an actual task of collecting some of these pieces of data, maybe displaying them in a dashboard and things of that nature. Whereas observability, if you look at the definition of it, right, it's really a measure of how well the internal states of an application can be inferred based on external outputs. The way it really works is by combining metrics, logs, and traces to instrument applications. A lot of times it requires writing more code. There's a number of different ways that you can integrate new logging frameworks or tracing frameworks, which we'll talk a little bit about in just a moment. But over and above all, they're really in the symbiotic relationship. Observability kind of taking things to the next level. And why the need for observability, right? We really have this need for fast feedback nowadays. Teams want to be able to be alerted immediately if something goes wrong. So you need this fast feedback about the state of your application, really on demand whenever you want it, right? So since applications are in this major paradigm shift, move to containers, orchestration platforms, microservices, service meshes, serverless applications, all of these distributed components are now ephemeral, a little bit more complex, right? With the scalability and the ability to pivot more easily, there is more complexity to deal with, more places where failure can occur, and having a very easily debuggable application, if you will, is definitely a key point when you're building a robust system, right? So the goal is to be able to deliver fast feedback about the state of your application, really anytime on demand, whenever you need it. One kind of architecture for building observability is kind of this observability pipeline, if you will. I kind of bring it up just to show what some organizations are doing as they become more and more advanced in the observability space. You don't necessarily need to go through all of this from the very beginning, but it's interesting to kind of take a look at, right? So developers are building these microservices, containers, sometimes VMs, that are producing logs from your application, metrics, traces, and they need some place to put those things, right? So rather than having each developer have to create custom code for writing all of this and sending it somewhere, a lot of times what organizations will do is create this kind of routing mechanism or single component that handles and feeds or takes as input, these logs and metrics and traces, and properly routes those to the right destinations, delivers alerts, takes the data and normalizes it into a specific schema. And it's really kind of the central processing unit that takes the data, sends it to your logging tools, your tracing tools, your monitoring tools, or event management tools. And kind of it has this nice flow of data from the services where the data is produced all the way to the components where they're consumed and viewable by developers, right? So I think as you build out your monitoring capabilities, a lot of organizations move towards architectures such as this. So kind of shifting gears just a little bit and taking a look at some of the standards around observability, I think it's kind of interesting, right? So open tracing got a lot of momentum, came out around 2016. It was broadly adopted by a lot of organizations that wanted a standard way of doing tracing within their applications. Open Census came out as well in 2018. And finally, in 2019, Open Telemetry came about, right? Which actually tied together Open Tracing, Open Census, and Open Telemetry actually just released version 1.0 of their SDKs and their applications. So congratulations to the Open Telemetry team. That's a great milestone. And really the goal of this was to be able to play well with existing network topologies, not be vendor specific, so that you're tied into a specific vendor. A lot of times what you have is different teams within organizations using different tools, different APM tools, different tracing tools, different metrics collection tools, whether it's Prometheus or Zipkin or Jaeger, or all of these different tools. The goal is to kind of really make one set of SDKs and APIs that organizations can use across all of their applications. And so those came about and really aimed to consolidate what was going on across the industry, right? So why is all that important, right? When you need to investigate a bug, really what you need to be able to do is observe it, right? If you can't observe the bug, you can't go about fixing it. So obviously many bugs are inherently hard to reproduce. A lot of times we're trying to reproduce a bug for days, weeks. I've talked to organizations that haven't been able to reproduce a bug and fix it for years, if you can imagine. So having deep observability into those environments is really key, right? And there's all of these different components that can play a role with finding and getting to the bottom of these issues, right? The state of your application, data within your environment is obviously key. Other service dependencies and configurations in your environment, the traffic coming into your applications. And these can all have different effects when you're changing these things, different side effects. They can affect the availability of your application, the cost to be able to go in and fix these. You need to analyze that. Is it going to affect your security or performance? So all of these are key things to keep in mind as you're going about analyzing some of these things. And so having the ability to observe your application and really be able to ask arbitrary questions of your application on demand as you need to is becoming increasingly important. You don't always know upfront exactly what you're going to need. Developers kind of get into this mode where they write a ton of logs within their applications, right? To be able to get information that they may or may not need. They don't always know what they're going to need ahead of time. So I wanted to kind of bring up this this category of dynamic observability tools that I think is pretty important. So being able to reproduce and get to the bottom of issues in the environment where they occur is incredibly important, right? So you need to be able to get to the data that's flowing within your application really at the level of your code anytime that you need it, right? So rather than having to log everything, you can use these dynamic observability tools that you can augment your existing logs with, or your existing metrics and traces, and get to the bottom of data that you need as you need it. So one look at the process that organizations take is kind of interesting to see, right? So when organizations and developers are needing to add new log lines or new information to their code to be able to access the information that they need to resolve a defect, they go through a usually complex process, right? So what happens is they'll typically add some code, some log lines, some tracing information, some metrics to their application. They'll typically need to run some test cases. Oftentimes they'll push that to a repository, maybe GitHub, Bitbucket, whatever it may be. They'll open a pull request. Most organizations have CI and CD processes that execute. So you're waiting for your continuous integration process to run. You're getting approvals oftentimes for that change to be pushed to your environment. You're waiting for that build to happen. You're deploying it. Then you're waiting for that new code change to drop. And then you're trying to search for the data that you need. So rather than having to go through all of this all the time, dynamic observability tools can come into play, which can basically bridge that gap, right? And get you directly from the point where you're needing to add all this information to your code right to the point where you can get that data on demand as you need it. So just a quick look, and this is going to kind of lead into the quick demo that we're going to do. Just a quick look at how it may be deployed into an environment that you have, kind of digging into the technical level now. So this is an example with Kubernetes. You may be deployed in a different type environment, but essentially a lot of these tools, from open tracing to these dynamic observability tools that we're talking about, a lot of times there's an SDK, sometimes an agent that you may install within your application. In the case of Kubernetes, you can see here, it could be within a pod within your Kubernetes cluster. And they allow developers to remotely interact with the application, collect data on demand from the environment. And really that happens by going in and setting data collection points within a running application to collect snapshots of data, things like local variable values, stack traces, profiling information, tracing information, on demand whenever you need it, right? So it kind of relates back to this notion of being able to access any data that you need from your application on demand whenever you need it. And that's becoming more and more important, right? So that kind of leads us into the demo. So I kind of want to switch gears and switch over to Rookout, our demo application, to show you a very quick demo of how you can actually use this within your environment. So let's say I have, just like my slide showed, let's say I have an application that's deployed in Kubernetes, and I want to be able to go in and ask some questions of that application, right? I want to be able to collect some data and understand what's happening while the application is running. That application may be running in the development environment, may be running in a test or QA environment, and may be running in a production environment. And what I want to be able to do is start to debug those instances on demand without having to make any code changes. So with Rookout, what I can do is I can go in and I can immediately tell it which instances in my environment, maybe microservices, that I'd like to debug. In my case, I have a Java application that's running. It's actually running in Google Cloud. It's running within a Kubernetes cluster. And it has the Rookout SDK that's been configured and attached to it. So what I'm going to be able to do now is whenever a customer or myself go in and interact with the application, I'm going to be able to immediately get some feedback on what's happening within my code, within the application, really on demand as I need that. So I'm going to go in to Rookout, and I'm going to select the instances I want to debug. Typically, that'll be based on a host name or a pod or an IP address, or even a custom label that I can attach to my instance. So I'm going to type in a label. I'm going to choose it. And you can see I have 13 instances where I've actually configured Rookout. And I want to come in and I want to debug one of them, right? This instance is my to-do application that you can see the host name, which is a Kubernetes pod name, the repository, the GitHub repository that's tied to it. So this is the instance I want to debug. And I can go ahead and actually click next and jump in and immediately be ready to start debugging that application. So the first step is actually to connect in to my source code repository, right? And you may do that by connecting in and authenticating to your GitHub or Bitbucket repository, or even a locally cloned file system repository that you have. Or even better, we can actually automatically reach out and fetch the repository, because as you can imagine, you may have different versions of code running in development and test and production. And you can configure this to automatically go out and fetch the right version of code for the environment that you're running in. Once you've done that, you have the ability to, just like an IDE within your local environment, open up source code files and start to debug them exactly while they're running, really without stopping them, without having to redeploy them or change any code. So the process of doing it looks very similar to how you would debug an application within your local IDE. So I've opened up one of my Java files that actually has some business logic that gets executed whenever I add a to-do item to my to-do list, right? So I have a function here called add to-do. And what I'm going to do is I'm going to go ahead and set a data collection point within this application. So you can do that simply by clicking on a line directly next to the application. And so what I've done is set a what we call a non-breaking breakpoint on line 45, where you can see I have a log line on line 37, but maybe I want to collect some data from a part of the code where I don't have a log line. And kind of like we talked about, without having to go back and change things, I can immediately get some feedback on line 45 or any other line within the code where I'd like to set a data collection point. So I can come back within my application, maybe add a to-do task to my list, and then immediately come back in to Rookout and see that we actually collected some data. So within Rookout, I can click on that line, and we can see that we captured some interesting information. So we collected all of the local variables, all of their values, all of the attributes and different objects and their variables and values. And we can immediately see that information regardless of where it's running, even in production. So I can kind of observe dynamically what's going on within that application on demand. You can even kind of dive deeper, understand where it's running server and process information. So I can see the Kubernetes pod or IP address where that application is running. I can get some insight into a stack trace, so I can actually see how we got to this line of code, and even have the ability to set data collection points in other areas of the code up the stack that may have been called through this call chain. And then I can even, kind of as we talked about, pull in tracing information. In this case, it's from Jaeger. As long as you're using Open Tracing or Open Telemetry or any tool that supports those, we can actually pull in information, and you can sync this with trace IDs and span IDs and understand where this transaction fits in the context of a larger trace or a larger span. I can also take all of this data, I can send it to any existing logging framework that I might be using. So whether you're storing data in Elasticsearch or Splunk or wherever you might be sending that, you can send data there as well. So you're maintaining that data in kind of a consolidated central place. And then I can even come in and do a bunch more things, which we're not going to get into today. Let's say I wanted to set a condition where I'm only collecting data from specific users. Maybe I'm doing data redaction for PII or sensitive data within my code. There's a ton more that you can do. This is really just a taste of some of the capabilities of a dynamic observability tool as it's running within a production environment. But that kind of gives you a little hint of how things are working, and some of the importance of really having a deep level of observability within your application, right? So to kind of tie it all together, if you haven't started yet, get some observability, dynamic observability components within your environment, just to make understanding what's going on really as easy and seamless as possible. If you have any additional questions for me, please feel free to ask. Also happy to interact with you offline over Twitter or email as well. Thank you.
That was such a great session. If you haven't all noticed the trend yet, there's been a ton of talks over the past 2 days about observability, something that we see more and more software developers needing to understand how to get that observability into their applications. So really love that session to understand a little bit more about some of how people can approach it and get some more insights out of that, whatever metrics they're collecting. So next up, I wanted to talk a little bit about, remind you all, we are doing a Bright Funds campaign as part of this event. We wanted to make sure we were trying to help drive some of the tech for good that you've been hearing about throughout. So we do have a campaign. We are encouraging everyone to donate. We are also doing some donations, but all of those will go back to one of 4 different funds. We have the Girls Who Code, Braven, Human Rights Campaign, and Southern Poverty Law Center. And we really wanted to just be able to help enable some of those organizations to do the good work they're doing, to help enable better STEM access, to help fight some of the disparities that we see in our culture today, So it was a great opportunity to partner with the community, and we thank you all for helping support that. I've seen a number of donations come through. Jeff, I know you've been active in that space. Anything that jumps out at you in there?
Yeah, I really thanks, Eric, and I'm really excited about all the give back opportunities here, and specifically, I'm excited about the Tech for Good sessions that we have coming up. There's, it's I mentioned it before, but DevNet Create to me is just really all about people supporting other people back in their communities, doing things for them, and it's gonna be really fantastic. I'm excited to see more of this. And if you have an idea or something you've contributed to a community you want to showcase, you can email us at devnetcreateforgood@cisco.com and tell us about your story. Now, coming up next, we have the session from Adrian Moharic, because nobody puts docs in the corner. Just saying. It's gonna be fantastic. She goes into everything from being a product manager all the way to a tech writer, how to write better docs, how to make them more successful for developers, all of that. So stay tuned for that and share anything you want to know on social. #DevNet, #DevNetCreate. We'll see you back here in just a minute.
Hello, my name is Adrian Moharic, and I'm a developer experience engineer at Cisco. I work with many teams within Cisco to improve the developer experience of Cisco's APIs through their documentation, which is what I want to talk to you about today. I'm going to explain to you why you should care about the documentation of an API, how the API documents are usually treated, how you can help improve the docs no matter what your job role is, and provide you a handy tool to help your team create great API documents. So let's talk about first impressions. Developers refer to the documents to make their first API request. Their ease of use of the API affects adoption of the API. For example, imagine having a hard time getting started with the API. You may get frustrated or confused. However, common side effects of good documentation and easily making your first API request successfully include, but are not limited to, experiences of joy, a sense of accomplishment, a positive attitude, a self-high five, a win-win attitude, a good spirit, and hope for the future. So a good first impression is what we're striving for. I think one of the ways we can provide developers with that satisfaction is through simple and clear documentation. What do you mean putting docs in a corner? Well, I'm glad you asked. I've experienced the release of an API similar to this process, and I've noticed when an API is being built, docs aren't usually top of mind. They tend to get thrown over to the tech writer to figure out. For a REST API, the Open API specification document may include all of the features of an API, but the examples in the document shouldn't include foo and bar, which makes it harder for developers to understand the context. Also, top use cases and the developer story aren't clearly documented in the introduction of the document. If developers aren't sure why the API should be used, they may not use it and use a competitor's API instead. If you're thinking, but I'm not a tech writer, what can I do? Well, I've got good news for you. If you're in any way involved in the API, you can help improve the docs. Pick a role that most closely resembles your role and see how you can help. Product managers can ensure everyone involved with the API understands the developer story and top use cases. This ensures everyone is on the same page when contributing to examples. They can kick off the creation and workflow of the docs at the beginning of the API lifecycle instead of closer to the end. And of course, the product manager can ensure the docs get updated with every update to the API. If you're an engineer, you can provide code samples for common use cases, generate machine-readable definitions of the API, and clearly define successes and errors to help developers with troubleshooting. If you don't know which language to write the code samples for, ask your customers what they use. Tech writers can enhance descriptions and examples to closely resemble real-world examples. But wait, there's more. Now that you know what you can do to help make the document successful, here's a tool to add to your tool bag. Call today to get access to the DevX doc checklist to help ensure that the documents clearly and easily help a developer use the API. As you can see, the checklist is pretty long, So we've split it up so that the developer advocate and the tech writer who didn't write the docs use this checklist to review the docs prior to publishing. Not everything is required. The checklist also includes recommendations to provide room for improvement. So if you're interested in that checklist, you can download it here. Grab your phone, take a picture of the QR code, or type in this URL. You will also be able to download the checklist on the DevNet Create website where the videos are being recorded. This special offer will last long. We're giving it to you for free. No taxes or shipping and handling fees added to this exclusive offer. No signups or annoying pop-ups either. So, with Patrick Swayze on your side, your docs can fly. Thank you.
Oh my God, isn't Adrian hilarious? I mean, documentation never gets any love, but it really should. I mean, as she has said, if you have poor documentation, it's going to just push developers away, and because they get very frustrated and just like don't want to use your APIs anymore. So definitely download the DevX doc checklist on the DevNet Create site. And then also, always, you should connect with us. Follow us on Twitter at Cisco DevNet or me at Denise T. Kwan, and connect with us. Use the hashtag DevNet and DevNet Create.
Awesome. Yeah, thanks, Denise. And it just throwing out there too. If you want to chat with any of us, mine's probably right down here someplace at Jeff Full Tech. Just find me on the socials. We'll chat. So all these innovative sessions, what Adrian just talked about for docs, and all the rest of the sessions have just been, they're inspiring and motivating. They make you want to go try something new that you haven't tried before. And I think that's no better showcased in the next 3 sessions. We've got some highlights from the Cisco teams across Latin America, which would be a really amazing session. Rob from Cyril is back talking about Istio and Linkerd, and examples to improve service meshes, apparently. And then Dan and Max are going to be talking about how to use digital twins for AI-driven testing. Really good content. Stick around for those. We'll be back in here in just a little bit. And like we said, follow us on social, chat in the Q&A. We'll see you back here in just a little bit.
Hola, muchas gracias por acompañarnos en este segmento de DevNet Create diseñado específicamente para Latinoamérica. En los siguientes minutos escucharán de diferentes expertos sobre la importancia de la programabilidad y la monetización, así como algunos ejemplos de casos de uso. Muchísimas gracias. Los dejo con Miguel Barajas.
Muchas gracias, Mariana. Y fíjate, es bien interesante cómo las aplicaciones realmente están haciendo que todas las plataformas también empiece a hacer una automatización para este mundo del cloud híbrido. Y algo bien interesante es que el 43% de las organizaciones están intentando hacer releases mucho más prontos y mucho más de manera rápida para su infraestructura, pero para eso realmente están buscando que para el 2023 el 60% de las organizaciones van a estar utilizando automatización para la infraestructura como parte de su cadena de DevOps. ¿Esto qué quiere decir? Pues básicamente que el despliegue de las aplicaciones, de la infraestructura, de las plataformas va a ser mejorada en un 25%. Otro de los temas bastante interesantes aquí es que para el 2025 más del 90% de las organizaciones van a tener un arquitecto de automatización. Para el 2023 también el 40% de la infraestructura que va a ser aprovisionada en premisas va a ser desplegada por medio de infraestructura como código. Y realmente cómo DevNet nos está ayudando a llegar a esta misión. DevNet es, a final de cuentas, cómo Cisco va a estar ayudando a sus empleados, a nuestros clientes y a nuestros partners a crecer en esta economía moderna del API, ¿no? Y pues realmente esto nos va a permitir crear una innovación mucho más sencilla para poder ayudar a los desarrolladores a crear soluciones alrededor de las plataformas de Cisco. Y por último, DevNet lo que nos está ayudando es a crear realmente una carreras y negocios para los desarrolladores. ¿Y cómo estamos haciendo esto y por qué lo estamos haciendo? Nuestros clientes están empezando a necesitar que realmente Cisco les ayude a automatizar su infraestructura, pero no solamente a automatizarla, sino también a conectarla e integrar estos sistemas independientemente donde estén desplegados estos. Puede ser en las premisas, puede ser en un cloud, puede ser en el otro. Realmente vivimos en un mundo multicloud. Y obviamente la programabilidad y el exponer estas APIs es el motor que le va a ayudar a nuestros clientes a transformar sus negocios. Esto obviamente nos va a permitir que hagamos también infraestructura y hagamos plataformas para poder automatizar nuestra infraestructura, no desde cero, sino también podemos ver que tenemos muchas integraciones ahora mismo y algunas que vienen, ¿no? Por ejemplo, con la ayuda de Red Hat Ansible, con la ayuda de Terraform y con la ayuda de Consul, nos va a permitir automatizar nuestra infraestructura como si fuera código. Esto es un concepto bien interesante en el cual vamos a poder automatizar de manera declarativa en vez de imperativa. Y como podemos ver, muchas de nuestras plataformas o la mayoría de nuestras plataformas ya están listas para ahora y para el futuro. Entonces, sin más, le voy a dar la palabra a Mónica, que nos va a estar platicando qué están haciendo nuestros clientes y nuestros partners alrededor de esto. Muchísimas gracias.
Muchas gracias, Miguel. En verdad, la programabilidad es un elemento esencial para la transformación digital en las organizaciones. Y para eso, veamos qué hay en LATAM. En Brasil, André Gustavo Albuquerque nos comenta que para iniciar el proceso de adopción en automatización de infraestructura con los clientes, se debe de trabajar con pequeños casos de uso que generen valor, beneficios y resultados rápidos de ellos. De hecho, lo mismo comenta Robert Landírez en Ecuador, que nos va a explicar en el video unos casos de uso de SD-WAN y automatización.
En arquitectura de Network Transformation, cada vez más nuestros clientes están buscando opciones de automatización. Y como se imaginarán, siempre hay diferentes clientes con diferentes requerimientos, con lo cual es usual que no exista una única solución que satisfaga todas las necesidades. Una de las grandes ventajas que nos brinda la programabilidad es la posibilidad de extender las capacidades que tienen nuestras soluciones fuera de la caja, para integrarlas de mejor manera con los procesos de negocio de una organización. En este orden de ideas, una de las oportunidades que tuvimos el año fiscal anterior de explotar esas capacidades fue con un cliente de Centroamérica. Ellos habían adoptado una solución de SD-WAN Viptela. Si bien es cierto con Software Defined Networking ellos ganaron la capacidad de definir por software el comportamiento de su red desde un lugar centralizado, adicional a esto ellos andaban buscando la capacidad de poder tener esquemas de calidad de servicio que cambien en función del tiempo. Básicamente ellos buscaban que durante horas laborables el tráfico de actualizaciones de software de las computadoras de los colaboradores fuera bloqueado y al mismo tiempo que el tráfico de videovigilancia fuera un poco más restringido. Por el contrario, fuera de horas laborables, más bien buscaban que se permitan las actualizaciones de software de las computadoras y que el tráfico de videovigilancia fuera priorizado. Ahora, esta capacidad no es entregada fuera de la caja por nuestra solución de SD-WAN. Sin embargo, utilizando el ecosistema de APIs, pudimos construir una aplicación basada en web. Esta aplicación nos permitía cambiar las políticas centralizadas de la fábrica de SD-WAN basados en el tiempo. Como ustedes ven, la interfaz es bastante intuitiva. En un inicio me muestra una pantalla de login utilizando las credenciales del controlador. Luego me muestra cuáles son las políticas que ese controlador tiene configuradas. Y finalmente, luego de seleccionar sobre qué política yo quisiera actuar, me permite a mí agendar en función del tiempo durante qué espacios yo quisiera que esté activa esta política. De esta forma pudimos liberar al team de operaciones de esta tarea repetitiva que era necesaria cada vez que se requerían cambiar las políticas de calidad de servicio de acuerdo a lo que se necesitara. Si pensamos acerca de esto, cualquier tarea repetitiva que nuestros clientes están ejecutando en la infraestructura, cosas como por ejemplo colectar información de la red, apagar puertos no usados, actualizar versiones de software, todo esto puede llegar a ser automatizado utilizando APIs. Luego, en una siguiente fase, podemos apalancarnos incluso en esas automatizaciones básicas que se realizaron al comienzo para crear flujos más complejos y de esta forma poder acompañar a nuestros clientes durante el ciclo de vida de las soluciones y al mismo tiempo entregarles más valor. Controladores de SDN como el DNA Center o el vManage proveen fuera de la caja características muy poderosas de automatización y nuevas herramientas para monitorear y hacer troubleshooting de la red. Sin embargo, nosotros podemos combinar esas capacidades que nos brindan los controladores junto con programabilidad, para de esta forma conseguir nuevos casos de uso de automatización y orquestación y una mejor integración con los procesos de negocio de nuestros clientes.
Como vieron, la automatización tiene grandes beneficios hacia los clientes y no podrían implementarse sin el apoyo de los canales, los cuales tienen hoy en día actividades de innovación, los cuales Citlali Amoros y Paula Carrillo nos van a platicar.
Hola, hoy queremos compartir con ustedes el trabajo que como LATAM Partner Organization hemos estado realizando con el fin de involucrar a nuestros partners con la programabilidad y cómo ellos están avanzando con respecto a agregar valor a través de soluciones automatizadas, integradas e innovadoras utilizando DevNet. Hemos estado realizando actividades de habilitación no solo con la finalidad de desarrollar prácticas en torno a la programabilidad y DevOps, sino también la forma en que se pueden adaptar rápidamente a las necesidades de negocio. Además, queremos construir una comunidad orgánica en la que compartamos continuamente información, así como mejores prácticas. Iniciativas como DevNet Sensei, donde la idea es llegar a esa comunidad de negocios para impulsar la cultura del intercambio de ideas. La forma de hacerlo es concentrarse en ciertos pain points que nuestros partners puedan tener, trabajarlos con ellos y mostrarles cómo se pueden resolver usando la programabilidad y aprovechar este conocimiento con una atractiva competencia. Además, iniciativas como DevNet University, donde habilitamos a las áreas comerciales de nuestros partners en cómo vender la programabilidad, guiarlos en la estrategia y la ruta de aprendizaje, además de cómo ejecutar este nuevo modelo de negocio y de operaciones. Además, hemos estado realizando sesiones generales de Voice of the Engineer, donde mostramos los casos de uso más importantes y todas las herramientas que DevNet nos proporciona.
Sabemos que la transformación digital es un proceso continuo, el cual abarca todos los aspectos del negocio a nivel de una organización. Conscientes de la naturaleza de nuestros partners, que es tener foco en networking, con poca experiencia en programabilidad o con un área de desarrollo incipiente, los apoyamos a descubrir su nivel de madurez digital con respecto a las prácticas de DevOps y DevNet y en conjunto creamos un plan de transformación a la medida. El reto ahora que tenemos es cómo reimaginar aplicaciones. A veces la mejor manera de hacer la diferencia es hacer las cosas distintas. Como por ejemplo producir a partir de una aplicación sobre cualquier arquitectura Cisco que pueda ser eventualmente monetizable. Eventos como un Virtual Hackathon nos permiten desafiar a nuestros partners a desarrollar un mock-up, integrando sus ideas innovadoras y casos de uso específicos para mostrar valor a sus clientes mediante la adopción de APIs. Todas estas actividades nos permiten incentivar a nuestros canales a identificar los beneficios de la programabilidad, adaptarse a los cambios de la industria e incentivarlos a alcanzar la especialización en DevNet. Actualmente en LATAM contamos con 4 partners con la especialización en DevNet, con cobertura en México, Centro y Sudamérica.
Muchísimas gracias por acompañarnos en esta sesión de DevNet Create. No olviden visitar developer.cisco.com.
Hi, welcome to DevNet Create. I'm Rob Richardson, and let's talk about service mesh to service mesh. Do I need a service mesh? What is the impact? What choices should I make? Let's dive in. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. I've been that person chasing the speaker, and it's never worked out for me either, which is why you can go to robrich.org, click on presentations here at the top, and here's service mesh to service mesh. You can view the slides there online right now. While we're here on robrich.org, let's click on About Me and see some of the things that I've done recently. I'm a Microsoft MVP, a Docker captain, a friend of Redgate, and a Cyril developer advocate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start Friday after work. Sunday afternoon, we deliver the completed software back to the charities. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp near you, hit me up on email or on Twitter, and let's get a Give Camp in your neighborhood too. Some of the other things that I've been doing, I work a lot with containers with Docker and Kubernetes. And I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into service mesh to service mesh. We talked about this guy. Do you remember when you learned to drive Do you remember that liberating experience, how you could now travel great distances? Let's imagine a country road, a small town where you can drive as fast as you want to. That would be fun for me too. In time, we may end up in something like this, where there's lots of traffic that just congests the road really badly. Well, now what? Well, let's set a traffic cop on the edge of town. Anyone who's going too fast is going to get slowed down. He works to ensure that we're all uniformly traveling through town. Now that's great, but we're optimizing for uniformity, not for expediency. What we really want is something like this, where our cars can communicate together, prioritize traffic, emergency traffic, and those that need to want to go really fast can go in one spot. Those who want to take a more leisurely pace can do that as well. By letting the cars communicate, we can now move more efficiently rather than just uniformly. We'll see similar analogies as we move into service meshes. We're going to take a look at service meshes, compare them to what came before, and take a look at a demo of both Istio and Linkerd. Let's dig in. So a service mesh is that thing that stands in between all of our services. It allows us to manage network traffic in a very graceful and scalable way. In short, it's the answer to how do I observe, control, and secure the network in the communication between my microservices. So observe. We're going to watch all of the traffic go through our cluster and be able to see how it functions. Then in time, we'll be able to understand what normal is and be able to start to craft that based on policies within our service mesh. We can also create mutual TLS between our services, and we do this inside the service mesh so we don't have to add this additional code into each microservice. Observe, control, and secure. We started out with a monolith, and the interesting thing about a monolith was we could deploy all of the pieces in one go. As we got closer to containers, we could start to deploy microservices, and we could iterate on individual pieces as often as we needed to. On the left, our internal pieces are internal. On the right, our internal pieces have IP addresses. How do we secure the traffic between our microservices? Now, as we talk about microservices, we'll talk about both north-south and east-west traffic. North-south traffic is traffic flowing into or out of our Kubernetes cluster, where east-west traffic is traffic flowing between our microservices. So in this diagram, we have north-south traffic coming from our user interface into our cluster. We also have east-west traffic flowing between our microservices. Well, what came before? Well, before we had API gateways. Much like the traffic cop at the edge of town, this is a fence around our cluster. An API gateway is great for being able to monetize or throttle traffic coming into our cluster. But once inside of our cluster, our API gateway knows nothing about the traffic flowing around in our cluster. So in this case, our microservices aren't following the rules of connecting only to their own data stores. If we had a mechanism where we could observe, secure, and control this traffic, we might be able to prevent that unwanted traffic flowing between microservices and other data stores. Sadly, an API gateway doesn't have any visibility into this and can only be that fence around our traffic. So how does the service mesh work? Without a service mesh, if service A wants to communicate with service B, it just does. It opens a socket and connects. With the service mesh, inside of the pod associated with each service is deployed a sidecar proxy. Now these are in one pod, so all of the traffic between these is in a very isolated network. So if service A wants to reach out to service B, service A will first reach out to the sidecar proxy that got deployed with it. The sidecar proxy will go check in with the control plane. Am I allowed to accept traffic from service to service B? In this case, we'll say yes, and it will create that connection to service B's proxy. Service B's proxy will check in with the control plane as well. Am I allowed to accept traffic from service A? In this case, we're going to say yes, and it'll forward the request on to service B. The response comes back through, and we've now completed the request. Now for east-west traffic, it'll work exactly like this. For north-south traffic, we may choose to make this an ingress or this an egress, and we can do exactly the same, routing our traffic through the sidecar proxies, which check in with the control plane to validate that connections are as they should, and ultimately allow traffic to flow between the services as we need to. Now the cool thing here is that we have this optional mutual TLS connection that allows us to secure connections between our sidecar proxies, and we didn't need to change the code in our services to make this happen. Now, this is the mechanism of a service mesh. All our traffic flows between these sidecar proxies. Now, because we have these sidecar proxies that can observe, control, and secure the traffic, we can actually level up and do some really interesting things. We're proxying between all of our services so we can watch the traffic move between them. We can then make decisions based on policies to say, no, you really can't connect to this thing. And we can secure via mutual TLS to ensure that no prying eyes can see the traffic flowing through. But let's level up a bit. We can create network topology diagrams. Let's watch the traffic and identify which services connect to which. We can view service health, keep track of which services are throwing non-200 status codes, and we can log this traffic so that we can understand the health over time. Let's level up again. It's more than just a proxy. Because we're proxying all traffic between all the things, we can start to do some intelligent routing. So for example, we could do A/B testing, where we have two different versions, and we can validate that our system functions better or worse with the new version. Once we've identified based on the results of our experiment, we can lean into that to optimize our user experience. Perhaps we want to create a beta channel where users can use new features sooner without having to wait for releases. We can get early feedback and we can tune those features for our other users. We can also create circuit breakers. Now, if a service is having difficulty and may tip over, all of the clients are going to notice that. And of course, if they think it's a transient concern, and they'll retry. So as the service comes back up, it'll just get flooded with all of this additional traffic. Now, we can create a circuit breaker that will just stop all the traffic to this service and let it recover gracefully, let it come back up to speed, and then open back up and let the traffic flow to it. Now, unlike the circuit breaker in your house, you don't need to walk up to the panel to reset it. The circuit breaker here will do that automatically once the service is ready. So we also get some really elegant dashboards of visualizing our traffic flowing through our system. This can be really elegant. So we want to prevent unexpected traffic patterns. We saw how microservices call into each other's data stores. We'll need to work with our developers to ensure that they code their applications differently, but we can very specifically block unwanted traffic patterns in our cluster. So which service mesh should I use? Istio, Linkerd, Console, Open Service Mesh, others? Now, as we compare features, they're all moving very fast. So we don't want to say this one has this feature. Instead, let's compare them by methodologies. When we first look at Linkerd, Linkerd likes to own the entire system. They're really good at contributing to the Rust network stack, but all the things inside of Linkerd are pretty much built by Linkerd. They have a really elegant startup experience, and we'll get to see that in a moment. By comparison, Istio is kind of the kitchen sink. They like to bundle the best of open source packages and allow you to turn things on and off based on flags. Now, in both cases, they have that same methodology of creating a sidecar proxy and routing the traffic through the sidecar proxy, checking in with the control plane. So let's take a look at both Linkerd and Istio. We'll start with Linkerd. So Linkerd is a really great startup experience. So let's come to the Linkerd docs, and we'll download the Linkerd CLI, and then we'll do a Linkerd check -- pre. After that, Linkerd install, pipe it to kubectl apply, and I've done both of those. Let's next run Linkerd check and validate that our system is as we expect. Yep, it looks like the system is running just fine. There's an upgrade that I can grab. Next up, let's go grab the dashboards. Now I'm going to take this and apply it into place. And now it's going to run each of those dashboards, getting all of that content into place. Now that's great. Next up, I can start to validate that this works. We can do a Linkerd check again. And what I like about Linkerd check is not only will it go check to see if all the things are running, but in this case, it's going to wait for my visualization tools to spin up until it's ready. Once we've got the visualization tools ready, we can now dig into each of the dashboards and start to explore Linkerd. Now, Linkerd does have a great sample application, and we won't have a moment to dig into that today, but let's grab this Linkerd dashboard and visualize how it works. May take us a minute to get the content installed. Go, 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 go. This is definitely one of those bandwidth constrained operations. There we go. We've got the dashboard installed. And so let's fire up Linkerd's dashboards. Perfect. Now we're going to fire up this dashboard. We've got all of our content in place. Let's take a look at the Linkerd namespace because Linkerd does proxy the traffic to the Linkerd dashboards, the Linkerd content. And let's pop open the Grafana dashboard for one of them. Now, this cluster hasn't been running very long, but we can already see traffic patterns associated with this content. That's great. Now, if we want to look at this content, we can also pull metrics associated with this through Prometheus, but we can also pull, not that one, we can also view these visualizations from the command line as well. So here's the stats associated with all of them. We can see the success rate, the latency, and the number of connections that have been connected to each of our containers. That's great. Now let's turn off Linkerd. There we go. And let's flip over to Istio. Now, in a similar way of Linkerd, we can go to the Istio Getting Started page. We will download the Istio CTL, CLI, and then we can launch into one of the demos. Now, they do have a really great demo of a bookstore. Here's the bookstore application, and we can see here's the product page. The product page reaches out to the product details page, microservice, and it also reaches out to the reviews service. We see that with version 1, there are no stars. With version 2, the stars are in black color. And in version 3, the stars are in red color. The black color and red colored stars also reach out to the rating service so that we can see how many stars we should display. So we just got those set back up so that we have all 3 of the star colors in place. And now let's take a look at the Istio dashboards. First up, we'll take a look at Istio CTL dashboard Prometheus. Now the Prometheus dashboard allows us to look at the metrics harvested from Prometheus. So for example, Istio request total, and I can see each of the requests and all of the details. Execute. Demo fail there. As we move into visualizing this content, we may choose to visualize it with Grafana. So let's flip over to the Grafana dashboard. And we can now take a look at that Istio content pushed into Grafana. So we have some default dashboards, and we can see that our control plane hasn't been running for a real long time, but we get to see some really great metrics about both the Istio and our application. Next up, let's take a look at the Jaeger dashboard. And the Jaeger dashboard is really good for visualizing interactions between our system. So if we take a look at our product page and find traces, we can see that it started here and then it called this one and then it called this one. If we're looking for a slow place in our application, this reviews default seems to be taking a really long time getting from the results of this call into the results of this call. That can be a really elegant way to diagnose system failures here with Jaeger. Next up, let's take a look at Kiali. What I like about Kiali is it allows us to build a network diagram of our system. So I'll log in here and pull up the graph. Now it's definitely a real-time system. So let's come back in here and refresh our page and get some traffic with each of the colored stars. And then coming back to the Kiali dashboard, we can take a look at not just what the developer thought was going to happen, but we can see what's actually happening. The product page goes to here, and that goes to the review service, and it will go to each of those review pages. If we refresh another time or two, we'll probably see the connections into, there we go, into the rating service. Now, what's elegant about this is what's actually happening, not what the developer thought was happening. So for example, if we don't see our connections to the rating service, Or if we don't see the connections to the reviews service, maybe we left in a debug statement that omits the traffic and uses simulated results instead. Kiali is really good at being able to compare to our developer notes. So that was a really elegant tour through the dashboards associated with Istio. And we can see that methodology where Linkerd focuses on an easy setup experience and Istio focuses on a kitchen sink. So what do we see? Well, from the crawl stage, we have monitoring, logging, and service health. When we go from crawl to walk, we have intelligent routing where we could create A/B channels and canary channels. And finally, in the run stage, we get a really elegant network topology diagram where we see what's actually happening, not what the developer thought was happening. Now, should I use a service mesh? Service mesh is not for free. On the left, we have all of the details associated with Kubernetes. We have the Kubernetes control plane. We have all of the pods that are doing our work. And on the right, we have all the details associated with our service mesh, the service mesh control plane and the sidecar proxies. You'll probably have about double the number of containers running in your cluster that you had before. And maybe the sidecar proxies are a little bit lighter than your Tomcat app, but you should expect probably 1.6 or 1.8 times the compute. And that's a non-trivial cost increase for your cloud hosting. We were able to observe, control, and secure the traffic because we're proxying traffic between all the places. Now, should I use a service mesh? Here's some best practices. If you need to secure really high sensitive workloads away from normal workloads, such as PKI or PCI, service mesh can be perfect. If you're running untrusted workloads and you want to segregate those away from things, then a service mesh can be great. Now, in Kubernetes, we have namespaces, but a namespace is not a trust boundary, not a security boundary. So if we're running multi-tenant workloads and we want to carve out a namespace per tenant, then a service mesh can allow us to create those policies. If we need security in depth, if we need to be able to validate that all traffic flowing between microservices is HTTPS, then the service mesh may be great. And if we need A/B routing or a beta channel, then we can use the service mesh. It's not for free, but it can be really helpful in being able to observe, control, and secure the traffic in our service mesh. If you're watching this video later, hit me up on Twitter at Rob_Rich.
Hello, developers. I'm Dan Krantz, Chief Information Officer for Keysight Technologies. I'm excited to share some insights with you on intelligent test automation. Let me start with a quick story. Back in my early software engineering career, way back when Amazon only sold books and Netscape was the browser of choice, I developed some technology for a major international bank. It worked beautifully in my lab, so we shipped it over to headquarters in Manhattan. A few days later, my boss showed up at my desk with a paper airplane ticket in hand. Yep, back in those days, we used paper tickets. And his comment was, "You're going to New York, your software doesn't work, and the customer's not happy." I was shocked. What did I overlooked? I hadn't done exhaustive testing. We had limited resources in the lab, but if I was honest with myself, testing was mundane. I had other deadlines. And it turns out my technology used over a wide area network just didn't scale. It worked in the lab, but not over the wide area network. And we had unexpected results. And in a bank, you just can't have unexpected results. Fast forward to just last week when I met with my Linux engineering team. They're developing and deploying the standard Linux containers for our R&D teams here in Keysight. And I was attending one of their sprint reviews. They demoed a couple of cool new features, and I asked if they could make a few changes. Unfazed, on the fly, right in front of me, they made a few changes, rebuilt the image, and then, to my surprise, they launched an automated regression test. Last step, I asked them, "What is that?" And they said, "Oh, we've fully automated the testing of our Linux build because we hate two things. We hate disappointing our colleagues with buggy software, and equally motivating for us is we hate mundane work like manual testing." Their test automation platform that they're using is Eggplant. And it turns out it's the same visual intelligent test automation platform that my teams use on the code behind Keysight.com. It's the same test platform my teams use in our Salesforce apps and our Oracle ERP environment. My teams, it turns out, have rallied like crazy around this Eggplant platform. They're motivated to rid the world of bad software, to overhaul user experiences, and perhaps above all, to avoid mundane manual testing. So I'm excited to show you Eggplant in action, and there's no one better than my colleague Max Gerard to take us on that journey. Max, over to you.
Thank you very much, Dan. Hi, everyone. My name is Max Gerard, and I'm the Chief Evangelist and VP of Pre-Sales and Technical Consulting here at Eggplant, part of Keysight. And what I want to do for you today is go and talk to you about the DAI, or Digital Automation Intelligence Suite, which really allows you to go and test the functionality, usability, and performance of any application whatsoever. Now, Eggplant can really be used to go and test any device, any platform. And you can see here on the left-hand side, I've got a model of an application. An example we'll use today is a mobile banking application. And on the right-hand side, I've got a real mobile device. And just to go and quickly show you here, this is one of the device labs that we can connect to, and we help many of our customers go and build. And you can see in here, we've got point-of-sale terminals, mobile devices, PlayStations, Xboxes, network routers, TV boxes, really anything that has a user interface, Eggplant is able to go and test. And anything we can make an API call to, Eggplant can go and test as well. So now let me go and explain to you what this model here actually is. Now, the areas here in dark purple, think of those as the screens in the application. And then the areas here in gray, think of these as the actions that a user can take on each of those screens. So on the account screen, we could go to current payment, savings payment, ISA payment, and then each of those actions takes me to a new screen that you can see here. And then, for example, confirm payment will go and take me to the payment confirm screen. And so what we have here is a digital twin of the application itself, with the areas here in purple representing the screens in the application, and the areas here in gray representing the actions that a user can take against each of those screens. And so now what I want to go and show you is how we can record a test case using the model, but then also how can I go and automate my exploratory testing using Eggplant's AI algorithms as well. So if I go to test case builder over here and then click on build new test case, I can just start clicking through the model to go and record my journey. So let's say in this case, I click on launch app, and then I go username, password, login, and then I go to current payment, and then I go to, let's say, account, sort code, amount, reference, make a payment, cancel. And then I'll go and give this test case a name, let's say test case underscore cancel payment. And then I come to my test cases over here. We can see that test case just there. I can then go click here on play. And then what you'll see go and happen now is that test case will start running against my device that you see here on the right-hand side. And as it's executing, what you'll see is that we'll highlight different areas of the screen in orange and in green. And this is where Eggplant is using its intelligent image and OCR recognition to go and drive the test. Now, not only can Eggplant look through the user interface using our intelligent image recognition and OCR recognition like a real user would, but we can also go and integrate with the object layer of the application as well, meaning we can test the full stack of the application. Not only this, Eggplant can also be used to go and make API calls as well. So you can see there in the space of just a few seconds, I've managed to go and click through my model to go and record a test case, and we've seen it there execute. And so what you can see there is you can really put Eggplant into the hands of any non-technical user that you might have in your organization. So now what I want to go and show you is how Eggplant can also go and automate to exploratory testing. So if I just go click run on this model that you see here at the top, then what you're going to see start happening is Eggplant is going to start exploring the application. But I don't know up front exactly what actions we're going to go ahead and do. And so you can see here we're launching the application. We go username, password, and then we're going to go log in. And what is happening here is Eggplant is using its 3 core algorithms to go and decide what the next best action to go and do is. Now, the first of these algorithms is called the bug hunting algorithm. So let me explain to you how that works. Let's say, for example, on the confirm payment action, which I'll highlight down here, let's just say for argument's sake that we find a bug. And on there is a text box and a radio button. Then what Eggplant will go and do is it will go and slightly increase the probability of us going to other areas of the application that have also got text boxes and radio buttons on, because maybe there's a pattern there. And then let's say we go to make transfer. And again, let's say there's text boxes and radio buttons on there. And there's also a bug that we find. Wow, we're really starting to go and find a pattern here. And so, of course, I've simplified the algorithm there, but hopefully you can get the understanding that Eggplant is able to explore the application to test it exactly as a manual tester might go and do, and then make adjustments on what we do next based upon what we're learning about the application. And that's exactly what you would do if you're a manual tester, right? You might go and do a test, or maybe you do 10 tests, and then you think, actually, I've learned something from those 10 tests. I'm just going to do a bit of exploring. I'm going to spend 5 or 10 minutes exploring about what I've learned to try and give more feedback to the development team. And so what we're really doing at Eggplant is trying to inject the intelligence of a human into the way that we go and do automated exploratory testing. Now, the second algorithm that we have is our test case algorithm. So if you remember that test case that I recorded just a moment ago, then what Eggplant is able to do is it's able to take those linear journeys through the application, but then go and add things that a real user might go and do against the system. And so a linear journey on an application like this might be to search for, transfer money to, select the amount, select the account you want to go and transfer to, and then click transfer. But in reality, it might be that just before you click transfer, you go, actually, no, that was the wrong amount. So you change the amount. And then you go, actually, that was also the wrong account for me to transfer to, because my colleague had said, can you transfer that to my personal account and not my business account? And then maybe you thought, oh, actually, I want that to go and be a monthly direct debit, for example. So you set that up and then you click transfer. And that's a perfectly valid journey for a real user to go and do against that system, but it's not necessarily one that you'd ever get the chance to go and test. And so what Eggplant is able to do is to take those linear journeys and then add in things like a real user might do. And that's often where you find all the bugs and issues, right? You know, all those linear journeys that people do or people test in their system, they work really, really well because they've been tested for years. And it's usually those ones where you do something that is in inverted commas out of the ordinary, but for your users, it's not out of the ordinary. It's just how they want to use the application. And so Eggplant is able to go and find all of those issues that ordinarily you might not be able to go and find unless you did it in a manual way. And then finally, the third algorithm that we've got is our coverage algorithm. And so let me just go and explain to you what this really is. So because we have this notion of a model, we can actually go and tell you all the different permutations that you have and have not run in your application, and go and tell you different coverage levels. Now, the different coverage levels that we have are nodes, pairs, extended, full exploratory. So let's just talk about a few of these. Well, node level coverage just tells me, have I gone and done that particular action, or have I gone to that particular screen in whatever order? And so you can see here, in this case, we've got 100% node level coverage because we've gone to every screen and we've done every action. But now if I go click on all pairs coverage, what we can go and see here is that it's going to tell me all the possible pairs of journeys that I can do in my system. So all of the things where I go this and then that. And if I just expand a few here, you can see some of these journeys. So, you know, payment confirmed screen, then go to the account screen, or back to your accounts, then current transfer, back to your account and current payment. And so because we have this notion of the model, we can go and tell Eggplant, go and run all of my possible pairwise journeys as quickly as possible. And you can see in this case, I've got 98% pairwise coverage. And because I've hit 91 out of 95 of the possible pairwise paths in my application. And the really cool thing is that even if I come back to my model here and I go and add a new action to it to go and do a certain thing, let's say we add something called delete user, all of my underlying coverage algorithms are updated. And so if I come to my coverage report over here, then click on view heat map, what we're doing here is everything in darker blue is really well covered and tested, but anything in gray, we haven't tested yet. And so we can see here that all of this application is really well tested, except for my delete user action that I just added. And so Eggplant is able to optimize where we go and test based upon where the risk is. And in this case, the risk is where those new actions are. So now I want to go and show you a full end-to-end user journey across both desktop and mobile. So let's just go click run on this now, and we'll see this test start executing. And I'm also going to go bring up my desktop system that you see over here, so you can see the test journey running there as well. Now, what you're going to see happen here, first of all, is we're going to go and start writing an email from my mobile device. And so if we go and see here on the right-hand side now on my device, we're just writing that email. And as part of this, we're also going to go and take a selfie, which we're going to go and attach to my email here, just to go and show you that we can do every action that a user would want to go and do against the device. So you can see here, we go to the camera, we then go and flip the camera around. And so you'll go and see myself appear on screen right now. Don't know if that's going to give me my very best angle, but there we go. You can see there, we go and attach that screenshot to my email there, click send. And now what's going to go happen is we're now going to go connect into my desktop machine. And we're going to log into my email client. That's the sort of journey you might do on the way to work, right? You might be on your phone on your email, you then get into the office, and then you go and start up your desktop client. This is a pretty valid test for someone to want to go and do on an email client. And as you can see now, we're now running against my desktop machine, and it's the same engine to go and run it mobile as it is against desktop and any platform. So no extra learning curve. And now what you can see is I've got two-factor authentication turned on. So then it goes and sends a text message to my phone. I then extract that 6-digit PIN out. We then enter that onto my desktop device, as you can see down here. And then we're going to go and find that email that I've just written on my mobile device on my desktop system. And so you can see there how easy it is for us to go and do a full end-to-end journey. And the thing to take away here is, first of all, it's the same engine that runs across both platforms. But secondly, the model is our representation of all of those platforms. And so rather than having a really complex open source framework where you go and glue together all of these different open source technologies to go and do your testing, where actually you'll find you'll spend more time maintaining that open source framework than you do actually doing testing. The model is the framework here. And so you can see here I have send an email to my mobile, log into my desktop, get the code from my mobile, then reply from my desktop. And so having lots of systems as part of a single model is a really, really straightforward thing for Eggplant to go and handle. Now, what I'll show you is how Eggplant is really easily able to go and integrate with your DevOps pipeline. And an example here, we're going to use DevOps as our pipeline. And what you're going to see now is we're going to start editing the source code of an application here in Eclipse. Then we're going to click here on commit, click on new commit, and then we're going to go and click on push to upstream. And that's going to automatically trigger a test in my DevOps pipeline that you can see here. And you can see now I've got a test running against my mobile device that you can see here on the right-hand side. Now, we're going to purposely make this test fail. And when it fails, we're going to go and message into my Slack instance. We're also going to upload the log file and the video and the screenshot into my Jira instance. And so you can see there now that that test has actually failed. And once that's finished, you can see the Slack message comes in. We go into my Jira instance and we can see there the log files from that particular test execution are stored here. So what you can see there is a full end-to-end DevOps flow where we're able to edit the source code of our application in Eclipse. That kicks off our test through our Azure DevOps pipeline. We then run the test. And then at the end of the test, we send a message into the Slack instance, but we also go and upload our logs into Jira. And that's because all of that's made possible by Eggplant's open RESTful API, which really allows us to integrate with anything. And you can see in this test execution here, not only are we testing mobile, but desktop machines stored in Azure as well as AWS. So Eggplant is able to go and test multi-cloud applications. And finally here, I want to go show you another example of some of the really cutting edge integrations that we're building here at Keysight between both Keysight technologies and Eggplant software. And so what you can see on screen here, you can see in the center there, a mobile device, which is being driven by Eggplant in the way that I just showed you. But in here, we've also got in the lower left, we've got a UXM wireless test set, which allows us to do 5G base station emulation and monitoring of throughput between the device and the base station. In the upper right, we've got a waveform analyzer, which allows us to go and take precise current and voltage measurements to allow us to see the exact power that will be removed from the battery when the device is being tested. And then finally, here in the lower right, we have a DC power analyzer, allowing us to test battery change and charging functionality of the device. And by integrating both Eggplant software and Keysight hardware, we're able to go and test the full stack of an application, all the way from the the low-level hardware components right the way up to the user interface. And so what this means is that we can do things like, well, go and tell me how my application behaves when I'm on an OK 3G network, and tell me how it also behaves on a really, really strong 5G network. And so rather than doing all of those tests in silos, we're now able to go and integrate our user interface testing with our ability to go and emulate all of those different environments and go and test the way the physical device goes and behaves. So just some really cutting edge technology integrations that we're now building. So that's everything I wanted to show you today. I hope that's been interesting, and I look forward to speaking to you all again soon.
Thank you, Max. Keysight has some great resources, everybody. You can see here, click through and get more information for you. But let me encourage you to not miss the chance to join us at Keysight's Live from the Lab for some additional insights on intelligent test automation. Wrapping up the session right now, I'm reminded of how the Viking warriors always paired a shield with their trusty sword. So as developers, you head back into battle, creating software and automating infrastructure with your development swords. Let me encourage you to not forget to grab your trusty shield of intelligent test automation. From what Max has shown, I now see why my developers are rallying around Eggplant. It's truly an amazing shield against bad software experience. Enjoy the rest of DevNet Create. Thank you.
Wow, what a great session. I remember during my early days of writing test automation, we had to write every single permutation, and it was so tedious and took forever. So it's great that there are testing tools to be able to do this for you and also give you coverage so that you know how much you're actually testing. So that's really no excuse to not test your code. So definitely, testing is very important. And speaking of testing, remember, we have the DevNet sandboxes. It is free Cisco environments, and you can find it at developer.cisco.com/sandbox. Eric, what's coming up next?
Absolutely. Next up, I'm excited about this session. It is going to be showing how you can take a couple of different solutions, bring them together to leverage both. So it's going to be showing how you could take something like a Meraki camera, grab some snapshots off of it, and actually feed that into some sort of an AI or recognition engine. And in this case, they're going to demonstrate how you can detect PPE and if people are wearing it properly. So let's go ahead and check this out.
Hey everyone, thanks for your time joining my session. I hope you enjoyed it so much. So what I'm going to show you is a very cool use case integrating AWS with our Meraki MV solutions. So what I'm going to show you is how to trigger a snapshot once a person is detected and how to perform a deeper image analytics through Amazon AWS recognition. I hope you enjoy it. Okay, so on the screen, you're going to see my workflow. The first thing that's going to happen is that the Meraki MV is going to detect a person on the screen. And that is going to trigger MQTT messages constantly to a Linux server. In my case, I'm using a Raspberry Pi, but it can be any Linux server, okay? That's going to act as an MQTT broker, constantly evaluating the MQTT messages that it's receiving. Once it evaluates that a person has been detected, that's going to trigger an API call through the AWS API Gateway Services. And that is going to trigger the Lambda function. What the Lambda function is going to do is to take the camera snapshot and send the image bytes to the Amazon Recognition Service. Amazon Recognition Service is going to evaluate the picture and to generate a deeper analysis, and it's going to return the response to the Lambda function. Lambda function is going to post the results into the WebEx room, and at that point of time, you are going to see the results yourself. So let's see how to configure it and how it works. So first of all, you'll have available this GitHub repo that I'll make available for you. One thing to note is that you have the Lambda model over here, so you are able to upload it. And then you'll have the MQTT trigger Python script that you'll upload to your Linux server. In my case, it's the Raspberry Pi, okay? What you'll need to do is to replace all the credentials with your own credentials. A couple of credentials here are the API key, the MV camera serial number, the base URL. It's not needed to touch, but you'll have to replace the AWS API URL, and you will find later what that is. And your MQTT broker address, that's the one that you're going to configure on the Linux server. As you can see, I've already uploaded the MQTT trigger Python script on my Raspberry Pi. Now I'm going to show you how to configure the MQTT broker once you already set it up on your Linux server on the Meraki dashboard. So you'll go to Cameras, you'll select your camera, you go to Settings, then to Sense, and on the MQTT broker section, you'll add a new MQTT broker. So here you have the parameters. I'm going to skip this piece because I already done it, but you can see that here I have my MQTT broker configured. In my case, I use the Mosquito. That's very lightweight and easy to configure. Then let's see the AWS piece. So once we have the MQTT broker configured on our Linux server and we added it to the Meraki dashboard, let's see how to configure the AWS services. So let's start with the Lambda function. So we search Lambda and we create a new function. We assign it a name. In my case, I'll use, for example, facemask_lambda. And I'll select the latest Python version. I'll hit create function. And now let's upload the zip file that I'll make available for you. You hit upload. You select the zip file and then hit save. As you can see, all the files and requirements are available over there. Don't forget to modify your own parameters with the AWS credentials on the main_plate.api file. Then let's hit on configuration and increase the timeout parameters up to 15 seconds because of all the time that takes to the API calls to be executed. So with this, we are set up with a Lambda piece. Let's now configure the API gateway. So we create a new API. We select REST API. And we give it a name. In this case, I'll assign facemask_API. And we hit create API. Now we create a new resource, in this case action, and then create resource. We will assign it a very simple name that's going to be facemask, and then create resource. And once this is done, we'll create a method under it. In this case, it will be a post method. Once the method is created, we'll assign it the Lambda function that we have previously created. In this case, is facemask_lambda. We hit OK, and we are not done yet. We now need to deploy our API. So we go to Actions, and we click on Deploy API. Then we assign a name for the deployment stage. I'll select production, for example. And the link or the URL that you are seeing over here is the AWS public URL that you will use for the API call. Coincidentally, this is the link that I told you that you're going to replace on the MQTT trigger script on your Python file, okay? Let's go to the fun piece. Let's see how this really works. So you run the script on your Linux server, in my case, my Raspberry Pi, and you see the MQTT messages popping up. The video expect a little delay because it's going through the cloud, but you can see that it has detected me in front of the camera and the function has been triggered. So once the function has been triggered, let's see if it sends the message to my WebEx room. And now you can see it has detected one person, and this person is not wearing a face mask. Let's try now wearing a face mask. So the MQTT messages keep coming. Of course, the video is a little delayed, but once I'm in front of the camera, it'll trigger the script. Now I'm in front of the camera and it has triggered the script again. It found a person now with the face mask. And let's see on the WebEx Teams what it looks like. And now, quantity of the detected people 1. If it detects more than one person, it's going to say what it looks like for each one. If one is wearing a face mask, it will tell you person number 1 is wearing a face mask. And if the person number 2 is not, it will tell you person number 2 is not wearing a face mask. And it can distinguish whether they are wearing a face mask with the nose cover or not. And you can see in the picture that the exact moment where it triggered the snapshot. I hope you enjoyed the use case, and I hope you try it by yourself. Thank you very much for watching my session, and take care.
Welcome back, everybody. Every time I see one of these demos of the power of the Meraki MV, not just the camera, but the software behind it and what it can do, it blows me away. Especially in the last year and a half, what is it, 2 years now? I don't know. Time doesn't seem to mean anything anymore. With looking at what the Meraki cameras can do, just simply detecting face masks is huge. And that is a massive thing for the COVID problem that we've been dealing with for so long. But it could be a huge impact to things like the healthcare industry broadly, or even like the retail 3 as a crowd problem. It can just solve for so many different things. And so while you're seeing these stories and you have other things you're thinking of, you can share them with us on social, #DevNet or #DevNetCreate on any of the platforms. And we got a lot more coming up here soon. Eric, how else can they connect with us?
Yeah, thanks, Jeff. So remember, all throughout the event, if you have any questions, we are there for Q&A live. So feel free to go on the right side of your browser. You should see the Q&A panel. You can ask us any questions you got. We'll get back to you with an answer. And you can also go down below, click the link to get into our real-time chat. And there's lots of good discussions going in there. We keep checking in there in between breaks as well and hearing all the good discussions. But first, or next up, I want to talk about Postman. So a lot of us have used that. It's a great tool when you're trying to explore APIs. But this next session actually introduced me to some cool concepts where you can actually use Postman to visualize and render and show some of the output in a very pretty way. So this is a really useful lesson. I'd check it out.
Okay, welcome to Quickly Visualizing WebEx Analytics using Postman. My name is Steve Greenberg, and I'm a technical solutions architect here at Cisco, and I'll be walking you through this demonstration. So just a little bit of background about me. I'm a TSA on the partner team, which means I do a lot of education for our Cisco channel partners around the collaboration technology, and I have a specific focus area on collaboration APIs. So what's our demonstration today going to be? Well, specifically, we're going to look at 2 things. One, that is the WebEx applications. Those are packed with a ton of APIs that are accessible to anybody who wants to analyze them. Specifically, we're going to focus on the video devices, which are packed with a ton of sensors that we can pull data from. And then secondly, I suspect that if you're in the world of programmability, you've used Postman in the past. And the data that comes out of Postman, although usually is simple JSON, with a bit of extra code using chart.js, we're going to turn those responses from simple JSON to pretty charts and graphs. Now, at the bottom of the page is a shortened URL that you can use to go to my GitHub repo, where I have all of the instructions and a little bit more details that I'm going to be able to go through in the 10 minutes that we have. So let's jump right into the code. So on the right-hand side of the screen, I actually have that GitHub repo that I was mentioning, and on the left-hand side, I have Postman. So specifically, let's start with step one. In step one, we just need to figure out what WebEx organization we are going to analyze. There are a bunch of options available to you, and I have some links in the code that you can go look at. One of them would be DevNet Sandbox if you do not have your own WebEx environment. Another, if you are a channel partner or a Cisco employee, we have the demo toolbox, which has a lot of useful data already populated to make this even easier for you. That's the site that I'm going to use. All right, now that I've figured out the site, I need to get my access token. That's pretty simple. If you go out to developer.webex.com and click on the Getting Started, you'll find a button here to copy down your bearer token. WebEx APIs use bearer tokens as their authorization method, and I've already gone ahead and copied down mine. Great. Now the next step is to get what we would expect, which is the simple JSON response out of our APIs. Where I would start with is workspaces. The workspaces are effectively where one of our video devices have been deployed. And that's what I've done over here. I've copied the workspaces API command, I've clicked send, and I get a basic JSON response. The JSON I'm getting is a listing of all the devices that happen to be deployed in this particular sandbox or demo environment. I happen to know that this particular video device, called the CX Desk Pro, has been on for a while and is going to be reporting back a ton of useful information. And again, I've taken that bearer token and copied it into the authorization bearer value. Great, now that I have the ID for a particular device, I've gone ahead and copied that and saved it to use in my next command. So the WebEx devices report back just a ton of data in them. And so what I've decided is to gather the humidity, because there are temperature sensors, humidity sensors. I can actually determine how many people are in a particular room using our people count method. But in this case, I said I'm going to do humidity, and I'm going to gather it over the course of a month. So I've set the from and the to dates, and I've said that I want to get a daily result of humidity. Now, I've already saved the response to save us a little bit of time, and you can see that I've got a bunch of responses that give me the humidity values over a course of time. So here's the mean value, the max value, and the minimum value on the first date that was given. Now, if I look at that raw JSON, it's kind of difficult for me to look at and be able to see those values over a course of time. So what I might try to do is actually try to run a test against it that's actually going to let me visualize that data a little bit better. So I'm using the PM visualizer command, and again, you'll find that here in the GitHub repo, to actually just print out a copy of the maximum value. And if I click the visualize button after entering that, you can see I now have a string of data. Now that's a little bit better, but we could certainly go one step further. So now this next version takes the same raw output and adds a bunch of HTML to wrap around that data. And the same results are true. I could use the raw JSON, or using the PM visualizer and this command, I visualize it, and now I have a very nice table that shows me the individual values over a course of time. Now that's a good step forward. does make it a little bit easier for me to look at these values over time, but we want to go one step further and actually create some graphs. So on Postman's website, which I'll show here, they do offer a bar chart that we can effectively take the data from. If I go to their bar chart, and I'm just importing their code, I can see that they're creating some random values and giving them some data back. And when I use their commands to visualize, I can see, there you go, I have a bunch of pretty graphs as the result of my test. If I copy this particular data back and follow the guide that I provided, you'll see that all I'm doing is manipulating the data a bit to, instead of being the data that was provided in this example, to be the data that we previously used. So now I'm, same thing, getting the humidity out of our WebEx APIs, setting the same dates, and then changing the test value to now be a chart where I've changed the labels and the values. And now if I click visualize, now I can see the humidity over time in a pretty graph, and I can actually set the color codes to be something interesting. So now if I think that a particular high value of humidity might be damaging to some of my electronics, I can actually see that over the course of time. So there you go. You can go out to the GitHub repo, get a sample code so that you can run this on your own, and you too can quickly visualize the data that you are getting out of Postman. Thanks for watching.
Hi, everybody. Good morning, good afternoon, good evening, wherever you are. I'm very excited that you've decided to spend the next 20 minutes with me on this talk. Today, we'll talk about Kafka real-time data streaming for network engineers. So first of all, who is this guy on the screen talking to me? Hello, my name is Eric. Very nice to meet you. I'm a principal engineer at A10 Networks, and I've been in the networking industry for over the last 20 years. Been working in service provider, public cloud provider, enterprise, and I'm excited and passionate about network engineering, Python, education, and also writing. So what will we cover today? Basically, Kafka is a beast to learn, but what we'll cover today are, hopefully in the short 20 minutes, is what is Kafka, and what problem does Kafka solve? How does Kafka solve those problems, and how can we leverage Kafka, as well as some demonstration and also next steps? They may not be in that exact order, but those are the big topics that I wish to cover today. And also, just as a reminder, because we have a short time frame, so all of the examples and code are all available after the talk for you to watch on this GitHub repository, as well as links to the demo videos. So what is Apache Kafka? Apache Kafka is a framework implementation of a software bus for using stream processing. And this project aims to provide a unified, high throughput, low latency platform for handling real-time data feeds. So there are several keywords in that statement, such as real-time data. It's in a unified location, so basically it's in the same location for all parties to talk to. And also it's high throughput and low latency. Those are very tall orders for a project to achieve. So let's see how Kafka does these. Well, first of all, who uses Kafka? Before we dive into the technical details, it's always comforting to know that you're not alone. And because there's so many large companies such as LinkedIn, Netflix, as well as Cisco uses Kafka, the development will continuously to evolve and also kept up with the latest changes. It is said that over 2,000 plus firms uses Kafka, as well as 35% of the Fortune 500 companies. And chances are, even if they're not using Kafka, they're probably thinking about it. And one thing that you'll know is these companies tend to be data-driven, user-facing web applications, and they're very sensitive to data loss, very low tolerance for data latency as well. So what is the background and history of Kafka? So Kafka is originally developed by Jay, John, and Neha back in 2008 while they were working at LinkedIn. And this was open source in 2011. And if you're wondering about the name Kafka, it's actually named after the author Franz Kafka. It was said that Jay was a fan of the author, and the author has a system that optimized for writing. So he created a system that's optimized for data streaming and data processing. The tool itself, the core is written in Java, but they have client libraries in Python, Golang, .NET, and so on. And the founders went on to co-found this startup called Confluent, and therefore a lot of the development and the ecosystem projects are sponsored by Confluent. So what problem does Kafka trying to solve? So imagine this: you have a web service, it's providing some information to the user, it talks to the backend database, and that's all fine. But then the user starts to request more information that may or may not live in the database. So you start making backend calls to another API for web services, display back to the user, and your application grows. The users thrill about it, but also you need to provide those information to other computer systems. So now you create an API front end for your web app, and now the list just goes on and on. You need to make additional web API calls. Somebody's calling your services more, and now you just have this jumble of mash of services between people calling your service and you calling other services. This becomes a really hard integration problem and just one service, right? In today's world, we have a bunch of microservices that interact with each other. So let's just say if you have 6 talkers with 6 receivers, that's 36 connections. And each of them, you have to negotiate, what protocol to use. Do you use REST? Do you use HTTP? Do you just transfer raw data? Or the data format? Do you use JSON? Do you use just other formats that may or may not be agreed upon between you and the other users? So Kafka is created to solve this problem. And I like this tagline of set data in motion. So how does Kafka solve this problem? So basically, Kafka solved this problem by being a massive buffer in the middle between your application producing the data and your application that are receiving these data. And the system lets you receive and transform this data from your source to your target, and generally referring to the producers talking to the Kafka cluster, and the consumer consume those information. And at the center of it are topics, which we'll talk about. The topics could be anything that you specify, and the producer will just write to that topic. You specify to the Kafka cluster, and the Kafka cluster will be responsible in arranging those data to be written to the right broker or server, and to the right topic, to the right petition, and so on and so forth. So if you think about Netflix real-time recommendation system or the Uber real-time location tracking and user demand search pricing, those are the kind of data in motion problem that Kafka could solve for you. So this is a pretty dense slide, but bear with me because I promise there will be more demos later on. Before we could dive deeper, we'll probably get we need to sort out some of the definitions that we'll talk about. So basically, in some of the important Kafka concepts and terms, we have events. Then events could also be called messages or records. Is it basically just something that happened, like a web click, a BGP neighbor going down, etc. Then since Kafka is run as a cluster, then we have sort of the managers, which are called zookeepers, as well as the server themselves that are responsible for storing information and talking to your producers and consumers. Those are called brokers. And then we have these producers and consumers. Basically, producers write data to the topics, and consumer reads those data off the topics. So we talked about topics a little bit. So topics are essentially a category or the name of a feed And each of these partitions, and all of these topics are broken down into partitions. And partitions are spread over different servers or brokers for redundancy and replication. And the offsets are basically just an integer to determine where the consumer have read those data in, because those data would come in order. And also, consumers could form a group, so for redundancy purposes, and Kafka is in charge of determining which consumer have already read the latest message in a consumer group. And lastly, in Kafka, you could decide how many copies of data that you would like to keep. So those are called the replication, and you will have replication factors for you to decide how many copies of the same data to be kept, and that you provide data redundancy, integrity, and so on. So here's a graphical representation of the Kafka cluster. We have the zookeeper that is managing the brokers, and within those brokers, you have the topics, and within the topics, you have each different partitions. And for all intents and purposes, you could think of a cluster as a group of machines, and the brokers are physical servers. One broker is one server, and together they form the cluster. Of course, for zookeeper, you could have multiple zookeepers for redundancy purposes. And a good example is if you create a topic and you specify 3 partitions and 2 replications, the zookeeper will be in charge of which broker to take those partitions in, and where the replication should be done on different physical machines. And the best part is Kafka takes care of all of these for you. As a producer, you just use the SDK, write to a topic, and Kafka will be in charge of keeping the data for a period of time, keeping the data redundant, as well as having the consumer read the data in order. So here's drill a little deeper into each of the brokers in the different topics and partitions. So here we could see that there's 2 topics, topic A and topic B, and each of them with a replication factor of 2. So we have 2 copies of the same data, and they're residing on different brokers. So for topic A, you would have partition 0, and that's being replicated on broker 2. So if you lose broker 1, then the topic A is still safe, and so on. So these redundancy and reliability scheme generally follow the 2n+1, meaning if you have 3 brokers, you could tolerate losing 1. If you have 5, you could tolerate losing 2. So the Kafka offset is a number that Kafka uses to make the current position of where the consumer or consumer group have read to. And it is just a pointer, it's just an integer pointer that points to the last record that Kafka have already sent to a consumer in the most recent poll. And this ensures the consumer does not get the same data or the same record twice. As mentioned before, this is very important to make sure the same record is not either not processed or being processed twice. If you think about something like a credit card processing, then you could identify with the need to keep a integrity of the data per topic, per consumer group. Okay, so let's look at some demo. As I mentioned before, I put all the useful links and all the example links, screencasts, videos into this GitHub repository. Basically, we're going to look at first how to install Kafka getting on the system, because we're doing testing. We have the same zookeeper and Kafka into the single server. And we'll look at the installation process and all that. And then we're going to look at 4 examples. The first example will be how to create the topic and testing to make sure the topic works. And the second example will be using consumer groups. So we have multiple consumers in the consumer group, and the Kafka will be in charge of load balancing messages between the consumers in that group. And we're going to have key value pairs to run in that message. And the message, typically have that key as in anything you want. This could be your username, your database submission ID, and so on. The third example we'll look at is the topic offsets. We'll look at how the offsets is being being incremented in Kafka, and they're being in charge of distributing it on a per topic, per consumer group basis. And the fourth example would just be a simple Python library that does the previous three examples, and but in a more Pythonic way. So first, let's look at how we could install Kafka. So this example is based on Ubuntu 2004 LTS. If you have a different system, there's also a link at the top for you to look at. If you have Mac, if you have different flavors of Linux, you could go ahead and consult that. It'll be a little bit tricky if you want to install on Windows, but it's definitely could be done. So first, what we want to do is we want to install Java because it's, the core system is written in Java. So we have, in this case, we install Java 8. And then we download the Kafka binary on tar on zip. What this has is a /bin directory that you could reference for all of the console commands later on. And it's recommended that you could, you could definitely type out the full path, but it's recommended that you add this bin directory to your path so that you don't have to type out the full path. And it's also recommended to create a data directory for Zookeeper and the Kafka. And we're going to go ahead and this is how you reference those in the configuration file for both Zookeeper and Kafka. So all the data within Kafka and Zookeeper are written to the disk, and therefore the implication is that you want to make sure that it's in a directory that is kept permanent and not being deleted every time you reboot. And here's the command that you start Zookeeper in console. Here's another command that you start Kafka in console. It is highly recommended that you start Kafka after you start your Zookeeper, and they're running at different ports. And here's how you produce your first topics. How do you produce your first topic? And you start your consumer, you start your producer, and on the topic. And then the next steps would be highly recommended if you want your Zookeeper and Kafka to start automatically after reboot. So here are the links for the playlist for the 4 examples. The first example we'll see is how we could create a topic and have the consumers and the producers working together. So here, definitely want to keep and make sure that your Kafka and Zookeepers are working. Then you have your consumer that's started via your console command. You subscribe to your topic of my first topic, and now you have your producer producing a bunch of messages in a customary hello world. If you look at the bottom, that's your producer that's producing messages, and you at the top that you see these messages. All right. Then we could look at the second example of how the consumers are, you can have multiple consumers in a consumer group. So here, we have the second topic that's being created, and we're going to clear that. We're producing a bunch of messages to that topic. And on the left, you see that now that we have a consumer group, and this first consumer is saying, hey, I want to consume all the messages from the beginning. So now I consume all the messages from there. And now I have a second consumer joining a consumer group, but it's not receiving any messages because all the message has been being processed by the first consumer. However, if I produce more messages to that the topic, you can see as I produce more messages that the messages are being low balanced between the 2 consumer groups. All right, great. Moving on to the third example. If you look at the third example, in this example, we're really focusing on the offsets. So if you look at the offset, it's 3, 7, and 5 for consumer group. And now what we're going to do is we're basically repeating what we saw in the last example for the first consumer group. And now you see the messages are being low balanced, and you see the current offsets are a little bit different between what we saw before and what we see now, because now we have more messages. So if we start a second consumer group, we could see that the consumer groups are receiving those messages. And if we check that consumer group, then we could see the offsets are a little different as well. All right, so let's move on to the fourth example. You're telling me, hey, everything looks great in the console command, but that's not what we use in the field. So yes, so now we could have a Python library that have both the producer and the consumer. And what we have is the fixed key. However, in the value, it's a JSON value that we're taking a timestamp just to illustrate the new messages. So now I produce 5 messages to that topic. At the bottom, you'll see the consumer group. And once I start the consumer group, I saw the previous 5 messages that's produced. And if I produce 5 more messages, and boom, there I could see those 5 different messages. So here's more network engineering use cases. We could use engineering Kafka for secure autonomous operations, Cisco's real-time ingestion, as well as the nano. If you're interested in knowing more about Kafka, you could check out these links for documentation, as well as the vast ecosystem of Kafka, such as Kafka Connect, Kafka Stream Security, and KSQL, and so on. I want to thank you for spending the 20 minutes with me and hope you enjoyed the presentation. And I'm excited to see what you could use Kafka for your application.
Wow, Apache Kafka does indeed seem like a beast, but thanks to Eric, he was able to show us how to use Kafka and provided very nice demos on how to get started. If you're interested in Kafka, definitely check out Eric's GitHub link so that you can get more information and the videos that he showed. Now, before we switch gears to the next topic, I just wanted to remind everybody, because it is a limited time for you to get this, is for DevNet Create attendees. We have 50% off of the DevNet exams, and we have 45% off of the Pressbooks. There are way more offers, so go to the offers page at cs.co/create21offers. Well, now our next topic that we have is automation. It's been a big topic here at DevNet Create. Why do we want to use automation? A lot of the times we want to do it for mundane tasks or repetitive tasks, or even some time-consuming things. And so, Jeff, what are other ways that you've seen automation being used?
That's such a good question, Denise. And it's something I love talking about. And I want to call out a specific group of people who are a part of this conference, not just attending, but also contributing to it. Our Cisco SEs. These are folks who are engineers helping customers and partners be successful in what they do every day. And I just want a huge shout out to those who've won Creator Awards, submitted projects, because they're a key part of the automation stories that we tell and that we can find out about to help communities and solve other problems for people. So there's a variety of ways automation can be deployed, and I just really want to say thank you to that community for being a part of this and supporting everything we do. So coming up next, we've got Marcel. He's going to be waxing poetic about some actually pretty funny examples of automation. We know that infrastructure things can go wrong sometimes or go a little sideways and be a little interesting. Automation can do the same. We should totally do more automation, but just know that it's not without its side steps too. So hopefully you enjoy. We'll see you back here in just a little bit.
Welcome everyone to this lightning talk on automation gone wrong, lessons learned from screwing up your network automation. My name is Marcel. I'm an API and programmability lead in the EMEA region here at Cisco, and that means I work with our large customers on everything related to programmability, APIs, automation in general. And I come from a programming background, starting to program at the age of 10, and have fallen particularly in love with the entire topic of net DevOps. And I've recently also written a book about that topic on using Python to automate your network infrastructure. Now, if we look at what you have to do on a day-to-day basis as an infrastructure engineer, there's all of these words, right? All of these things that we have to do, like rollbacks, like removing sites, updating DNSs, integrations, adding new ISPs, changing site names, setting up guest networks. And I'm sure you can come up with a bunch of more tasks that you need to do. And these tasks keep on piling up, while at the same time, we want to move faster and faster. And the answer that has sort of come out to do that is automation, right? We have all you're at DevNet Create, so you've probably all seen this pitch for automation where we say, hey, we're going from this circle of fear where changes happen very rarely, where all changes are big and all of these changes are complex. And we have a team that isn't very well practiced. The change is seen as a very high risk. We have problems occurring during that change. That change is seen as a failure, and then since no one likes to do failures over and over again, changes happen even less rarely, right? This is this circle of fear, that spiral of death that we sort of are in. And we have sort of said, hey, we can use automation, we can use this idea of net DevOps to go to a culture of change, where we can have changes happen very often, where all of these changes are very, very small. The team is well practiced, change is seen as low risk, problems occur during the change. Hey, that's natural, but we have a way to identify the problem quickly, and we have a way to resolve the problem very, very fast. And thus, even if there are problems during our change, we don't see that as a failure, but rather we see that as an opportunity to test our fallback mechanisms, and we can still do changes very often. No? This is the whole idea behind net DevOps, and might be sold on this already. So it's a nice Friday afternoon. You're here in EMER, Americas just came online, and you're just pushing one small change, right? Kicking off one automation workflow before you go into your well-deserved weekend. Now, during that weekend, you might end up looking at your phone, down at your phone, and you see something odd. Hey, there's a bunch of emails in your inbox, and there's a bunch of messages directed to you in your chat. And finally, there is a bunch of missed calls, because you know what? The little automation workflow you just kicked off completely screwed your network, and the Americas was out of your out of ISP or out of internet access. So automation allows us to do all of these workflows very, very efficiently, but that also means that if we do something wrong with our automation, well, we're kind of screwing up the entire operation, or we can screw up bigly. To say it in the words of Bill Gates, once said that, hey, the first rule of technology used in a business is that automation applied to an efficient operation will magnify the efficiency, right? If we do this, we can make things very, very fast. We can make sure that everything runs very, very smoothly, and we can do orders of magnitudes more of workflows in the same time. But the second rule is that automation applied to an inefficient operation will magnify this inefficiency. That means if you screw up something with your automation, you are going to screw up your infrastructure big time. So what can we do in order to avoid these, and what kind of workflows can we implement in order to avoid these total failures, right? What can we do to avoid you getting those massive amounts of emails, those massive amounts of direct messages, and that massive amount of phone calls when you're just rolling out a simple change? Well, if you look at a normal net DevOps pipeline, this is just an example of how such a pipeline, like the different high-level stages that such a pipeline can have. We have in the beginning the design changes, the testing of the changes, the rollout of the changes, and then at the end, the monitoring of these problems. Each of these stages, we can do things to make sure that in the case of a failure, we are able to recover faster, and we can sometimes even prevent failures from happening in the beginning. So the first of these things is in the design phase, go ahead and design your changes with rollback in mind. What does that mean? Well, the easiest way to say is, hey, we can just take a backup of our network configuration, of our device configuration, and here's 16 lines of Python code that can actually do this using netmiko to do that. So you can see here, this is the file, and if we go ahead and we execute that, can execute that, and what we get at the end is just a backup of our configuration. That looks like this. Now, this is a rollback mechanism, but this is not the ideal rollback mechanism because we will get all of the stuff, all of the things in there. What we can also do if you're using, for example, something like PyATS or Genie to define your network changes, we can actually use PyATS to build us not only the required configuration changes. In this case, we're adding a new interface with an IP address, a net mask, and we're enabling it. But we can also tell PyATS, hey, go ahead, or Genie in this case, go ahead and configure or generate the configuration needed to undo this change. So if that change, that specific change, was the one that caused you problems, well, you already have the rollback built in. So you can see here, this is the configuration change that was generated, and this is the unconfiguration that we could use to go back. Next up in our DevOps pipeline would be the testing stage. So we're testing our changes. We're checking that everything goes well. And here, make sure that you're actually testing. Funny story, there's some people that actually screwed up their production infrastructure because they forgot to flip the target environment from testing to from production to testing, and they deployed their testing changes into production. But make sure that you're testing what you're actually doing and that you're testing in a realistic environment, be it a simulated environment like CML or be it a proper lab setup. Make sure that you can test in a proper environment and make sure that these changes that you're testing and your tests are actually covering the changes that you're testing. Next step is then to roll out the changes. And this is sort of a second cousin to what I said in the beginning, where you want to be able to have these configuration changes. You want to have a way of rolling back those changes. And you want to be able to roll out changes fast. So you want to optimize for speed, especially in the case of an emergency, right? Especially if something is wrong, if you have to roll back, you don't want to wait hours upon hours for your automation to kick off and do its thing and reach all of the devices. You want that to be as fast as possible so that you can then go ahead and figure out what actually went wrong. So you want to optimize for speed. And especially if you're using SSH-based automation like PyITS or NetMiko, it's not that easy to optimize the speed of the operation itself, but what you can do is you can parallelize your execution, right? You can go ahead and do all of these different devices, for example, in parallel. Now, what you could do is you have a queue of jobs that you want to have done. So these are, for example, a configuration change that you want to apply to each of your devices. And each of these red boxes represents a job. And this job now contains the configuration change that you desire, right? In this case, we're again configuring an interface. It contains the connection information, and it also contains what you actually want to do. In this case, the job name, apply configuration. And then we can have a worker or multiple workers pick up those jobs, figure out, okay, I have to connect to switch 1 with these credentials and roll out these configuration changes. Let me go ahead and do that. Now, sounds extremely complicated. You might be wondering, how much does that take to do? Let's do that in 30 lines of Python code. So you can again go over here to the editor. So we first define the task. These are the functions that the workers will be able to run. So in this case, the apply config, which simply uses NetMiko again to send a set of configuration commands. And then we need a script to open up a queue. We're using RQ here, Redis queue. This is the configuration commands you want to do. This could, for example, also come from your single source of truth, from your templates. The connection details, they could come from an IPAM. And then down here, I just enqueue this job. And if we jump into the terminal here and do queue sample, you see that I now have a job with the ID, with this ID queued. And I can go ahead and start a worker node of our network changes. And then the final step is, of course, building a monitoring solution that captures everything, right? You want to have a dashboard like this that covers all of the data, that gets all of your data, so that you can roll out your changes and monitor that everything is good. With that, thank you very much for attending this session, and all of the source code is available on GitHub.
Welcome back. As you can see, automation can be really powerful when it's going as planned, but if you have something go wrong, it can be disastrous, especially if we rely on it 100% without having checks and balances. Thank you, Marcel, for reminding us that you should always have a plan to make sure that automation goes right, but if it doesn't go right, that you can recover from it. Do you have a funny automation gone wrong story? Share your story and use hashtag DevNet and hashtag DevNetCreate. Eric?
Yeah, I love that. And I love, one of the big mantras I always use with teams is fail fast. So that perfectly fits in. Things can go wrong in nature, so be prepared for them and know how to remediate quickly. And that's actually a perfect segue into this next section where we're going to dive a little bit into chaos engineering and talk about, it's a concept that's been used in a lot of online services over the past few years, but bringing it into the network infrastructure as well, and security more specifically, is how can you actually anticipate unanticipatable security issues? So They're going to talk through some concepts about how you can build some chaos into your security plans and make sure you're ready for just about anything. Let's go ahead and check that session out.
Good morning, good afternoon, good evening, one and all. Thank you all for being here in DevNet Create 2021. It's always a pleasure to meet and greet all our DevNet enthusiasts and have some of the best conversations with all of you. Thank you again for making it here today. Now we will be discussing about chaos engineering. Test your network security before someone else does. It is an interesting approach to improve the network software reliability with chaos engineering strategy. Well, honestly speaking, this will definitely going to bring some good changes the way network testing happens currently. Before that, I'll quickly introduce myself and one of my co-presenter, Utkarsh. I am Sayali, working as a network consulting engineer in professional services Cisco. I am passionate about learning and implementing different technologies, and hence I have been part of automation and data science related initiatives, along with the regular customer deliverables. So automation, network security, data science, these are some of my key focus areas, which is why I am here today in front of you talking about network security. Well, before diving straight into the session, imagine if I would have asked you, say, around 50 years ago or 70 years ago, which is the next thing that is going to break the market or which is going to bring some revolution to the industry. We would have never guessed that the internet is the thing that is going to bring this change. While talking about internet, there was good old time where internet was only for people, where people could search the images, search the movies, upload some documents on internet. Happy lonely world, we could say. But now with the advancement in technologies, newer and new products are getting introduced, manufactured day in and day out, and these are being launched into the market. And we as a consumer, we are using it every day in our life. But at the same time, these edge devices or IoT devices are opening more and more security vulnerability threats for the system or for the data streams, right? So I would like to mark a great code said by a great philosopher that if you are revealing the secrets to the wind, you should not blame them for being exposed to the trees, isn't it? So what else could be true during this current scenario? As you all must have observed that during this pandemic period or this time span, many organizations all over the world have faced security breaches. Let's take a look at some of them. You name it, and each and every company at some or the other point of time have had some of the major security threats or vulnerabilities in the network. Key point that we need to focus here is that most of these breaches happen during the production network. Well, as you can see, Capital One, Equifax, LinkedIn, and many other companies have had breaches during the production network. And what happens if these things happens? Obviously, this is going to reduce the valuation, data privacy, monetary loss, right? So we all agree with the fact that security is really very important. To bring security in our day-to-day transactions, technologies, and devices, we need something that can bring trust. So we are coming up with a new approach. We call it as a chaos engineering. Well, chaos engineering is something which is a discipline of experimenting on distributed systems in order to build the confidence in the system's capability to withstand the turbulent conditions in production. Oh my God, I'll give you in a very quick and simple format that break your systems on purpose. Find out their weaknesses and fix them before they break when least expected. Oh my God, this is scary, right? You must be thinking this is a crazy idea, Sayali, of injecting failures into the production system. Like, why do we need to break our own system? Right? So you'll be getting answers to this question in next couple of minutes. So before that, let's take a look at how our network system or network testing mechanism looks like every day. So nowadays, most of the network testing mechanisms are scenario based, or I would say hypothesis based. For example, if I know the test case A and expected output B, then there will be a scenario like that. But that's not the case in production network, as it is a very dynamic environment. Any constant changes, and it causes unexpected emergent behaviors and errors, and this will mostly lead to network downtime. So there is no testing mechanism to predict failures in the production system. And obviously this is going to results are usually binary, and they do not uncover new information about the application. So it's very difficult to predict these failures, right? And when downtime occurs in the customer system, it causes a whole list of problems. And all of them can be very, very costly to the organization. If the network is down for longer than few minutes, I'm mentioning few minutes, an organization can be losing or facing a lot of money in fines, maybe in penalties or SLA refunds, which eventually leads to further loss of revenue. And during that, customer is also experiencing some very worst case scenarios, because network failures happens in the production system that takes time to scale up after the network outage occurs. And this will obviously reduce the customer satisfaction and possibly even the adoption of new features. So if you're asking your customer to adopt some new features of your product, it will be very difficult for you to convince the customer, right? So this is the customer experience today that we are facing. So there might be few questions that are running through your mind. Why can't we reduce these network failures in the production? Or why can't we reduce the security breaches and downtime in the production? Why can't we just predict these failures proactively and avoid them in the future, right? Because there is a gap. There are some fundamental challenges for identifying the root cause and suitable readiness for failures that encounters in production network. The primary reason is the production network system cannot be replicated in a lab environment, both in terms of hardware as well as software diversity. Not only this, the infrastructure or the network is changing, and it is becoming a very dynamic system that leads it to difficult to control the complete network. And these constant changes are causing unexpected errors, which we cannot predict always. Also, it takes a lots of cost from an organization perspective to set up a testing environment and scale to a production environment. So let me ask you this question again. What if we conduct small, very minute failure testing scenarios in the production system, in the live production system? Is it making sense now? So this is going to build a confidence into the network, into the customer's network system. We need smarter ways to test systems continuously. And one strategy that is gaining a lot of popularity nowadays is chaos engineering. So Netflix has been using chaos engineering in their microservices and cloud-based production system to give a smooth user experience. Well, honestly speaking, we took it a step further to incorporate this into our security networking infrastructure. How we are going to do this? We are mainly focusing on three main components. The very first one, as you can see on the screen, is plan and experiment. So based on whatever network topology you have in your production system, you need to build a test case scenarios. It will get designed with the help of smart agents, or on yourself you can build a hypothetical one system that will help you to plan this experiment. For example, let's see if we could send some wrong packets from router A to router B, and we will calculate how the system is going to behave after that. Is there any downtime? Is there any latency issues? Or what exactly is happening when this particular test case we are running in production system? Once it is done, we are going to contain the blast radius. What do you mean by that is that we are going to execute a smallest, I'm saying smallest test case that is going to teach us something. And that will help us to create more and more such cases around the network. Once you find an issue, well, yes, job well done. Otherwise, you'll have to increase the blast radius until you are at full scale. So these are the three main steps that we can follow whenever we are working on chaos experiments. Well, honestly speaking, this is going to incorporate a metric of fuzziness as well with the help of machine learning. So this is a loop where you can, leverage this one particular test case scenarios into your system continuously after some time period, some time interval. And once you get the results, you can feed those results into your model again and again so that you will be getting a good machine learning model or a fuzziness that will help you to stop these network failures in the future. The advantage of this, we will get to know real-time testing, not only based on known test case scenarios, but also on random case scenarios. So we can use a random metrics to leverage that into the system. So these are some of the very important key takeaways or magical features we can see of chaos engineering that we can use whenever we are trying to experiment these things out there. Now, the performance of the network and conversions can be monitored regularly once you use this technique. The very first one is hypothesis. Obviously, you will have to create a hypothetical scenario or experiment with test cases, and you can run all of those test cases with particular time interval into your production network in real events and in production network. Also, this is a continuous process, so it's not like you are just going to trigger it only once. You can have it again and again and again and again once you get to know what are all the results that we are getting out of it and what is the exact metric that we can use it again to avoid this in the coming future. So this delta will get calculated and the system performance metrics will get generated. As a result of this chaos test or scenarios that we are designing can be used to analyze and generate some reports out of it or dashboards out of it that will help us to build a repository for the future use. And once again, it is going to minimize the blast radius. So benefits, this is a main part of it, right? So as a result, once we get this incorporated and start leveraging this in production system, there are going to be multiple benefits for both the customers as well as the organization. For customers, obviously, this is going to improve the service availability and durability, faster adoption of network features. If you're asking your customer to, adopt something, it will be very easy for the customers to take it positively, and there will be minimal network impact. But when we think from the organization perspective, this is going to reduce large losses in revenue. This is going to scale up quickly without losing any reliability of their services. And there is a wider coverage of test cases, which helps in monitoring, which will help you to improve the test cases and calculations and metrics during that period. But with the help of these magical features of chaos engineering, we will be able to secure our system from the threats or from the breaches that are happening around us. But what do you think? Chaos engineering is not only limited to the security. We have huge industry impact out there in innovation, education, development, government sector, and where not. So this brings us to the end of this session. As every technology comes with pros and cons, chaos engineering has its own. But I'm pretty sure we will be using this in different industrial impact in our day-to-day life. Thank you so much for your time. Have a good day ahead.
Warm salutations and welcome to today's talk, Efficient Network Deployments with Action Batches. I'm John Kukta, and I'm a product architect here at Meraki. Along with my counterpart, Corey Gwynn, I look after the heart and soul of Meraki APIs as a core part of the cloud platform. This talk is for folks who are already somewhat familiar with our APIs and who are responsible for large deployments. That might mean admins with more than 100 Meraki devices or more than a couple of partner integrations. This talk is also for folks who are developing software tools for service providers or managed services providers, or those who are developing paid applications, such as those that our ecosystem partners provide. In any case, if you need to optimize your API usage for efficiency, you should benefit from this talk. So, why are we talking about action batches today? Imagine the following scenario. You work for a national corporation with one headquarters, several secondary national offices, and thousands of branch locations in your country alone. On your office campuses, you manage everything from Meraki appliances to switches and access points to cameras, sensors, and more. At each of your branch locations, you manage a single Meraki appliance, but also usually several switches, access points, cameras, and sensors. In total, you manage upwards of 200,000 Meraki devices across thousands of locations. Where would you start? How would you track progress on this deployment? And how would you manage it over time? Well, this is a great opportunity to use the dashboard API, and given plenty of time, you might not even need action batches. But how many API calls might that take? Let's ballpark some numbers and bear with me while we do a little math. First, let's estimate that your config work amounts to 10 API calls per device, which is probably a more complex config. That's 2.25 million API calls total. Now let's also consider that you can run up to 10 API calls per second per organization. You have 6 organizations, so you can max out at 60 API calls per second. Let's presume you're really good at parallelization and that the average response time for each call is under 1 second, just to keep things simple. Let's also presume that nobody else needs to use the API on those organizations, so you're taking full advantage of your API budget. If you do run 60 API calls per second, then you should complete 2.25 million API calls in about 37,500 seconds, or about 10.5 hours. And that's presuming no mistakes, go backs, client failures, etc. We haven't even mentioned the additional time you'll need to prepare the configs themselves, like write the API client, track your own progress, and verify the configs, or deal with environmental factors conspiring against you, like Todd from security hassling you about leaving the building so he can lock up. Listen, Todd, it's crunch time. Also, if you have other folks using the API with those orgs at the same time, then it would take longer because those folks are sharing that API budget. If only there were a way to batch all of these changes. Enter action batches. Action batches are a Meraki dashboard API feature that you can use to condense up to 100 API requests into a single batch. Different batches can be run in parallel, and they can also be run as background jobs, which we call asynchronously. Each action batch is atomic, meaning that the whole batch either succeeds or fails. There's no in between. That's good because it means you can sleep easy if one succeeds. And if it fails, well, despite the code we write, we're all human, and it is easier to clean up mistakes when they're discrete and predictable. So let's revisit our math using action batches this time for the same theoretical deployment. Using action batches, conservatively speaking, we can condense 2.25 million API calls into action batches of 100 each. But again, let's be conservative. Let's say you average 75 actions per batch. In total, you'll have 30,000 action batches to execute. Again, it's still a big deployment. But you can run 5 action batches at a time inside of a single dashboard organization. And let's estimate that each action batch completes in about 10 seconds. So, considering your company's hypothetical Meraki dashboard deployment, your deployment split across 6 organizations, you can run 30 batches at a time. In that case, you're completing 30 action batches every 10 seconds, or to simplify, 3 batches per second on average. And each batch is 75 actions. So with 30,000 action batches to process, you could be done in 10,000 seconds, which is under 3 hours. So with action batches, you just reduce the runtime of your entire deployment from a hell of a long day, upwards of 10 hours, to a chill afternoon. You can go home, have dinner, resume that manifest marathon, whatever you want to do. Plus, you didn't consume your company's entire API budget for more than an entire day. If you're running some monitoring application that also uses the API, I'm sure those folks who manage that won't be too thrilled. Sounds better, right? Ultimately, your deployment is much more feasible with action batches. Next, let's answer how you can get started with action batches. Action batches are an API-only feature. You will not find them in the dashboard GUI. To create them, you will use the dashboard API, and you will need read-write organization admin privileges. An overall guide and detailed documentation are available on our documentation site, meraki.io. The key endpoints we'll leverage today are those that create and then return the action batches, so we can check on the status. And the docs for these endpoints are linked here in case you download this deck later. Let's look at the anatomy of an action batch. Every action batch has these components: organization ID to indicate which dashboard organization the batch will run on, confirmed, which is a Boolean that indicates whether the dashboard API should start the batch immediately upon submission or create it without starting it yet. In some cases, you may want to create it and then run it later. Synchronous is the next Boolean, which indicates whether the batch runs in the foreground, which would result in some blocking I/O for your application, or as a background job, which is generally preferred. And again, those background job, we call that an asynchronous action batch. Status is an object with information about the batch's status, such as whether it is complete, whether it failed, etc. And actions, which is a list of the actions you'd like the batch to execute. If we look at that actions list, every item in the actions array will have these components. First, resource, which is the relative URI to the API resource or endpoint that you're invoking in the action. Operation, which is the REST operation to execute on that endpoint. And body, which is the REST request body for that action, if relevant. So now you know what it takes to actually submit an action batch, but let's look at some tools available to help you get the most out of action batches. The first is our official dashboard API Python library. Using Python to interact with REST APIs requires the use of some library like Python's request library to handle the HTTP requests. However, instead of using the request library, you can use our official dashboard API Python library, which wraps all of our dashboard API calls into native Python functions so you can interact with the API the way you would interact with any Python function. Instead of mapping variables to complex JSON structures, which in Python would look like strings if you were using the request library, you can simply create your configs as Python dictionaries and lists, if relevant, and apply them using the library's Python functions. To get started, simply install it using pip install Meraki. Here's an example. This is real code of creating an action batch in the Meraki library by the request library. As you can see, in both of these, they're both written in Python, but on the left, this code uses the Meraki library, and on the right, it uses the request library. Using the Meraki library, we can keep those payloads, such as the actions list, as an actual Python list, rather than the JSON string, which we have to use if we use the request library. And of course, manipulating strings like that using the request library, that's a more brittle implementation, right? Much more difficult to change a single parameter inside of a JSON string than it is to change a single value for a given key in a dictionary or index of a list. Using the Meraki Python library, we also don't have to worry about headers or text encodings, which can complicate your deployment if you use the request library. Next, let's look at another feature in the Meraki Python library that makes creating action batches even easier. The Meraki Python library also offers a built-in batch class, which enables you to create properly formatted JSON actions for action batches using the same structure as the library's Python functions that directly invoke API endpoints. So let's demo the batch class. Here we have a switch with a default configuration. Port 1 is in trunk mode with the native VLAN 1. First, we'll use a Python script that invokes the Python library to change the port to access mode with VLAN 10. Script is pretty straightforward. We're importing the Meraki library. We're initializing the dashboard session and a couple variables that we will use. Then this is the command to update the switch port, and then this will print the response. And it'll do little JSON dumps to format it, make it look pretty. So pretty quick, already done. So we see this response port ID, and it was updated to VLAN 10 and type access. So we refresh this page, and we'll see that the dashboard is now reflecting the changed config. Now, that's fine. But if you want to use an action batch to do this instead, then you would need to create that action in the format that the action batch expects. And that's where the batch class comes in. Invoking the equivalent function in the batch class won't change the config or submit any API requests. The code is virtually identical, but the function instead returns a properly formatted action that you can submit in an action batch. This is the function that will create that JSON structure for you. This means that translating your existing code to action batches is easier than ever. Let's compare these two scripts. They are virtually identical. You can see that most of the characters don't even change when I switch between the two, and that's by design. In this one, however, it will not actually run the function. So just to verify, let's change this back to 10, or rather back to 1. And now let's run this dashboard batch switch update device switch port action, and we'll see that it does not change the config. Instead, it simply gives us this JSON structure that we will use in order to submit an action batch using that action. And it's already formatted for you. You didn't have to manipulate any Python strings. It just created it. And the config did not change. So we've used the batch class to create the action that we're going to use inside of an action batch. It did not actually change the config, which is good because we're not ready to actually change any configs yet. The next item is a new module called the Action Batch Helper. We already know that action batches are a powerful tool for streamlining your bulk configurations. But in our scenario, we need to submit 30,000 action batches. For this, you'd need to write some client logic to split those actions into all those individual batches. And what if one of the batches in that huge list requires one of the earlier batches to succeed? you probably wouldn't want to submit the second one before the first one completed in those cases, right? You'd just be wasting your time. So if you need to submit them in a linear fashion, which of course takes longer, that would necessitate some additional client-side logic. The action batch helper makes it easier to work with action batches at massive scale, handling these concerns for you when you have tens or hundreds of thousands of configuration changes to make. The key features of the action batch helper are that it creates discrete action batches of a custom size from an arbitrary list of actions, submits the batches only when there's room on the organization's action batch queue to run them, allows for simultaneous or linear batch submissions, depending on what you need to do, and it optionally generates a JSON preview of the entire list of batches. So let's demo the action batch helper. This demo uses an organization that has 603 networks. In each network, we're going to rename the first SSID, then rename the network, then change the network time zone. All told, in this smaller demo, that's 1,809 actions, which we're going to split into action batches of 75 each. The batch helper is going to do that work for us and then handle putting them on the queue until they're complete. Let's look at just one of these networks to observe the changes. First, we can see the network name, and we can see the time zone. Then on the SSIDs page, we can see the name of the SSID. And those are the things we're going to change. This demo script is available on GitHub, so I won't spend too much time detailing it. I will simply run the script, which will then do the work. And we'll look at the output together. So first, it's validating all of the input from those actions that we've created. And of course, it used the batch class to create those actions more easily. It then confirmed that we were ready to actually start submitting the batches. It checked the batch queue for that organization. It saw that there were 0 active action batches, and it submitted the first batch. Now, this one does not require any sort of linear submission, so it's doing them in parallel. And then it started creating the next action batch, and it showed that there were 24 action batches remaining here. Confirmed against submission, and then checked the queue and saw that there was 1 active, of course, which we just submitted. Then it submitted the next batch, and it continued in that fashion until it eventually filled up the queue. Then it waited a few seconds to check, and it submitted the next. And we can see that this went through a total of 25 batches, submitting them, confirming that there was space on the queue to actually start them, and now we only have 5 remaining. So it's doing all of this automatically for you. This means that you didn't have to write your own logic to check that there were any available space on the queue, or to split that huge list of 1,809 actions into batches of 75 actions apiece. And it's completed now. So we can see that it's complete, and in this case, there were no failures. So if we go back to this settings page, we refresh the page, we should see the network name changed and the time zone changed. And it did. Back to Los Angeles. If we look at the SSIDs page, then we can see that the name of the SSID also changed. So we just got that done across 603 networks in no time at all. Pretty cool. We just published this module on GitHub, and I hope you'll find it useful. To recap, what did we learn today? About action batches, why to use them, what they are, their anatomy, then some helpful tools. Our official Python library and how to use it to submit action batches, our library's batch class to simplify creating actions for action batches, the action batch helper module, and how to use it to submit action batches at massive scale. I hope that you now feel empowered to take your deployments to the next level, and that I've helped you to be more efficient when operating at massive scale. Thank you for your time.
Hey, everybody. Wow, this has been a great day. Day 2 for the Americas here just wrapped up. Last sessions, we've got a closing here in just a little bit. Before we get to that, we just wanted to say thank you. It's been a lot of fun being a part of the community, being here doing this co-hosting stuff. And Denise and Eric will be up in just a minute, but I know Debbie wanted to say thank you to everybody. I mean, he's here, she's here, they're here hanging out with all of us today. It's been a blast. From Twitter to the communities out there in the public to our Q&A and the chat, everyone's been engaging and been part of this. It's been so much fun. I've been a blast hanging out in my TARDIS, or I mean my shed here in the East Bay. We'll figure out where we're going to go next after this. But it's been so cool to see all the stories everyone's been sharing, including things like just motivation and inspiration. So I know Michael, for example, put out there that he's been inspired from DevNet Create to go pursue his DevNet associate. And that's awesome. Like, I hope, Michael, that you get that, or that you're ready for it at CLUR this year. That's really cool. It's amazing to see what motivates and excites everybody. And you never know. You'll watch a conference like this, you'll see a session here and there, and something will just trigger, and you go like, you know what? I can do that. I can go pull that down and make that happen. And I think that's what makes attending these things so much fun, is not only do you see all the content, but you get to be around all the people that motivate you and get you excited about doing that next thing. Denise, how do you want to wrap up today? What was really exciting for you while we've been here?
I mean, I too had an awesome 2 days, especially co-hosting with you and Eric. And I'm kind of sad that it's coming to an end. I mean, there were so many great sessions out there, and I'm sure and hoping everybody learned a ton of stuff, because I definitely did watching these sessions. I mean, if you want to connect with me, I'm on Twitter at Denise T. Kwan, and definitely, follow me. And with all the things that happened today and these last 2 days, let us know, what did you like? What did you not like? I mean, we also want feedback as well. So before we close the day, I wanted to remind people of a lot of different things. I mean, we have DevNet swag at the Cisco store. You can get the Snack Minute apron, that cooler. There's t-shirts, there's hoodies, there's lots of DevNet stuff. So if you want to represent DevNet, definitely go check out the store. Also, remember, just for Create attendees and for a limited time, there are discounts that you can get. 50% off of the DevNet exam. Remember, that is good for the core exam, which is needed for the DevNet expert certification. And then there's 45% off of the press books and other different great discounts that are available on the offers page, cs.co/create21 offers. Well, Eric, what are your takeaways before we close up DevNet Create?
I mostly just want to thank everyone. It's been so awesome talking with you all on social media. I'm at Eric D. Thiel on Twitter, in the chat rooms, in the Q&A. It's been great seeing everyone engage and take value out of those sessions and find little nuggets that they'll be able to go try out themselves. So it's so great to see the community come together. Throughout the 2 days, we've been talking about social responsibility and what we can do to make things better. So I want to encourage you all. The Bright Funds is still available. We're trying to rally everyone to help support those 4 key funds. And we want to make sure that we can all try and use some of our
No problem. And Eric's right. Like, trying to support these Bright Funds, when you contribute into the fund, it'll get dispersed to all these groups. They're fantastic, and they're having so much benefit for the communities that they all serve. And it's really motivating to see that happen. Now, also, I wanted to touch back on Tech for Good, because that was an amazing set of content. These interviews with people, SEs, and others in the community. They're doing things that are good for their own communities that they can associate with. And hopefully it's an inspiration for all of you to go find those things that you can help with. So coming up next, we've got the closing keynote. Grace and Taeyu will be talking all about being an agent of change and how everyone works together to do, just be better at tech in the world that we're in. That's gonna be an awesome fireside chat. Definitely keep an eye for that and kind of watch through that. It'll be amazing. So as we close out, my name is Jeff Bull. I just want to remind you at Jeff Bull Tech, you can follow me. We can have a conversation about these things, send feedback, all of that good stuff. And also a reminder for everyone who's been here throughout Create, all these sessions will be available for you as recordings on the 26th. No big deal. You'll be able to catch up on that and watch them. So don't worry about it. You can always come back to everything we've got. It's all good. Again, thank you all so much for being here. We really appreciate it. One last reminder, there's a little over 12 hours left in Devi Defend, so definitely follow up on that. I hope you enjoy the closing keynote. It's going to be a lot of fun. Follow us on social. We'll see you all soon.
We are now at the close of DevNet Create. Over the last 2 days, we've been able to learn, do, and build so much together. Having watched many of the sessions, I know you all have been inspired to dig deep into new technologies and develop new skills. What's also been amazing is to see how many of you are connecting, communicating, and building together. One of the things we hear often about our community is how collaborative it is. I think that's the nature of software. We are a group that wants to and needs to work together. It's how we build things that can become more than the sum of their parts. As I said at the start of DevNet Create, we are a global team of problem solvers. We are agents of change. Now, I'd like to bring your attention to another area that I know so many of you care about, helping others. Technology is such an empowering force. From access to information to the creation of new inventions, tech can be transformational. And we at Cisco and DevNet believe that more than anything, tech can be a force for good in the world, especially when we're all working together. To help discuss how the work we can do can address a higher purpose that helps people and our planet, I'd like to welcome Tae Yu to DevNet Create. Tae is the Senior Vice President within Cisco Corporate Affairs and leads Cisco's social investments and stewards our corporate social responsibility organization. Welcome, Tae. We are so happy to have you here. So Tae, please tell us about corporate social responsibility at Cisco and how that work supports the company's mission to power an inclusive future that benefits our employees, communities, and the planet.
So our focus is to really use the technology in a global environment so it's inclusive of everyone to address key issues. There's a million great issues that we can get engaged in, but what we did was coalesced around 4. One is economic development, education, critical human needs and crisis response, and then environmental sustainability and rejuvenation. So we focus on those 4 areas, and we set a really aggressive goal back in 2016 that we would positively impact 1 billion people with digital solutions by 2025. And every year we measure it and we come up with the numbers. And so we're already at over 500,000 people who are positively impacted. And we've also brought a rigor to this. And so we brought in PwC to actually do, an external limited assurance of those numbers. So they went through and did the typical sampling and came back to us and said, this works, this doesn't work. And we were also asking them to give us an assurance, not just on the numbers, but also that our work, our specific, intervention and focus had a specific effect, rather than saying we got together with 10 other companies and then claim that we were having impact. So that's how we're focused. And the technology becomes incredibly important because before it was a nice to have, and now technology is at the core of addressing everything from the most, the basic needs to humanitarian crisis. Because our initial reaction as human beings is to go and, send water and food and blankets and whatever we need to do, when in reality, it's really important for us to understand where it happened, who to send things to, what's really needed. And it's the technology, and particularly the communications infrastructure, that makes the most basic of basic needs, which is that.
Wonderful. I love the data-driven approach you're taking to that and measuring the impact. And as far as impact goes, particularly with the last 18 months, we've all been living through this global pandemic. Tell me how you guys have shifted your focus around that and what you've been doing around the pandemic the last 18 months.
So there's two parts to the pandemic. One is that it helped us accelerate what we would already do. And the other is to make sure that we were inclusive and enabled those who didn't have access to internet and collaboration technologies to have that. So for instance, you had our network academies, right? It's in 180 plus countries. And over 3 million students went through the Academy program last year. So a cumulative of almost 15 million people since it started. And what this does is teach people how to design, install, maintain networks, which is a critical piece. The network is the critical piece of economic empowerment. And what they've been able to do is work with the program, the content, and the partnerships that the universities, community colleges, high schools enabled them to be able to provide a blended hybrid work environment, hybrid teaching environment, so they can continue to teach over that period of time. And that's just one example of so many others.
That's wonderful. Tell me, there are so many, I've heard about so many different things that people can get involved in. And I know that for, my colleagues and friends and even myself, sometimes there are just so many opportunities. How would you sort of guide others in terms of how do you get engaged? How do you pick the thing to get involved in? What would your advice be to someone that's looking for, getting involved for the first time, as an example?
Yeah. So there's several ways to do that. I would say one is figure out, your core competencies. What are the things that you love to do, that you are good at, and that people could benefit from? So it's a particular skill, whether it is coding, whether it is mentoring, whether it's being a critical reviewer of a particular type of a product design. There's some things that are happening there. The second is make it personal, something you're passionate about, a topic that you care about, whether it's the environment or autism or, a local community, homelessness, those kinds of things. And then the last piece of it is really looking at how do I bring it together and create an environment that enables me to test something and scale it over time. So, a couple of examples is this. We have a global problem solver challenge. And, one of the things that I've been saying for the last decade is that we don't really know what the future jobs look like. We can look out 5 years, maybe 10 years in certain instances. But the reality is that we're going to have to create the jobs of the future. So one of the most important things that we think we need to do is, as well as imbuing the skills such as problem solving and critical thinking, collaboration, persuasion, communication, is a combination of hard skills and soft skills. But with that is innovation and entrepreneurship. How do we instill this entrepreneurship muscle and then enable people to practice it and exercise that muscle regularly so that they're very comfortable with it? And that's where the GPS challenge comes in, global problem solvers. And last year we awarded about $1 million in prize money. And it enabled us to give prizes in multiple categories, such as environmental sustainability and inclusion. So if you were looking at a couple of examples, one is Remora, and what they do is they're focused on carbon sequestering. So if you look at the realities of the situation, and we saw this up close and personal during the pandemic and sheltering in place. What we did is the number of Amazon trucks or FedEx trucks or UPS trucks all across the freeways were so intense because we were getting things delivered, because we've gone to this e-commerce environment, but they have to physically deliver this stuff. That's not going to go away because they're still going to use fossil fuels for many years to come. The question is are we able to sequester that carbon? So what this team did is they used it based on research of an individual who came out of University of Michigan. So when you ask the question, how do I get engaged? Sometimes it's connecting with your university or your community college and looking at entrepreneurs and getting on their team. So what they did is they came up with this solution of creating a carbon capture mechanism. And what it does is it attaches to the tailpipe of the truck, and they're able to capture the carbon, sequester it in this gravel-like, the molecules attached to this gravel-like substance, and then they are able to measure how much is in there, so whether they need to switch it to another sequestering device, measure how much carbon comes out, and then are able to either sell it to concrete developers or permanently sequester them in dried up oil wells. So when you think about this, this enables, for instance, trucks to be able to continue to capture that, but also be able to get and deliver things. So that would be one example. Another example is Jangala, which was a young person who was out there working in remote places such as Africa, and realized that connectivity was not available to them. And they created the Big Box, which is basically taking existing technologies that were out there individually, whether it's 4G, 5G, hardline broadband, radio frequencies, and being able to create a box that enables about 300 people at a time to have internet access so they can continue their education, continue to communicate with those they love, be curious about opportunities, and most importantly, at some point become an entrepreneur and be able to sell their products and collaborate in terms of development. So I think a lot of it has to do with what people are passionate about, and maybe I'm going to do some shameless advertising here, but what we do have is the GPS challenge. We have it every year. We would love to get judges involved in this, and there's multiple categories, whether it's environmental, whether it's social, whether it's inclusive, emerging technologies, all of that is in there. It would be great to get people engaged and be a judge. It's a good way to get to know some entrepreneurs and also to share some skills and experience.
Wonderful. What a great way to have a call to action for our wonderful community of technologists that are here. It's simple, easy way to sign up and actually get involved. I loved your thinking around just building that entrepreneurship muscle, and also just that cycle of being able to give access to people so they can learn tech, so they become entrepreneurs, and it becomes like this ongoing cycle of giving, contributing, and creating greater value within our broader community. I love what you're doing there. You mentioned that one of the other things that you recommend is to really find something that you're passionate about. What are you personally passionate about, Tay?
So right now, one of the most important things that I see is the homelessness situation. And you see entire families who are not able to survive, and many of them children living in cars and then trying to go to school. And then when schools closed, sometimes the school was a place a lot of children got their first meal, their major meal, because there's a school lunch program. Not just in the U.S., but also in India and other places around the world, the UN food program and USAID and all of that. So there's a lot of incentives to get children to schools. But homelessness is something that we at Cisco have been very, very focused on. There is actually a sleep out. It's a virtual sleep out this year. We used to raise money with employees and with partners, and a group of people would sleep outside. We did it outside of Building 11 in 2019 in the back of Building 9. And we were able to raise multiple millions of dollars for Covenant House. And then there is organizations like Destination Home. And what they do is they work with public agencies and private donors to come up with a playbook and an assessment of how you can address homelessness. The food bank is a great place that we've all been engaged with. We had employees who were actually seconded there. And they were able to look at their logistics and supply chain, because Second Harvest and Feeding America, for instance, as an example, is actually a distribution point. They're the ones who go, and you have to have a forecast of how much food is coming in, fresh food versus donated food, and then they distribute that to soup kitchens and churches. And so it was working with them. The year that they were seconded, they ended up, being able to save enough money to do an additional 2.4 million meals. So we like to put some measurements around the work so we know the impact that we've had as a company or with our technology. So Grace, it's just been a real pleasure to get to know you. And what I always find fascinating is when you get to know someone, you get to know what some of their passions are. And as we talk about this space, what are you passionate about?
I have been really passionate about diversity and inclusion for a really long time and have, started programs like mentoring rings at places like Microsoft and Atlassian. And, as I think about, sort of the global pandemic and how we're operating today, I'm sure that to some degree, some people are sort of struggling with like, how do I do that now in this completely virtual world? How do I find a mentor or a sponsor? How does that work? Any thoughts there from you around maybe work you're doing or ideas that you might want to share with our community on things they might be doing to help solve this?
Well, actually, that's a really great segue into something that we've all seen play out during the pandemic, which was that we're used to being able to connect physically with people who come over and are mentors or sponsors. You could, meet them. You either go to a school to mentor a young student, or you meet somebody in the office over coffee to talk about those things. But I actually think that there is a silver lining here in that with collaboration and the technologies that are available, that you're not just limited to where you're located and somebody you physically can meet up with. You actually have the ability to be mentored by almost anyone anywhere in the world. And the focus is on specific topics. Sometimes we get assigned a mentor, but they may mentor us on the soft skills. How to deal with certain things, but they may not be able to mentor us on a project. Think about the possibilities that are out there. If I'm working on a specific project, and what I really need is an engineering mentor who has a very specific skill set, let's say in coding, Python, that I could actually have more than one mentor. So I think that the technology can actually make the world bigger in terms of opportunity. So I think that that's something that we'll see happening over time. But the passion and the focus shouldn't change. It's just how we are able to achieve that can be opened up because of the technology.
Yeah, agreed. And this event is actually a great example of a virtual event which has the ability to facilitate networking across the board with people who may have never come to the event in person. And so we're connecting people globally right now in this event of DevNet Create right now. So from that perspective, I know we talked a little bit earlier about how to get involved. And it occurs to me that sometimes what's sort of daunting is this idea of getting involved in something really big. But I think we all have this opportunity of thinking about, sort of the snowball effect of starting really small and letting that effect grow as you collaborate and join forces with other people. Any other thoughts there in terms of like specifics for people to get involved? Just those baby steps, what would you recommend?
So there's several things. First, and the most immediate, is the DevNet Create Bright Fund. So you could get engaged and contribute to that. The other thing is, and it's literally right in your backyard, is that with Covenant House, there is about 2,000 young people who have nowhere to sleep. And so part of the awareness and fundraising we're doing as a company is to sleep outside. And we're doing it virtually. And what a lot of employees did was they got their kids involved just to help them become aware of the situation around homelessness, but also to raise money. And so you can literally sleep in your backyard in a tent, on your patio, with your kids, by yourself, with a friend, with your dog or your cat, and everything that you raise that's not matched by Cisco will be matched by John Morgridge, the former CEO and chairman of the company. So that's a great thing to get engaged. And then if you just want to browse through our website at csr.cisco.com, that would be a great way just to look at all the different projects there. And we would be more than happy to connect you with some of our NGOs and social entrepreneurs and their networks for you to get engaged.
Wonderful. Well, thank you, Tay, for joining us today and for inspiring us with the wonderful work that you're doing within your group for Cisco, and also, giving us some really tangible examples of how we all can get involved and contribute here. Thank you so much for your time and for just being an inspiration here today.
It was a pleasure. It's good to talk to you.
I want to thank Tay again for joining us, talking about the power of tech and the power of community to solve problems, from global warming to learning coding. And if you were inspired to action, I'd encourage all of you to take advantage of a new feature we have at DevNet Create. New this year at Create, we are proud to be able to offer the DevNet Create Bright Fund. Through this fund, we can speak as a single community to promote diversity in STEM and support the fight to end racism and discrimination through global education. Join us to celebrate the empowering nature of all developers. Find the link to donate on our website, developer.cisco.com/devnetcreate. Well, we've reached the end of another DevNet Create. I hope you all have enjoyed this event as much as we did in producing it. And even though we're closing out the conference, the real work now begins. I invite you, agents of change, to seek out your new projects, dream big, and build new innovations, solutions, and inventions. I'll leave you with a note of encouragement and advice that I received from a good friend. Shoot for the moon in all your endeavors. You may miss, but you'll still end up among the stars. So let's get to work. Let's connect, collaborate, and create. I'm so excited to see what you'll do next. See you soon.
That's wonderful, well done. You don't get anywhere unless you put yourself out there, you know what I mean? Do you want me to play anything for you?
Can you do yellow?
Look at the stars, look how they shine.